Hey everyone and welcome back. In today's video, we'll be discussing about the basics of Docker, the advantages that the Docker offers, which really makes it as one of the great technologies available, and also a small demo before we conclude the video. So let's go ahead and understand more about it. Now, before we go ahead and understand the advantages that the Docker offers, let's look into a typical installation of software workflow. I'm sure that most of you might have already experienced this with your workstation. Now, let's say that we have a Windows operating system and you want to install certain application or you want to install a certain game. Now, the first step is to download the installer. So installer would be a typical .exe file. Now, once you download the installer, you go ahead and double click on the exe file so that the installer starts to run. Now, during the middle of the installation, many of you might have already experienced that you get an error message during installation saying that certain files are missing or certain dependencies are missing, etc. So you start to troubleshoot the issue so that you understand the fix to solve this specific error message. Now, once you troubleshoot it and once you install a specific dependency, you rerun the installer and might be you get another error which might not be the same as the previous one. Now, again, you go back to the same cycle of troubleshooting it and rerunning the installer. Now, I still remember this type of workflow you typically see specifically when you used to install the GTA game. Now, it always used to say that there are certain DLLs which are missing, certain dependencies which are missing, and you had to go through this software workflow at least a time or two to make sure that you have all the dependencies and all the requirements to install the game. Now, this workflow that we were discussing over here, this is the end user workflow. Now, there is also a workflow related to the development. Now, let's say that this is a programmer who works very hard at developing a software. So he has developed this specific software. Now, depending upon the way in which he has created the software, it might or it might not work out of the box in the operating system. So let's say that he has created a software through Visual Studio. So it might work directly in Windows, it will not work in Linux, it will not work in Mac. And this is a pain for the programmer because if he wants that software to work in Linux, if he wants to make it work in Mac, it is really a pain. He might use Java, but if let's say he does not really wants to use Java, out of the box, it really becomes difficult for the developer as well. So what he can do, he can create this software, he can put it in a Docker container. Now he can deploy the Docker container in Windows, he can deploy it in Linux, he can deploy it in Mac. And he can be 100% sure that the Docker container software that he has tested in his local environment will work perfectly in Windows, it will work perfectly in Linux, and it will work perfectly in Mac and all the operating system which the Docker supports. So this really becomes much more easier for the developer to push his software to wide variety of operating system, and also all the dependencies which are required by this specific software, because during the second slide that we were discussing that software installation typically fails due to dependency issues, etc. He can put all of these dependencies within the Docker container itself. So once he deploys the Docker container to any operating system, it will work out of the box and the end user does not really have to do anything other than running this specific Docker container. So with this, let's understand what Docker is in a definitive terms. So Docker is basically an open platform. Now, once we build a Docker container, we can run it anywhere. We can run it in Windows, we can run it in Linux, we can run it in Mac, whether it is a laptop, it is in a data center, or it is in a cloud. Now it follows build once, run anywhere approach. So that basically means that once the software developer has built his own Docker container, he can run it anywhere. He can run it in Windows, he can run it in Linux, he can run it in Mac as well in a perfectly working condition depending upon the test that he has performed while he has created the Docker container. So this is the theoretical perspective. Let me quickly give you a demo so that we have a good understanding about this. So for our demo purposes, we'll be taking the example of NGINX. Now, NGINX is a very popular web server in the market. Now, we'll consider NGINX to be this software which has been written by an organization. Now, if you look into the technical specification of NGINX under the supported distribution, it does support Amazon Linux. Then you have CentOS, Debian, FreeBSD. Then you have the Red Hat Linux, SUSE, Ubuntu, etc. But it does not really support Windows. And this is the reason why I have chosen this specific web server for our demo purpose. Now, what we need to ensure is that if we try to install this in Windows, it will not really work because you will not have an exe file out of the box. So what you need to do is you can put this entire NGINX within a Docker container. And once you have done that, you can deploy that Docker container in Windows, Linux, as well as Mac. Now again, Mac is not supported here, but if it is under the Docker container, it will work irrespective of whether NGINX is supported out of the box or not. Now, the first thing that we'll typically need to verify whether the NGINX Docker container is available or not. So this is the Docker Hub website, and here you see there is a NGINX container which is available, and this is the official image. So let me click over here, and if we go a bit down, you see this is the NGINX official image, and basically here is the command to pull the NGINX image. And if you go a bit down, you will see various commands which are available in which you can run the specific image. So generally there are two steps which are involved generally when you use Docker. The first step is basically this specific Docker container image. It would be in a specific website. Now Docker Hub is one such website. So you have to pull this image, or I would say you have to download this image within your operating system where you want to start the container from it. Now, for that, you have the command of docker pull nginx. Now, once the image is downloaded, you can go ahead and start the container from it. So let's look into how exactly this would work. Now, let me copy this up, and from my Windows CLI, I'll paste the docker pull nginx command. So this command will go ahead and download the nginx image from the Docker Hub repository. Now do remember that before this command works, you need to make sure that you have the Docker daemon installed within your operating system. Now Docker supports Windows, Linux, as well as Mac. And basically, if you see over here, I have the Docker daemon which is running, and this is the reason why my Docker command works perfectly. So let's quickly wait for a moment for our image to get downloaded. Alright, so our NGINX image has been successfully downloaded. Now the next thing that you need to do is you have to start the container from that image. So for that, I'll write a simple command of docker run. I'll specify a port mapping. Let's say 8080 to the 80 of the container. Let me specify the container image, which is NGINX. So it has given us the long output over here, but if we quickly do a docker ps, then you should see that there is a NGINX container which has started up. Now in order to verify, I am in my Ignito mode, and I'll put 127.0.0.1:8080. And now you see it basically is showing me the index.html page of NGINX. So that means my NGINX is perfectly working in the Docker container, and I am able to access that within my Windows browser. So this is the great advantage of the Docker containers. You don't really need to worry whether it is supported or whether an application is supported in Windows or not, or whether application is supported in Linux or not. As long as you can put it under the Docker container, you will be able to run it in Windows, Linux, as well as Mac, or in fact any operating system where the official Docker daemon is supported. So with this, I hope you understood at the high level overview on what Docker is all about. Now one great thing, in fact two advantages we just saw. One was NGINX was not supported in Windows, but through the Docker container, it is perfectly working. And second is we did not really have to worry about installation of NGINX and taking care of all of the dependencies, etc. All we did was we pulled this specific Docker container of Nginx, and that container itself had all the required dependency to run the Nginx web server. And once we pulled it, we went ahead and started the Docker container, and that's about it. And this is the reason why Docker as a technology has become extremely popular. And typically, if you look into the roles of DevOps or SREs, having a good understanding of Docker is a mandatory thing which a lot of organizations are looking for. And even as a software developer, primarily because of such advantages that it offers, a lot of organizations are also mandating that the software developer should also have at least basic knowledge about the Docker containers. So this is the high level overview about the introduction to Dockers. I hope this video has been informative for you, and I look forward to see you in the next video.
Hey guys, and welcome back. So as part of our lab setup, we will be installing few tools that we will be using throughout our course. So one of the first tool that we will be using, it is called as the MobaXterm. So this is a very nice and sleek SSH client. So we can run SSH related commands, or we can connect to a server via SSH. So this is something that we'll be using throughout our course lab. So just click on get MobaXterm now, and there are two editions. One is the home edition and one is a professional. For our case, we'll be using the home edition, and within home edition there are two other editions. You have the portable and you have the installer. So you can select any one of them. For our purpose, I have downloaded both of them and we'll be using the installer edition. So you'll see the type is compressed file. I have already downloaded it and it is of type zip. So there are two files within the zip package. One is the installer and second is the dat package. So for our case, I have extracted both of them to my desktop, and we'll double click on installer and I'll click on run. So let's install this. This is quite simple. Perfect. So we have installed our MobaXterm client. So you see I have a nice shortcut on my desktop. I'll just click over here and click on start local terminal. And now you see I have my local terminal up and running. So you can type your Linux commands over here and it will actually work. So what I would want to show you is that there are certain commands that we will be using. The first is telnet. So this is one important command. Just type telnet and verify if it is present. Second is curl, and by default curl is also present. So I'll just do a curl on say dexter.kplabs.in. Let's verify, and curl seems to be working. And let's do a telnet on dexter.kplabs.in, port 80, and this also seems to be working. So these are the two important commands that we will be using, and definitely we will be using the SSH command as well to connect to our remote servers. So this is it about this lecture, a very short one. Go ahead and set up your MobaXterm, and I look forward to see you in the next lecture. Hey everyone, and welcome back. So we had a great introduction about what Docker is all about. So what we'll do today is we'll be installing a Docker container, and we'll look into how exactly the basic commands work. So for our lab, what we'll be doing is we'll be installing Docker for our CentOS based system. So I'm connected to one of my servers which is running the CentOS one. However, again, depending upon your environment, you can install it in Windows, Mac, Ubuntu, or even Fedora. So let me show you Windows also, because most of you might be running a Windows system. So in order to download Docker from Windows, just click on download from Docker store. And once you do it, there are two versions of Dockers which are available. One is the stable channel and second is the edge channel. So edge channel is something where you get the latest releases or latest features. However, stable channel is where you get a stable software which is well tested. So for your case, you should be using the stable channel, because even I'll be recording lectures in Windows and I have downloaded Docker which is of stable edition. So click on get Docker and your download will get started. So it is a simple exe file. So all you have to do is double click on the exe file, click on next, and it will go ahead and install. Once it gets installed, you will have to log out once and then your Docker will be up and running. So you will have this kind of a pop-up within your start menu. So this is the Windows version. Let me show you for Linux based version. So you have to run yum-y install docker-io. So this will go ahead and install Docker for Linux. Now one important thing to remember is that once Docker gets installed, only the initial installation process might be different, but after that whatever commands that you will be running, that commands will be very similar across both Windows and Linux. So let me show you. Once I have downloaded the Docker in CentOS, I'll start the Docker service, systems cts data Docker. Okay, I'll start the service. So now it is started. You see it is active and running. Similar goes for Windows. You see my Docker is running in Windows as well. So the very first command that you can try is docker ps. So what docker ps basically shows is it shows you the status of any containers which might be running. Since I don't really have any running container right now, it is showing it as empty. So I can show you that in my Windows also. So this is my Windows command prompt, and if I do a docker ps, currently none of the containers are running, but that does not really mean that I don't have any containers. So if I do a docker ps-a, what ps-a will show you all the containers which are running or in stopped state or someone which have exited abruptly. So these are all the Docker containers which I have in my Windows. But when you talk about Linux, since it is a fresh installation, I don't really have any Docker containers installed. So once we have Docker up and running, what we can do is we can go to Docker Hub and we'll download a container image. So we will be using CentOS. There are various other images like Ubuntu or other ones as well which is available. Now within CentOS, you also have various builds like CentOS 7, CentOS 6. So what we'll be doing is we'll be pulling the CentOS 6 base archive, and this is something that we are really looking for. So if you go down, you see it has given us a command like docker pull CentOS :6 or docker pull CentOS :7. So if you copy this command, let me copy this and paste it in your prompt. I am putting it over here. If you're using Windows, then you will put it in the command prompt. So once I do this, it will pull the latest CentOS 6 based container. You see it has pulled, and after it pulls, it will give you a digest. So once you get a digest, it means that the container image has been successfully pulled. So if you do a docker images, it will give you the latest pulled image. So this docker CentOS image is something that we have pulled just now. So it is of size 194 MB only. Now this is a container image. Now if I want to launch a container from this image, I'll run a command docker run -dt and I'll specify the image ID. Okay, so only a very simple and short command docker run -d -t and the container ID. Just press enter, and again you will see you will get a digest similar to this, and this means that your Docker container has started. So now if you do a docker ps over here, you will see that you have one container which is in the started state, and you will have an image container ID and you will have a container name. Now once you have this, if you want to go inside this container, you have to type docker exec -i, which stands for interactive, -t. T will give you the TTY terminal so that you can type commands, and then you can either specify the container ID or you can specify the container name. Let's try for the container name. I'll say PEDANTIC_POITRAS, and next thing you have to do is you have to type bash. This is very important. You press enter, and now you see you are under the Docker container. And if I do a ls over here, it will show you all the aspects related to the Docker container image. Now same thing I can do for Windows also. Let me actually start one of the containers which I have been using. So same command, docker exec -it, put a container name. This seems an interesting name, laughing swirls. So let's try this out. Laughing SWIRLES, and I'll put a bash. Okay, so it is saying it is not running. So go ahead and start a container. Perfect. So now the container has started. Do a docker ps. The container has started, and now you can connect to the container. So once I connect to the container, you see I automatically got a root session. So earlier I was in my C drive users zeal. This is the Windows, and now I have a root. So if I do ls over here, I am under the Docker container. So one thing that you will see is that actually the commands that we are typing in Windows as well as in Linux, they are very similar. So this is the beauty of Docker. Now you can actually do everything over here, like you can run top command or you can install softwares with yum. So if you do yum install nano, it will actually install the nano text editor within your container. So consider this exactly as your Linux based operating system. Perfect. So if you want to come out of the container, just press exit, and now you are back to the original state. Similar in Windows, if I do a exit over here, you see I am back to C drive user zeal, and if you do a docker ps, the container is even up and running. Perfect. So the next command I wanted to show you is the docker commit. So let's say for example you actually set up a lot of softwares within the Docker container. So after you installed your Docker container, you set up NGINX or you set up some amount of softwares which took you around 15 to 20 minutes. And what you want to do is you want to take a snapshot of this Docker container, so that even if you mess this up, you can relaunch a new container from the snapshot itself. And this part is very easy. So if you do a docker commit, give the container ID and give the name of the container. So I'll say first commit, and I'll press enter. So what this will do is it will actually take a snapshot, and now you see you have the message digest. So now you go to Docker images, and you will see there is one image which is stored, which is called as the docker commit. Now if you want to launch a Docker container from this snapshot that you have taken, you can use the docker run -dt command followed by the first commit command, and it has executed. So if I do a docker ps now, you see I have one more Docker container which is up and running. So if I log into this Docker container, let me log in here. And if you note, we had installed Nano. So if I do a RPM QA on Nano over here, you see my Nano package is installed. So this is the very high level overview about Docker containers. Go ahead and install Docker in your system depending upon the operating system that you have. The installation process will vary, but trust me, installation is very simple. Once you go ahead and install it, practice the commands that we have done. Pull the Docker CentOS 6 base image, create a container, do something inside that container, create a snapshot, and launch a new container from that snapshot. So this is the basic about Docker container. I hope you got the basics about Docker container, and I look forward to see you in the next lecture. Hey everyone, and welcome back. So today we'll have a very high level overview about NGINX Plus. Now NGINX Plus is basically a paid offering of the NGINX open source product, which basically offers additional features which are not available in the open source versions. So definitely, as this is a paid offering, the additional features does come up with a hefty price. Now, there are a lot of additional features which NGINX Plus offers. Like some of the important features, one is the Web Application Firewall. Now, this is like a star offering of NGINX Plus. Lot of organization uses the NGINX Plus subscription because of this nice functionality of Web Application Firewall that it offers. Other than that, it does offer various other things like advanced HTTP as well as TCP and UDP load balancing. Now these are not part of the open source NGINX subscription. It comes with the NGINX Plus. You also have the feature of clustering. Along with, you get a nice GUI which helps you monitor the activity in a GUI way. So you don't really have to log into the server and look into the logs. It comes with a GUI, and NGINX Plus also comes with support which you can opt for. Now from what I feel, NGINX Plus by default is quite expensive, because in one of the organizations that I used to work with, we had evaluated and the price really goes a bit hefty. And what other organizations they try to do is they try to do things where the NGINX Plus features are not really needed. Now this is something that I am sharing from the real world perspective. We will be using NGINX Plus and we will be exploring some of the features of NGINX Plus in trial version only. So let me just show you. You have the NGINX Plus pricing per instance. So there are a lot of supports which are available, and you have the support which starts with $2,500 per instance per year. So this is a caveat. So you have to, you see the price per instance is $2,500, which is very expensive. So anyways, I'll leave it up to you if your organization is quite rich enough to buy, but it does come with good features. So let me show you. So these are the difference between NGINX and NGINX Plus feature matrix. You get it in the official website itself. So the more down you see related to load balancing, application delivery, and even security perspective, you have clustering where NGINX Plus supports. The open source version does not support. Media delivery is also there, and various other things. You see, NGINX Plus does come with a full-fledged support. So this is the basic about NGINX Plus. I did not really want to go in depth right now. In the next lecture, we'll look into how we can set up our NGINX Plus trial. Now, one important thing to remember is that I will not really suggest you to opt for trial right now in the earlier lectures. So when you go to the later lectures, where like active health monitoring, so these are lectures which are quite down, and when you reach those lectures, you can think about opting for the NGINX Plus trial. but currently this video is part of the setting up labs. So I would not really encourage you to set up Nginx Plus instance right now, and do it when you reach the lectures when Nginx Plus is really needed. So this is it about this lecture. In the next lecture, as said, we'll look into how we can set up our Nginx Plus in cloud environment. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. And in today's lecture, we'll look into how we can get a Nginx Plus based instance, because there are certain practicals like active health monitoring and all those which will only work in Nginx Plus. So it is important for us to understand on how we can practice those. So if you go to the Nginx websites, under the products, there is a product Nginx Plus. So if you just click on it, it basically will direct you to the Nginx Plus webpage where they have a free trial which is available. So if you go to a free trial, you have to register with your business email. So @gmail.com will not work. So you need to register with your business email if you want to subscribe for the trial from the Nginx official website. Now there is one more way in order to do it. So if you go to the AWS marketplace, this is provided you have a AWS account. By the way, we have already launched just few days back one of the amazing video course on AWS Solutions Architect certification for associate. So you may go ahead and look into it if you're interested. So anyways, coming back to topic, I put Nginx Plus under the AWS marketplace, and here you see they have Nginx Plus trial which is available in AWS. So it is a 30-day trial which you can launch. So it will launch a EC2 instance, or it will launch a server in your AWS. If you go in an AWS way, you don't really have to go into putting your business email, company, job title and all those things. You can bypass those stuff. Anyways, so what we'll be doing, we'll be launching our Nginx Plus instance in our AWS account. So I'll click on launch instance and I'll select AWS marketplace, and within the AWS marketplace I'll put Nginx Plus. So this is a free trial which is available. Do note that after your free trial gets over, it is $0.13 per hour. That is quite expensive. Anyway, so we'll select this. I'll make sure that I don't go beyond free trial of 30 days. And I'll really encourage you to also make sure that you do not go about 30 days. So I'll click on select. It is giving you the hourly chances. So basically the instance type that you select. So if you select T2.nano, that has, I believe, 512 MB RAM, the amount of charge is much more lower. However, if you go with a higher instance type which has more CPU, more RAM, then the amount of charge increases a lot. So you have a $3 per hour of charge for the R3 8X large. Anyway, so we'll be selecting the bare minimum. So here also it is saying try one instance of this product for 30 days. So this is a free trial which is available. I'll click on continue. Now again, the more higher the instance you go, the more you will have to pay for the Nginx Plus once it comes out of trial. For our case, I'll be selecting the T2.micro. I'll click on next. I'll click on next. I'll select review and launch. And this time I'll launch it with my private key pair, which is KP Labs. So this instance will automatically get launched and my key will be added to the EC2 instance so that I can log in with the SSH key pair. So I'll click on launch instance. So let's wait. So it is subscribing to the Nginx Plus product. So let's wait for a minute for it to get subscribed. Now, once it gets subscribed, one thing that I would really encourage you to do, just do what's my IP. It will give you the IP address of your internet connection. Once you get your IP address and once the instance is launched, do a whitelisting of your IP address within the firewall. So let's see. So I'll just name it as NGINX-plus so that we can know. Now currently the security group is allowing all you see 000, so it is allowing the entire internet. So what you should be doing is you should only remove 0000 and replace it with your IP. So only you can access your EC2 instance and no one else over the internet can do that. So click on save and we have a NGINX Plus instance ready to get used. So go ahead and try this out. If you do not have an AWS account, AWS does have a free tier account which is free for 1 year and they allow certain amount of resource that you can use for free. So I would really encourage you to register for AWS account because AWS is something which has been used in most of the organizations. And if you register for free tier, you might not even pay for anything, even for server launch. So this is it about this lecture. I hope this has been informative for you and I look forward to see you in the next lecture. Hey everyone and welcome to the Knowledge Portal video series. Today we will be speaking mostly about protocols. Now protocol is quite important specifically when you are studying about networking as well as cryptography. So let's go ahead and understand protocols with some kind of a simple use cases. Now, in order for a communication to happen between two entities, a common language is very important. And this is the reason why humans have languages which are used to communicate. Now, the reason why we are able to communicate is because we speak a common language. So I speak English and you must be understanding English, and this is the reason why the communication happens. Now, if two people do not speak a same language, then ideally the communication, a verbal communication is very difficult and it cannot happen. So when we talk about today's world, there are a lot of languages like English, Chinese, Hindi, Gujarati, Sanskrit, and there are a lot of languages which are available, and the people who wants to communicate verbally have to speak a common language, and this is same for computers as well. Similarly, so if you have two computers who want to talk with each other, so this is computer 1 and computer 2, then they need to speak a common language, because if computer 1 speaks entirely different language and computer 2 speaks entirely different, then the communication would not happen. And this is the reason why we have a set of standard protocols. So consider protocol as languages. So we have set of languages which are used in intercommunication, and all of the computers which want to communicate with each other has to follow a certain language, or I would say had to follow a certain protocols. So you might have already done this. Let's assume there is a computer 1 and there is a computer 2. Now you want both of them to communicate with each other. So what do? You have something called as a LAN cable, and you attach the LAN cable from a computer 1 to computer 2. And once the LAN cable is attached, there is a specific language or a specific protocol which is used in the local area environments, and through that common protocol the communication will happen. So there are various kind of protocols which are used for a specific use cases. So for file transfer, you have a very famous file transfer protocol. For DNS, you have domain name system protocol. Similarly, TCP IP that you might have heard, transmission control protocol, internet protocol. For secure file transfer, you have SFTP, and HTTP is something that you might have heard. So each of this protocol has a certain use cases, and for that use cases each of these protocols are used. So in combine, all of these protocols are combined together and it gives us a great internet experience. So when we talk about TCP protocol, which is Transmission Control Protocol, it has its own language and a own way of communicating. So you might have heard about TCP three-way handshake. Like before a communication takes place, there is a three-way handshake like SYN, SYNAC and ACK. So this three-way handshake occurs before any communication takes place as far as Transmission Control Protocol is taken care of. So if we want to understand how the protocol works, we have to understand the language which they use to communicate with. So this is the basic about the protocols. Definitely we can spend an entire course understanding each of these protocols, but in today's lecture we just went ahead and understand a high level overview on what a protocol means. And in the subsequent lectures, whenever it is necessary, we will take one of the protocols and we'll deep down and understand on how the individual protocol works. So this is it about this lecture. I hope this has been informative for you and I look forward to see you in the next lecture. Hey everyone, and welcome back to the Knowledge Pool video series. So in today's lecture, we'll have a high level overview in various kind of request methods which are available for the HTTP protocol. Now we have already discussed some of the request methods like GET, POST, TRACE, HEAD, etc. So this will just be a overview lecture. Now we already discussed that whenever a communication needs to be happening between a client and the server, in a very simple plain English language, a client can request for a file called as documentary.mp4. I want to watch documentary.mp4, and the server will send the file. So this is a plain English based communication. When you change the language from English to the HTTP, then the client will send a GET request, which basically means give me this file on documentary.mp4. So it also specifies the file name, and the server responds back with 200 OK. Now, depending upon the nature of the request, this specific part, this is called as the request method or HTTP request method. So this specific part will change. Like for example, if you are using a login form where you have to put a username and password, then you cannot really use GET ideally. You should be using POST. Or let's say for example, you want to write some file to the server, then you need to use a put. If you want to delete, then there is a HTTP request method called as delete. So depending upon the kind of operations that you might want to perform, there are various request methods which are available in the HTTP protocol. So as a high level overview, these are some of the request methods that we will be using, and these are some things which are used most commonly. Now GET is something that we are already aware about. It is used to retrieve data from a server. POST, it is used to send input data to the server. So whenever there is an input form which we are presented with, like a username, password, or a search query, so those can use POST. Head is exactly like GET, but it only is used to find the headers of the response, and the server does not send the actual response. Put is also an interesting method which is used to write a document to the server. Delete, as the name suggests, it basically deletes resources from the server. Options basically asks the server on which are the request methods which are supported from the server. Now we have already discussed that a web server can have a control on what type of HTTP request methods are allowed. Now generally web server will not allow this specific method like delete, for example. So delete method itself is not allowed. So depending upon the web server and the web server configuration, a system administrator can choose to allow or can choose to deny a request method. So this is very important to remember. Last but not least, trace. It basically echoes the received request from the web server. We have already discussed most of them. There are other HTTP request methods also present, like for example connect, and we'll not be able to discuss about all of them, but we'll surely be able to discuss about most of them which are more important in day-to-day communication. So this is it about the HTTP request method. One thing important to remember, just remember this term called as request method. So if tomorrow someone asks what is GET, you should be able to say that the GET is the request method. So this is it about this lecture. Go ahead and complete the lesson, and I hope this has been informative for you. If you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now we had a high level overview about various type of request methods which a client can send to a web server. Now in response to that request methods, a web server might send a certain HTTP status code like success or not found or some kind of an error as well. So these are called as the HTTP status codes, and we'll have a high level overview about the HTTP status codes as well. Now, as we already discussed, a client sends a request to the web server asking for get documentary.mp4, and the web server sends a response back. Now, depending upon the response which a web server formulates for this specific request, a HTTP response code is basically generated. So this specific code, you see 200 OK, is called as the status code. Now it might happen, let's say for example, a client send a request get documentary.mp4, and there is no such file called as documentary.mp4 in the web server. Now in that case, web server cannot send a 200 OK because there is no such file itself. So that is one possibility. Second possibility is present, like the documentary.mp4 is present, but the client does not have a permission to view this file or fetch this file. So that is the second possibility. So there can be lot of such possibilities which might be available. Or third possibility is like client sends a delete call, a delete request method on documentary.mp4, and the web server might not accept the request. So depending upon the situations, the response of the web server might be different, and corresponding to each response, the status code which will be sent will be different. 200 OK basically means successfully processed. You can have a 404 or 403 or 401, etc, etc. So this specific aspect is called as the status code, and you need to remember high level overview about various status codes which are available in the HTTP protocol. Now there are various response status codes which are available. One is the 100 series. So these are the 100 series which are called as the informational status code. You have the 200 series which are generally indicated as a success status code. 300 series are called as the redirection status code. 400 series are something related to some error from the client side, and 500 series relates to some error from the server side. So let's have a high level overview. So 200 status codes indicates that the action is received and is successfully understood, accepted and processed. So whatever action which has been received by the server from the client is successfully understood, accepted and processed. So this is what I call as the 200 status code. Now some of the example is 200 OK 206 partial content. So these are the very famous response status code. Now there are a lot of others as well, but we'll not be going too much in depth right now. Whenever a need arises in a practical session, we'll be discussing more about 200 series status code. Now 300 status codes indicates that client must take additional steps to complete the request. So whatever request that a client has sent, that request is not good enough to have a successful response. So there are some additional steps which a client must take, and these additional steps can be informed by the web server. So web server can tell a client that you should be doing these additional steps to complete a request. Now one of the famous 300 series status codes are generally part of the URL redirection, and some of them is 301, which basically indicates that the page is moved permanently, and 304, which is called as not modified, which is generally used in the caching mechanisms. We'll be discussing in detail about these status codes in the relevant practical session that we'll be having. 400 series status codes indicates that a client seem to have sent some request which is not an idle one or an error sum. So one of the very famous that you might have seen is 404 page not found, which looks something similar to this. You also have a 403 forbidden, which basically means client does not really have a permission to view this page. Now in case if there is some kind of a HTTP authentication like Basic Authentication or Digest Authentication, you have a 401, which basically will ask client for a username and password before the contents are being viewed by the client. Last but not the least, you have the 500 series status code, which basically indicates that there is some issue on the server side and it has failed to fulfill the request. Now there can be a possibility that there are some issues on the web server side also, and those issues are indicated by the 500 series status code. One of the famous ones is internal server error. I'm sure you are aware about that. You might have seen internal server error a lot of time. So that is one of the example. You have 504 gateway timeout. It like a client might be expecting, or there might be a timeout of 20 seconds in which the server is not able to respond. So you have a 504 gateway timeout. You also have 503 service unavailable. So these are a high level overview about the HTTP status codes. I hope you understood the basic about status code. Now we'll be discussing in detail whenever a right section comes related to each of the status codes. I hope this has been informative for you, and if you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now in the earlier lecture, we were discussing the basic about what protocols are all about. Now continuing our journey, today we'll be discussing the basics of HTTP protocol. So let's go ahead and understand more about it with a simple use cases. So on the left hand side, you have a client. Let's assume this as a web browser, a Google Chrome or a Mozilla Firefox. And on the right hand side, you have a web server. So this web server has certain files within it. Now there are three files that you will see over here. One is movies.html, second is documentary.mp4, and third is mysong.mp3. Now this client wants to play documentary.mp4, which is there within the web server. So in a very simple terms, how this would really work is the client or a web browser will send a request to the server asking that I want to watch documentary.mp4. Now, depending upon the settings configured in the web server will reply back saying that here you go, and it will send the documentary.mp4 file back to the client's web browser. Now, depending on what kind of player like VLC or HTML5 player, what kind of player a browser has, it will go ahead and play this documentary.mp4 which the server has sent back. So this is a very simple way of communication between a client and a server. HTTP protocol is very similar. So let's take example of HTTP protocol now. So a web browser will send a request to the web server. This time, instead of the plain English language which we had used, they will be using the HTTP language. So what a web browser will do, web browser will send a request which would be get followed by the name of the file, which is get documentary.mp4. Get basically means that I want to fetch this specific file. So web server will understand that the client wants to fetch the documentary.mp4. So the web server will fetch the documentary.mp4 and it will send it back to the client. Now in the response, you see you have 200 OK. 200 OK means your request has been successfully processed, and this is the documentary.mp4. Along with that, the web server will also have a header called as content type, which basically tells what type of content it is, which basically signifies that this specific file is a type video and subtype is mp4. So now the web browser will understand that the file which the web server has sent, it is of type video and mp4, and then it will play this specific file according to the player that it has. So a very simple way of communication between a web server and a client. So let's do one thing. Let's fire up our Wireshark so these things become much more clear to us. So let's do one thing. I have my Wireshark up and running. So there are three interfaces over here. I'm using Wi-Fi. So I'll be selecting the Wi-Fi interface. So I'll start the capture, and now let me go ahead and type dexter.kplabs.in. So this is a very simple page where you have a text information called as let's HTTP, and you have a simple kplabs.logo which I designed. So when you go to the Wireshark now, I'll stop the packet capture. Let's go down, and this is the GET request that was sent. Let's do one thing. I'll right click here and I'll select follow the TCP stream. So let's find it out, follow TCP stream. Perfect. So now what has happened is this is all internal happenings. You will not see this in a browser. So what happened was browser sent this request. When we typed dexter.kplabs.in, browser sent a GET request on the host dexter.kplabs.in. Now the web server which is running here, which is running on dexter.kplabs.in, received the request and it responded back with 200 OK. 200 OK basically means the request that my browser made is successfully processed, and along with that it sent the HTML contents back, which you will see you have let's HTTP and you also have the kplabs-logo.png. So this is what actually happened behind the scenes. Now if you'll see over here, along with the GET request, there are a lot of other HTTP headers which the browser had sent to the web server. Now all of these are very important for communication, and depending upon the headers which the browser or a client sends to the web server will respond according to that. So this is a very simple way of communication. So this response that you see over here, you can actually see in the web browser. So if you right click over here and do a view page source, this is the exact contents that you will see over here. So this is the high level overview about the HTTP protocol. In the subsequent lectures, we will be discussing about each and every headers which are part of a routine HTTP communication, so that it will give us a very solid foundation in the HTTP protocol. So if you might be wondering how these things are decided, and the answer to this is the RFC of HTTP protocol. So RFC basically contains the rules of a HTTP protocol, and these rules are being followed both by the client as well as the web server. And since the rules are followed on both the ends, the communication can proceed. So we'll be discussing more about all of these in the subsequent lectures. I hope you understood the basic about the HTTP protocol in a high level overview. And if you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now in the earlier lecture we were discussing about the HTTP protocol. So continuing our journey with it, today we'll be understanding our first HTTP protocol method, which is GET. So let's go ahead and understand more about it. So HTTP GET request is a very simple method which is generally used to fetch the information which is specified in a request URI. So the syntax is GET followed by the request URI. So if you're not aware what a request URI is all about, let's take a very simple example for this. So I'll open up my Atom editor, and there are three URLs which are present over here. One is dexter.kplabs.in/sample.html. Then you have dexter.kplabs.in/index.html and dexter.kplabs.in/video.mp4. Now in all of these, the first entity remains the same, which is dexter.kplabs.in. So you find that the server is the same, and then you have a unique resource which you are mentioning over here. So in this, the unique resource or a unique file is sample.html. In the second request you have index.html, and the third request it is video.mp4. So this specific parameter which signifies the unique file within the server is called as the request URI. So let's try this out. So I'll copy this and I'll paste it here. So now you have a sample.html file. Let's modify this and put index.html, and you have a different page load altogether. So you have a different page over here, you have a different page over here. The reason is because here you are calling a file or a resource called as sample.html, and here you are calling a resource called as index.html. So the parameter which calls the unique resource within the server, in this case it is /sample.html, is called as the request URI. Perfect. So going back to our presentation, GET method is used along with a request URI. So when you talk about one of the example, you have get/admin followed by the HTTP/1.1. So there are various HTTP protocols like 0.9 it all started with. Then you have 1.0, you have 1.1, and now even 2.0 is present. So depending upon the protocol language which your browser is speaking, the protocol version might change. 1.1 is a fairly common protocol version which has been used. And in the next line you have host followed by dexter.kplabs.in. So this entire request is interpreted as dexter.kplabs.in/admin. So this is what it signifies. Perfect. So this is a very simple GET request. There are various type of other GET requests which has been used, and one is called as the conditional GET request. So conditional GET method is generally used to fetch information with a specific condition. So let's take an example. You have get/sample.html. You have the HTTP protocol version, which is HTTP/1.1. Host is dexter.kplabs.in, and the condition here is if modified since Saturday 29th October 2017 followed by the time in GMT. So what this basically means, get me sample.html file from dexter.kplabs.in server only if it is modified after this specific time. If sample.html is not modified after this specific amount of time, then the web server will send a 304. It will not fetch this specific resource. If it is modified, then the web server will send the entire sample.html files content back to the client. So this is the conditional get. Let's talk about one more method, which is partial get. So a partial get method is used to retrieve only specific content instead of everything by default. So let's take an example. You have get followed by the request URI /movie.mp4, then http/1.1, and the host is dexter.kplabs.in, and in the third line there is one header which is added, which is range followed by bytes, which is 0/1024. So what this basically means that I don't really need the entire movie.mp4 file because it might be very big as well. I only need the first 1024 bytes of this specific movie.mp4 file. And this is what a partial get means. It means give me only partial information instead of the entire file. So this is very useful, and in youtube.com you will see whenever you load a video, entire video is not streamed, only a specific information is streamed at the start, and when you complete it, then next range of information gets streamed. So we'll understand this with an example in the upcoming lecture. And let's do one thing. Let's write our first GET request, not with the web browser, but with a manual handwritten request. So when you manually write things, it gives you a lot of satisfaction and it will help you understand things in more detail. So let's try this out. Let me check if I can zoom this more so that it will become much more visible. I hope this is much more visible now. So let's do a telnet on dexter.kplabs.in followed by the port is 80. So 80 is the port in which the web server is listening. I'll press enter. So it stays connected, and now since we are connected, we can write our first HTTP based request. So our request will be get/sample.html followed by the HTTP 1.1. So we'll write this, and now in the host we'll say dexter.kplabs.in. I'll press enter twice, and now you see the web server gave us a response saying that 200 OK. 200 OK means that this request is successfully processed, and it gave us a range of headers. After giving the range of headers, it gave us the actual file, which is this is sample file, and then it states specially designed for your handwritten GET request. And whenever you open this in the browser, you directly get this specific file. Browser in turn creates this specific HTTP request and sends it to the server. Now instead of browser formulating this request, we have actually written it in a handwritten format. So I hope you got the basic idea on how exactly the request is sent to the server and the response is received. So go ahead and try this out in your side as well, so that it will give you a much more better understanding on how things would really work. So I hope this has been informative for you, and in the next lecture we will be speaking more about the conditional get and the partial get, and we'll look into how that would really work. So this is it about this lecture. I hope this has been informative for you. And if you have any doubts, questions, suggestions, feel free to connect us at Twitter, Facebook, or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now today we will be speaking about partial GET request. So let's get started with a very similar example that we have been discussing since past few lectures. So you have a client, so consider this as a web browser or a telnet, and on the right hand side you have a web server which has a file called as documentary.mp4. Now when a client makes a request to the web server of type GET, so you have a GET request on the documentary.mp4, what the web server will do is that it will fetch the entire file and send it back to the client. Now, what happens if a client wants to see only first 5 minutes or first, let's assume 20 seconds of documentary.mp4? The client does not really want to see the entire content, just first 20 seconds of the content. So what client will do, along with the GET request, this is the first mandatory step. Client will also specify that I want to watch only first 20 seconds. So this is what client will specify to the web server. Now web server in response will say that here is the first 20 seconds of the data, and instead of sending the entire file, web server will send only partial part of that specific file. Now if you look into the response header, you have HTTP 1.1, and instead of 200 OK, you have 206 partial content. So this header specifies that the content which is being sent is only partial and it is not an entire file. So this is about the partial GET request. So going back to a theoretical perspective, partial GET method is used to retrieve only specific content instead of the entire file. So if you look into the example over here, you have GET request followed by movie.mp4. You have the HTTP/1.1 protocol. Host is dexter.kplabs.in and range is bytes 0 to 1024. This basically means only send me the first 1024 bytes of the movie.mp4. So once the web server receives this request, instead of sending the entire file, it will just send the first 1024 bytes of the file which is being requested. Now one important thing to remember over here is that the partial GET was introduced in the HTTP protocol version 1.1. So if you try to do it with 1.0 or 0.9, this will not work. It got introduced in 1.1. So if you want to have a partial GET, you need to use HTTP 1.1. So one important thing to remember. So this is about the theoretical part. Let's go to our favorite lab section so that we can actually see on how this really works. So what I'll do, I'll type dexter.kplabs.in and I'll type partial.txt. So if you'll see over here, the response has content numbers from 1 to 100. So these are all the numbers which is present in this partial.txt file. Now instead of using a classic telnet, this time we'll be using one more client which is very famous called as curl. So if you do a curl, let's say dexter.kplabs.in/partial.txt, curl will give you a similar output. So you see you got numbers from 1 to 100. Now curl is very famous for its flexibility and customization features that it offers. So I can actually print out the response headers only. So if you do a -i, it will only print out the response headers and not the entire file. So let me show you on how that actually works so that it becomes much more clear. Let me start the Wireshark capture and I'll fire up the curl. So you got a response. Now I'll stop the Wireshark packet capture, and this is the request which was made, which is get/partial.txt on HTTP 1.1. So I'll right click here and I'll follow the HTTP stream. So if you look into the request which curl automatically created, so whenever you type this command, curl will automatically formulate a get request for us. However, in case of telnet, ideally we had seen on how we can write a get request manually. So curl created a request, a get method for partial.txt. The protocol is HTTP 1.1 and the host is dexter.kplabs.in. And this entire request was sent to the web server listening on dexter.kplabs.in. Once the web server received this request, it responded back with a HTTP 1.1 200 OK. 200 OK means the request that was sent by the curl was successfully processed, and this is the reason why you have 200 OK. Followed by the other headers, it also tells us what is the version of web server which is being listened, which is NGINX in our case. After this response headers, so these are called as the request headers, these are called as the response headers. After this response headers, the web server, which is NGINX, responded with the actual content of the partial.txt file. So when you do a curl -i, what will really happen is that curl will only give us these particular headers. It will not send us the content of the file which was been requested, only the response headers. And you might ask, do I really need response headers? And the answer is very well. So let's print the response headers and see on what kind of information it provides. Now the first information it provides is whether the request was executed successfully or not. And since the response header says 200 OK, it means that this request was successfully executed. Then you have the server, which is NGINX. Now next important header that we'll be discussing is the content type, which says text/plain, which basically says that this file, the partial.txt or file, is of type text. Then it tells about the content length. It says that the file which is being requested is of size 292 bytes. So we can actually find the size of the file even without requesting it. This is very important. Okay, 292 bytes. And the last important header is the accept ranges, which is of type bytes. Now this specific header is very important when it comes to partial get request, because this signifies which ranges does the server accept. So let me show you so that it will become much more clear. So I'll do a curl -- header. I'll say range would be bytes 0 to 20 for dexter.kplabs.in/partial.txt. So now what this specifies is that curl will send a get request with a header range, and the range is bytes 0 to 20. That means I just need the first 20 bytes of the partial.txt file. So this is what it really signifies. So if I press enter, you will see instead of entire file, it is only sending me the first 20 bytes of the partial.txt file. So let's do one thing. Let's fire up the Wireshark so that we can see the request headers. Okay, and I'll press and you got the first 20 bytes. So now if I'll stop over here, let's go a bit down. This is our stream. I'll do a follow HTTP stream. So now if you'll see, when we entered this command, when we entered the curl command, we also specified an additional header which it should send to a web server, and this is the header. Now curl will add that header. So if you'll see over here, curl has added one more header called as range with bytes 0 to 20, and this is what the -- header command actually does. After this specific request was sent, the Nginx server sent a HTTP response, you see 206 partial content. That means the content that is being sent is of partial type. It is not an entire file. Along with that, it tells the content length of the new content which was being sent, and in the content range header you'll see byte is 0 to 20/292, which signifies out of 292 bytes of the partial.txt, only the bytes ranging from 0 to 20 have been sent back to the client. Now you can actually modify these value as well. So I can put 20 to 40, and now you see accordingly you get the information. Now this is commonly used in a downloading website. Like there are various websites where you download files from, and some of these websites will not allow you to resume file for free users. However, some websites will allow to resume files for free users. So how they actually do it is that, let's assume I am a free user and I have downloaded content from 0 to 20 bytes. So this much amount of content got downloaded and my internet got disconnected. So after my internet resumed again, I would ideally want to download file from 20, let's say from 20 to the last byte, which is, let's assume 290. However, since I'm a free user, what the downloading website does is it will not allow you, or it will not respond with the range header. It will ask you to start downloading from the absolute zero. However, for premium users who have paid money, it will allow the range header, and if you want to resume your downloading from the 21st byte, that will be possible. So this is how the file downloading websites can block free users from resuming the operations. So this is it about this lecture. I hope the partial HTTP GET method is understood by you. And again, if you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now continuing a journey with the GET method, we'll be speaking about conditional GET in today's lecture. So let's go ahead and understand more about this. Now conditional GET method is used to fetch information, however with a specific condition. So in this example, we have a GET method which is get/sample.html for the HTTP 1.1 protocol. Host is dexter.kplabs.in, and the condition which is specified over here is that if modified since. So this is the header, and there is a date and time associated. So you have if modified since Saturday 18th October 2017 at evening 7 o'clock and 43 minutes and 31 seconds of GMT time. So what this basically says that get me this file only and only if it is modified after this specific time. If it is not modified, then I do not really need the file. I just need the file if it is modified or if it is updated. So this is the basic about conditional GET. Let's get back to our labs and we'll understand this specific value. So when you do a curl on dexter.kplabs.in/sample.html,
This time I'll do a -i so that we can see the response headers. And within the response header, there is a very important header called as last modified, and followed the value associated with this header is Wednesday 18th October 2017 at 5 o'clock 19 minutes and 43 seconds GMT. So this response header basically tells us on what was the last time this file sample.html was modified. Now this is a very important header, because if a browser is, or if a user is trying to load this file again and again, and if the file is not modified, what a browser can do is browser can store this file in cache, and it can only supply the newer version if this last modified date has been updated. We'll be discussing this in the upcoming lectures, but for the time being, let's do one thing. Let's do a curl, and I'll say dexter.kplabs.in/sample.html. So this time I'll get a response which is of 2 lines. This is sample file, and it is specifically designed for GET request. Now we'll add an additional header with hyphen header, and this time I'll add a header if modified since, and we'll put a value which is present over here. I'll paste it and I'll press enter. Now here you will see you did not really get any response. Now the reason why you did not get response is because the file is not modified after this specific time that we have mentioned over here. If the file gets modified after this date and time which is specified, then the response will be received. So let's try one thing. Instead of 519, I'll say 518. So just a minute back, and I'll press enter, and now you will see I got the response back. Now the reason why I got response is because the file was modified after this specific time interval that we have been writing in our header file. So if you look into the headers, let's do one thing. I'll put -i. So in -i, you are getting the response because file was actually modified at 519. Now if I do 519 back here again, this time instead of 200 OK, you will get 304 not modified. So the web server is saying to the client that the file has not been modified after this specific amount of time, and thus the response is not received. The contents of this file is being not received. And this specific conditional plays a very important role during the caching process of browsers. So this is the basic about the conditional get. I hope you got what a condition basically means. So this specific condition is something that we are specifying. Like if this condition is met, then only send us the file. If condition is not met, do not send me the file. So this is what the high level overview of the conditional get really means. So this is it about this lecture. I hope this has been informative for you. Again, if you have any doubts, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching.
Welcome back to the Knowledge Portal video series. Today we are going to talk about one more HTTP method called as post. In order to understand post, let's take a simple example of a login form. So this is a simple login form. We all have gone across a login form when we used to enter a username and password, and it can either allow us to log in or it will say incorrect password. Now, during these cases, so during, let's say you open gmail.com and it asks you for a username and password. So essentially here you have to post some data to the application and click on sign in. Application will verify whether the username and password that you have entered are correct or not, and depending upon that it will either give you access or it will not give you access. So in this time, what essentially you're doing is you're posting some data to the application that is running on the web server. And during this time is when you use the HTTP post method, because get won't work here. In a nutshell, HTTP post is used to send some data to the server to be processed in some way. In this example, we are posting or we are sending username and password to the application so that the application can process it. By process, I mean validate whether our username and passwords are correct. If we take a look at the example of a login form, here instead of get, we have post method on login.php, and in the body section, we have user is equal to admin and password is equal to test 123. And this is one of the reasons why the HTTP post method is used. Now let's go to a lab section and see on how post is generally used. What I'll do is, let's open our Wireshark and start our packet capture, and click on start and go to Mozilla, and let's open a simple login form. I'll say login.html, and here it is asking for a username and password. So username I'll say Zfora, password I'll put my password, and when I click on login over here, it will log me in. So what essentially we are doing is we are posting our username and password to this particular web application, which will validate it, and it will either allow us or it will not allow us. So I'll click on login over here, and here you see it has allowed us inside. Now let's look at the Wireshark packet capture and see what has happened behind the scenes. I'll filter based on HTTP. It will be much more simpler. Initially, what has happened is our browser has sent a GET request to the login.html on the web server, and the server responded back with the login form. So this essentially is the login form. I'll close this. And now after we have entered the username and password, the request became post. So let me filter back to HTTP, and if we see over here, there is a post request. So if I follow the TCP stream over here, now after we enter the username and password, the request essentially became a post. And also here you see login is equal to Zilvora and password is equal to password. So my password was password in plain text, and this is the login button. Now server will validate it and it will either allow us or either it will not allow us. Now this essentially become a post request because in the body itself we are giving the username and password and sending it back to the server. And this is one of the reasons why the HTTP post method is used. So essentially if you see or if you think on where post can be used, then there are endless number of possibilities where HTTP post is used. Take for example google.com, where you have a search bar and where you enter whatever you want to search and you click on Google search and Google will present with you all the results. So during that time also essentially the HTTP post is used because you are posting some data to the Google application. This is it about the simple HTTP post request. I'll suggest you to try this practical also, follow the labs that I have given and try to do a Wireshark packet capture also. This is it about this lecture. I hope this has been informative for you, and I'd like to thank you for viewing. Hey everyone, and welcome back to the Knowledge Portal video series. And in today we'll be speaking about the HTTP head method. Now we already had an overview about the head method in the earlier lectures when we ran curl-i command. However, I decided to just have a dedicated lecture so that it will become easier for us to revise. So when you talk about a response which a web server will send, there are two parts in the response. One is the header fields and second is the message body. And this is very important because whenever a web server will send a response, if the first thing that it will show is the header field, and after the header field it will give us the message body if it is required. Now header field itself gives a lot of information. Like in here you see it is 200. Okay, that means the request has been successfully processed. Along with that you have various other important information like the date. So this is the date in which file was last updated or last modified. You have a content type, you have the content length. Content length is very important when you're sending a partial GET request, I hope you remember. And you have a cache control which is public. So these specific headers sometimes becomes quite important, and there can be a possibility where client just needs to know the header field and not the message body. So if a client just wants to know the header field, then the head method is something which will be useful. So head method is used to fetch only the HTTP headers as part of the response. Now, whenever a head method is used, so a head method is very identical to a get method, except that the server must not return a message body in the response. This is very important. Whenever a head based header is sent to the web server should send the idle response but without the message body. Now the example is very simple. You have a curl -i followed by the URL of the server for which you are sending a head based request. Perfect. So let's do one thing. Let's go ahead and I'll start the Wireshark as well so that it will become much more simpler for us to see on what exactly is happening. I'll start, and this time let me do a curl. I'll say dexter.kplabs.in, say sample.html. And now you will see it returned only the header fields. So I'll stop the Wireshark and let's put HTTP so that it will become much more simpler. So this is the HTTP packet corresponding to a curl request. So if I do a HTTP stream, now what you will see is what curl did. Curl, instead of sending get, it send a head /sample.html. So now in response to this, what a web server did, web server sent only the response header. It did not send the message body. However, if you remove the -i over here, you will find that it now sent the response body as well. And this is the basics about the HTTP head method. Again, this becomes very important because you need to know on what are the parameters which a web server is accepting for a specific resource. This also helps a lot in cache control as well as partial gets as well. So we'll be looking into this once we go ahead and work with web server Nginx in great detail. So this is it about this lecture. I hope the basic HTTP header is understood, and if you have any doubts, questions, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hi and welcome back to the Knowledge Portal video series. Today we are going to talk about HTTP trace request method. Trace is generally used in the HTTP protocol for debugging related purposes. So let's look into what exactly trace is. Now, generally internet is a very big network. So it can happen that you reside in India. So currently I reside in India, but the server that I'm querying to might reside in Russia or even US. So the request that I make, it generally can go through various proxy servers. In this example, there are two proxy servers through which the request is going. So when I make a request, it goes to the first proxy server, and from the first it goes to second, and from the second it goes to the destination server, and same goes via the response. So from the destination server, response comes to the cache proxy, to the first cache proxy, and back to the client. Now many times what happens is that whatever data that you send, a proxy cache can either modify the data or it can add its own headers, and due to that the response that you get back is not what you are expecting of. Now if we take a look at an example, so here you are sending a text file call as this is my data. Now it goes via multiple proxy links, and maybe proxy is modifying the information, and here if you see, this is our data, so my is turned into R. So it can be possible that the data which is reaching the destination server is already modified by the middle links. Now how can a client know what exactly is reaching the server? And this is basically done through the HTTP trace method. Now what happens in HTTP trace method is, whatever data the server receives, or whatever the request, the HTTP request the server receives, the server will send the same request back to the client. Now this will be much more clearer if I show you an example. So I'll go to my favorite Linux machine this time. Now let me open the terminal and let's do a trace. So I'll do a trace on example.com, and I'm getting a trace reply back. Now essentially what I'm getting over here is what I have sent through this particular curl request. So if you see, the user agent is curl, so that means this is the request that we had sent it to the server, and server responded with the same request. Now let's do one thing, let's add a proxy server over here and let's modify it according to the example that we have seen. Now I have burp suite over here, so I'll start a burp suite. I'll say java jar burp suite. Taking a bit of time, yeah, and it's ready. Now what we have is, we have a proxy server between a client and the server. Now we'll play the same request, which is trace. Along with that, we'll add a proxy. I'll say 127.0.0.1:8080. This is where the burp suite listens to, followed by example.com. Now this request is captured, whatever request that I have sent from curl is captured on the burp proxy. So if I go over here, this is the request that curl has made. Now let's modify this. Let's say the proxy server has add a via header and say theevil.com, ha ha ha, with an evil laugh, and let's forward this request to the example.com server. If I forward it back, and in the response, if we see, the via header has come, the evil.com, because the server which is running on the example.com has received this particular request and it responded with the same. So now it is possible for us to know that what is the data that the interception proxy has added. So from here we can see that there is a via header field, the evil.com, that might possibly be added by the interception proxy. Now this is one of the reasons why the trace method was introduced, where we can actually debug on what exactly we are sending from and what actually is received to the server. Now in the real world environment, generally trace is disabled because it leads to a lot of security related issues, and trace by default is disabled, or it is not allowed in the NGINX based web server. So if you want to try trace, then you'll need to have a Apache based instances. So this is it about this lecture. I hope this has been informative for you, and I'd really encourage you to try this out once more again. Thank you very much for watching.
Hey everyone, and welcome back to the Knowledge Portal video series. Now in the past few lectures we have been discussing about various HTTP methods like get, post, head, trace and many others. So today we'll be speaking about the options method. So this options method is generally taught at the last of the HTTP methods, and the reason why is something that we'll understand now. So let's go ahead and understand the options method with the use case which we have been taking since quite a while. So you have a client. This can be a web browser, telnet, curl or other clients, and you have a server. Now here within the server you have three files. Now one is the documentary.mp4, second is login.php, and third is the test.txt file. Now a web server has these three files. Now a client can generally send a request to the web server asking for one of these specific files. So for example, for documentary.mp4, a client may send a get request. However, when it comes to login.php, both get and post will be required because client will be logging in, and this is the reason why the username and password fields need to be posted back to the server. So for documentary.mp4, get method is quite useful. You do not really need a post method. Similarly, for login.php, get and post, two methods are very much required. When it comes to test.txt, then get method is sufficient enough. So depending upon the file which is being served by the web server, the HTTP methods which needs to be supported differs a lot. So when a client sends a request and the server sends a response, the overall methods that will be supplied over here needs to be controlled. So as we discussed, for documentary.mp4, get and head is sufficient enough. Head is also a very useful method. For login.php, you need get, head and post. So all three are required, among which get and post should be mandatory. And when it comes to test, you have get and head, which are important. So is there a way for a client to know that for a specific resource, what are the methods which are supported? So it might be possible that a web server is only supporting get method for documentary.mp4. So is there any easy way in which we can actually determine this? And the answer is yes, through the options method. So what really happens in the options method is that option method is used to describe the communication option for a target resource. For example, you have a very simple syntax where you have options / index.html HTTP 1.1. So what this basically will do is that it will show on what are the methods, HTTP methods, which are supported for this index.html file. Now this is something that we can send with telnet as well. However, we know that the curl is quite simple, and thus we'll be invoking curl, where you have curl -x. We'll be using the options header followed by the URL
and -i. So this will only print the headers. Perfect. So let's do one thing. Let's try this out so that it will become much more simpler for us. Okay, so what we'll do, we'll run a curl command. -x will specify the header or the method, which will be options, followed by the IP address. In my case, let me put one of the IP address followed by -i. So now in the response, you get there is a header call as allowed, and within this there are the methods. These are the methods it is saying which is allowed, which is post, options, get, head, trace. So these are the HTTP methods which the web server is allowing. So there are various other methods like put, delete. So those methods are not allowed for this particular web server. And if you might want to know which is the web server it is running Apache 2.4.6. So similarly, a system administrator might actually decide to not allow the options header at all. So let me give you an example. When you talk about NGINX as a web server, NGINX does not allow this options header at all. So it will not accept it at all. So let me show you. I'll say dexter.kplabs.in -i, and now you see it is returning back saying it is not allowed. So options header is not allowed in NGINX by default. The reason why is because of the security perspective. Ideally, this is why do you want an outsider to know what is allowed, what is not allowed in your web server? And this is the reason why NGINX does not support it by default. Apache does it, and this is the reason why I had a test server created so that we can check the options header in our Apache based web server. Now, one important thing to remember is that even if you're using Apache, make sure that you do not really allow options for the world to know on what are the HTTP methods which are allowed in your web server. Along with that, you can control, let's say for example, for login.php, you can control on what are the HTTP methods which will be allowed. Similarly, for if it is a documentary.mp4, you can control which HTTP methods which will be allowed in that specific resource. So this is it about this lecture. I hope you understood the basics about the options method, and I look forward to see you in the next lecture. Hey everyone, and welcome back to the Knowledge Portal video series. So we have our Docker up and running. So if you just do a Docker version, it will show the current version of Docker, and even here you will see it states Docker is running. Perfect. So if you have been following the guide, we have downloaded a CentOS 6 based Docker image, and we will be starting our first Docker container with help of this. Now, one important thing that I have decided to note this time is that whatever command that we will be doing it in the course, I'll just take a note and I'll share it so that you can directly copy paste it for reference. Otherwise, there might be some issues related to spelling mistakes or a syntax issue. So this is an ideal way of doing it. So I'll also do the same. So let's start. So we'll be starting a Docker container. So with help of docker run -dit, I stands for interactive, T stands for TTY, -p followed by 8080. So what this will do, this will map the port 80 of my Windows machine to port 80 of my container. Since NGINX is going to run in the container, -p 8080 is quite important. After this, we specify the repository, which is CentOS : the tag is 6. So CentOS 6 and the bin bash. So once I press enter, you get the ID, and if I do a docker ps, it will say that my container is up and running. So in here you see port 80 is mapped to the port 80 of the container. Perfect. So this is something that we wanted. Now we'll connect to this specific instance which got started. So I'll do a docker exec -it. I'll specify the container ID and I'll put bash. So now you will see I am inside the container. So since this is a CentOS based container, whatever commands that I'll be typing will be based on CentOS 6, or I would say a Linux one. So the very first thing, we'll just verify if the CentOS package is present or not. I'll do rpm qa grep nginx and it doesn't seem to be present. So let's go ahead and install the appel release. So this is very important because from this repository we can get the Nginx package. So let's wait for a minute. Perfect. So once this is installed, we can go ahead and install the Nginx. So I'll do yum y install Nginx. So the Nginx package is quite big actually, so it might take some amount of time for it to get downloaded, even though I have a good connection. So let's just wait for a minute. Perfect. So we finally have our Nginx container with Docker. So now if I do a service Nginx status, the Nginx is stopped. Perfect. So let's go ahead and start our Nginx. So it says starting Nginx. Let's quickly verify. Perfect. So our Nginx is up and running. So let's go ahead and explore the etc Nginx directory. So this is the directory where the Nginx related configurations are set. So most of the work related to the configuration that we will be doing throughout the course will be within this specific directory, which is etc Nginx. Now there is a file called as nginx.conf, which is the main configuration file of the Nginx. Okay, let's try vi. Perfect. So there are various configuration directives which are present within the nginx.conf, and each of these directives represents a certain configuration of a web server. Now it is very, very important to understand these directives, and in the subsequent lectures we will be looking into each of these. So for the time being, I'll come out of it. And since our Nginx is up and running and it is running on the port 80, if you will see, if I do a netstat ntlp, it is running on port 80. Since we had done a mapping, let me press Ctrl P and Q. So I am out of my Docker container. So if I do a docker ps, you will see that my port 80 of Windows machine is directly mapped to port 80 of the container. So if I open up port 80 of my local machine, I'll be automatically directed towards the Nginx which is running in the container. So let's do one thing. Let's try this out. So I'll type 127.0.0.1 and I'll press enter. And here you will see welcome to Nginx. So this is basically the default Nginx page. So this is the basic about it. Let's do one thing. We do not really want to use IP addresses. So what we'll do is we'll modify our host file. So I'll copy this. I'll type run. And within this, I'll paste this specific value. So this will open up the host file. I'll press OK. And this will basically give me the default contents. So here what we'll do, we'll add our first entry, which is 127.0.0.1, and I'll say example.com. So we will be using the example.com domain, So by default, you will not be able to save it within the directory itself. Or if you, let's do one thing. I'll save it in the desktop. Now, one thing that we can do is that this specific host file is saved with the extension .txt. So this is something that we do not really want. I'll just put it like this. I'll copy it. Now I'll go to the directory path which is present, C drive Windows System32 drivers etc host. So let me just copy it. Oops. I'll go here, and this is the host file. What we'll be doing is we'll be replacing this host file with the new host that we have created, and I'll click on paste. And I'll replace the file in destination. I'll click on continue. Perfect. So our host file is now added with a new entry. So if you do example.com and I'll press enter, you see now I am up with the NGINX default page. So instead of 127001, we'll be using a domain called as example.com for a local practice. So this is it about installing our first NGINX. I hope this has been informative for you. Go ahead and try this once, because after this we'll be looking into the nifty drifty details of our NGINX web server. Thanks for watching. Hey everyone, and welcome back. Now in the earlier lecture we looked into how we can install our NGINX. So today what we'll do, we'll have a very high level overview into the architecture, and then we'll go to the nginx.conf and understand the various directives which are present. So this is a high level overview. I apologize for a bit blurry image. I don't really have the original image right now, and I wanted to complete the lecture. So let's look into what it really is. So first you have your NGINX configuration file. So this is the nginx.conf file which has various configuration related directives. Now when you do a service nginx start, what happens is there is a master process that gets created of nginx. This master process will read the nginx.conf file. Now depending upon the directives which are present over here, it will launch certain worker processes. Now these worker processes are responsible for interaction with the client. So whenever a client sends a request to the web server, it is the responsibility of the worker process to provide the response. Now how many worker process that gets launched really depends on the amount of resources that you have available. But just remember that the master process does not interact with the client. It is the worker process which interacts with the client. Master process's responsibility is to read the NGINX configuration file, and depending on that, it will launch various worker processes as well. So this is the very high level overview architecture. Let's do one thing. Let's go back to our server and let's explore. So before that, what we'll do, I'll just install Nano, because I really find Nano to be very simple and sleek. So along with that, we might need less command. Okay, it is already installed. Perfect. So we'll go to cd etc nginx, and if I do a ls, there is a nginx.conf file which is present. So if you do nginx.conf, what you will see is there are a lot of settings or directives which are available, and we'll start with the first one. Now what the first one says, user nginx, and in the second one you have worker processes auto. Perfect. So let's start with the first one, and before that I wanted to show you one thing, because we discussed the architecture of master and worker processes. Let me show you. I'll do a ps-ef-forest grep nginx. So now what you will find over here is that you have one master process, and in the master process you see -c, and you have the part of the nginx conf. So this is the path which is specified. So the master process will read the nginx.conf file, and according to that it will launch various worker processes. So you have the first worker process over here, you have the second worker process over here. So when you open the nginx.conf, in the worker processes you have auto. So what auto basically means is that it will automatically launch the worker processes according to the right configuration which Nginx believes it to be. Now how actually it really does is, it basically, one of the best practices says that the amount of worker processes that will be launched should be dependent on amount of cores of CPU that you have in your system. So let's assume you have a dual core CPU which has 2 cores, then you should launch only 2 worker processes. However, if you have 4 core system or a quad core system, then you should launch 4 worker processes. So depending upon the CPU cores which are available to your Nginx, the worker processes should be launched accordingly. So in our case, if you just want to see, let me do a cat on on proc and CPU info. Now here you see I have 1 core. So this is the first processor and this is the second processor. So this basically means this is running on a dual core based machine. So 2 cores are available to the Nginx host. And this is the reason why by default, whenever the Nginx starts, it will run 2 worker processes because I have 2 cores which are available. So let's go ahead and modify this one. Let me modify it to 4. I'll save the Nginx conf and I'll do service Nginx reload. Perfect. The reload has completed. And now if I do a ps-ef, what you will find is now I have 4 worker processes which are created by the master process. So master process read the nginx.conf. It saw that now worker processes is changed from auto to 4. And this is the reason why the master process launched 4 worker processes. Perfect. So this is the first configuration directive that we explored. The next directive will talk about user Nginx. So this basically means at what user the worker processes should be launched. So if I just go out and you'll see over here, the worker processes, we have 4 worker processes which got created and the user associated with them is Nginx in all of them. Now remember, this specific directive, this user Nginx directive specifies at which user the worker processes gets launched. It does not is related with the master process. So master process will always get launched with the user which starts the Nginx. Since in our case we started the Nginx with root user, the master process, so this process is a master process got launched as a root, and the worker process will inherit the user which is specified in the nginx.conf file. Perfect. So now we have 2 directives which we have covered. The next directive, which is error log, which specifies the path at which the error log will be stored. So this is very important. Like sometimes what happens is that Nginx fails to start or it does not start at all. Now how will you debug on why Nginx is not starting? And the answer to this is error log. So whenever Nginx has some issues or it does not start due to some reason, then you can find the specific reason in the error.log file. So let me just copy this path. I'll do a less on var log nginx error.log. So if I press enter over here, this file is currently empty. The reason why it is empty is because there is no error in Nginx. But once we move ahead with our Nginx configuration, I'm sure we'll be making mistakes and we'll be looking them in the error.log file. Along with that, I'll just show you one more interesting thing. So if you go to varlog Nginx, there are two files that you will find over here. One is the access.log and second is the error.log. So access.log will contain information related to the client which are connecting to our web server, and error.log will contain information related to the error perspective of Nginx. So let me show you. If I do a tail on access.log, these are the log files of the visits that we had done in the earlier lecture. Let's do one thing. Let's go to example.com and the default Nginx page loaded for us. So now if you'll see over here, within the access.log, I have the log file which is created. So this log file directly corresponds to the request which was made. So you have the IP address of the user which made the request. You have the timestamp, you have the get request, you have the response code. You also have the browser which made the request. Anyway, so we'll be discussing about this in great detail in the relevant section, but just understand the need of access.log and error.log. So coming back to the topic, the last directive that we'll discuss in this lecture is the PID. So PID stands for process ID, and it basically tells the process ID of the master process. So which is var run nginx.pid. So if I do a cat on var run nginx.pid, it will basically give you the process ID of the master process. So whenever you do a PSEF on Nginx, you will find that there are processes which are different PID. So one is the master process which has a PID of 219. Then you have 4 worker process which has PID 2926, 2927, 2928 and 2929. So understanding or getting the PID of the master process is very important. We'll look into why. Or if let's assume if you want to kill your Nginx, you can kill this specific PID of a master process and the worker process will automatically be removed. So we'll be discussing more about this, but just understand the PID section as well. So this is it about the Nginx.conf for the first lecture. We covered the first 4 directives. In the next lecture, we will be looking into the events section as well as the HTTP section. So go ahead and try this out, what we have done in today's practical, and in the next lecture, I'll see you with another great video. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. So continuing our journey with understanding the Nginx configuration, today we'll take one more important section of nginx.conf file. So let's quickly open the nginx.conf, and in the earlier lecture we discussed the basic overview related to the first 4 directives which are present in nginx.conf. Today we'll be looking into few more, specifically the event section and certain directives of the HTTP section. So some of you might say that where is this specific directive, and this is something that we'll be covering, but I wanted to show you some of the most important parameters that will be useful right now. So when you talk about events section basically deals with the connection parameters related things. So this is one of the section that we will be dealing the least with. So within the event section, you'll see you have worker underscore connection followed by 1024. So what this basically means is each worker which gets created, how many maximum connections it should have, and the answer is 1024. So things related to ePOL and multiplexing, so all those things are part of the events section, and this is the reason why we'll be touching it the least for the time being. The next important section is the HTTP section. Within the HTTP section, you will see that there is a access_log followed by the path of the log file. So in the earlier lecture, we discussed the basic about what access.log really is. Now, if I just open it up, so if I do a var log nginx access.log, you'll find that there are a lot of logs which are present over here, and each log follows a specific format. So you'll see in all the log that is present over here, it all starts with the IP address. Followed by the IP address, you have various parameters like the timestamp, you have the request type, you have the response code which is 200, you also have the user agent. You see the Chrome over here. So now the question is how exactly this format is defined, and the answer to this is in the HTTP section. So the format of the logs that will be stored in the access.log is defined in this specific section. So this is the format. So first you will see the remote_addr variable. So this variable basically is the IP address of the client which is making request to our NGINX web server. So anytime when you are confused on what a specific value of a access.log really means, you can just open up the nginx.conf and see the mapping over here. However, we actually have a separate lecture altogether related to these two directives in the logging subsystem, where we'll be discussing and we'll actually modify the log format and see on how actually it would really work. So last but not the least, if you might have seen, what I have done is there used to be a curly braces over here, and I have removed the curly braces over here to actually break the NGINX configuration. Now in the earlier lecture, we had discussed that error_log basically tells about the error which NGINX might face down the line. And since I have removed the curly braces here, the NGINX configuration would break. So if I do a service nginx restart, you see it says that the nginx configuration has really broke. Now you might not get this good description all the time when the nginx has broken. So your standard way should be to open var log nginx error.log, and within the error.log you will see it actually saying on why the nginx broke, and it is saying unexpected end of line expecting the closing curly braces in etc nginx nginx.conf on line 40. So this is a very accurate description which it is showing, and it will help a system administrator know on where exactly the error is really happening. So let's do one thing. Let's quickly go to etc nginx nginx.conf. I'll go down and I'll do a closing braces, and now if you do service nginx restart, you see nginx has restarted perfectly. So this is the basic about the nginx configuration. Now one important thing that I'll show you, we'll conclude with this last point. Like whenever you change some configuration parameters of nginx conf, instead of directly doing a nginx restart, because this might actually, if you are running it in production, the entire website will go down. We had this scenario where a person missed the curly braces and he actually restarted it, and the entire website went down. So you should never do that. What you should be doing instead is you should be running nginx-t command. So nginx-t command will check your nginx.conf and it will tell you whether everything is perfect or not. Now in this case, you see it is already showing you the error. So I'll quickly fix it. Let me quickly fix this. And now if I do nginx-t, you see that the syntax check is successful, and then you can go ahead and restart your Nginx web server. So this is it about this lecture. I hope this has been informative for you, and again go ahead and practice the things which we have mentioned over here, and I'll see you in the next lecture of our Nginx series. Hey everyone, and welcome back. So continuing a journey with understanding the nginx.conf, today we'll be looking into the other parameters which we have yet to cover. Now what I've done is I have increased the font size overall so that it will become easier for us to see the contents. So if you're also using Windows, one of the ways in which you can increase the font size is right click, go to properties, and within the font size you can select the font size that you really need. So this will be much more helpful. Perfect. So let's open up the nginx.conf. And in the earlier lecture, we were yet to cover the include directive. So this is one aspect. And if you go a bit down, there is one more include directive, which you'll see over here. And then you have third include directive, which you see over here. So what include basically means is it says that include all the configuration. So what it says that include all the contents which is present in this specific directory. Now there are two ways in which you can write the configuration. The first way is you write in this specific file in nginx.conf. However, if you write everything within nginx.conf, what will happen is it will grow very big, and then debugging will be much more difficult, as well as it will not look very good. And this is the reason why what the Nginx decided to do is they created a directive called as include, and within the include we specified the path of the files which would have the directives, or I would say Nginx configuration directives. Let me show you one among them. So if you'll see include etc nginx conf.d star.conf. So if you'll go, so if I do a pwd, I'm already in etc nginx. There is a directory called as conf.d. So conf.d and star.conf. Star.conf basically means all the configuration which ends with .conf extension. And if I open any one among them, these configurations are also commented out, but whenever we will be creating our first virtual host or first website custom, we will be actually writing all of the parameters in this specific directory in conf.d. We will not be modifying the nginx.conf. We can do that, but it will not look very good. We will instead be writing it in a directory which is etc nginx conf.d, and when you go out, when you open nginx.conf, so whenever you start your nginx server, it will read all the configuration file which is present within the include directive. So this is one of the very good ways of making sure that the things remains in a systematic way. Now one example I can show you is that there is a include followed by etc nginx MIME.types. So let me actually open this up. And I'll do a nano etc nginx MIME.types. Now if you'll see over here, this is a pretty long file. You'll see a very long file. So if you just want to see how many lines are there, it is actually of 89 lines. Now you can actually write those 89 lines in the nginx.conf itself,
But if you do that, then your nginx.conf will become really messy. And this is the reason why you can actually write a simple include directive. You have an include directive followed by the file path, which is etc nginx mime.type. So whenever you restart your nginx server, it will open up this specific file contents and it will include it in the HTTP subsection. So a small lecture. I hope you understood the basic about the include directive. In the upcoming lectures, we will be specifically discussing about the MIME types and the default underscore type parameter. Now, one thing that I would really like to let you know that each of these configuration which you see over here, send file, TCP, no push, keep alive, each of these configuration actually requires a separate video lecture in itself. So I hope these are actually very in-depth configuration parameters, and when we'll be discussing more about Nginx once our website is created, and whenever a relevant time comes, then we'll be discussing about each one of these. But with this, we'll complete this specific video. I hope you understood the basic about include directive, and I look forward to see you in the next lecture. Hey everyone, and welcome back to the Knowledge Portal video series. So what we'll be doing today is we'll be creating our first website based on Nginx based web server. So till this time, what we had been doing is whenever we type example.com, it would show you the default page. Now within this, it actually gives you the file or the directory where this page is actually located. So if you go here, if just copy this out, which is user share nginx html, I'll copy this. Now let me go to CD. I'll copy the user share nginx html, and if I do a ls over here, there is a file called as index.html, and this is the file which basically gets loaded when you type example.com. However, what we'll do, we'll go out of defaults and we'll be creating our first website. Now, the question that comes is, let's go to the nginx.conf. Now the question that comes is, how come when I typed example.com, that page got automatically loaded? So there has to be some kind of a setting which actually specifies that the page which is stored in user share nginx html / index.html should be loaded when someone types example.com. And this actually configuration is present over here. So if you'll go down, although the direct configuration is not present, there is one include directive. Let's go down. So this include directive states that include all the files which is present in etc nginx conf.d / star.conf. So let's explore this out. So I'll go to etc nginx conf.d, and here you will see there are 3 configuration files which are created. We'll open up the defaults.conf, and this file actually contains all the configuration related details. Now within the root, you will see over here, it contains the path where the index.html is loaded. So this is the path where the current website files are present. Let me show you the importance. Now since our Nginx is running, let me show you, Nginx is running on port 80. Now let's assume that I want to change the port in which the Nginx is running on. So I'll go here and I'll say 8080. Okay, and I'll save it. I'll do a nginx-t. Everything seems to be perfect, and I'll restart. It restarted. So next time if I do a netstat-ntlp, you see that the Nginx is now listening on port 8080. Perfect. So let's do one thing. Let's go back and change to the default configuration and verify if everything is working on port 80. Perfect. So what we'll do, we'll create our own conf file similar to default.conf, and we'll be writing our configuration parameters. So there is a sample file virtual.conf which is pre-created when you install Nginx, and we'll be using this file as our starting point and we'll be modifying things. So what I'll do, I'll copy virtual.conf to kplabs.conf and we'll modify the kplabs.config file. So let's remove the comments which are present over here. So it all starts with the server directive. So everything should be present inside the server directive. We'll be discussing more on this. The first directive basically states on which port the Nginx should be listening on. It should be 80 or it can be 8080 or some different one. So this is where the first directive is present. We'll remove the second directive. The next directive is the server name, which basically signifies the name of the server which will be present in the hostname header of the client. So I'll say example.com over here. So whenever a client sends a request on port 80 for example.com, then this server block will be invoked. Now in the location, we have to specify the directory in which the root or in which the website files will be stored. So I'll say root, I'll say var www, let me put it as websites, and then you have an index that basically means what happens if someone just types example.com without any URI, then what should be loaded. And in here we are specifying if a user just opens example.com, then by default index.html file should be loaded from this specific directory, which is www websites. Perfect. Now since we have written our own kplabs.conf, what we'll do is we'll just modify the other configuration which are present over here so that they do not get loaded. Perfect. So I think you might be hearing some cracker noise. This is actually a Diwali, and this is the reason why people are actually bursting crackers. Anyways, so perfect. So now we have removed or renamed all the files. Next thing that we have to do is we have to create a directory var www websites. Oops, let me go to var and let's create a directory called as www/websites, or instead of it, simple command would be mkdir-p var www websites. Perfect. So now it has created www and website. So we'll go here and we'll create our first index.html file. I'll say welcome to our first website based on Nginx with a good smiley. I'll save this out and we'll go back to our Nginx configuration. We'll do a nginx-t. Everything seems to be successful, and I'll do a restart. Perfect. So things seems to be working perfectly. Let's refresh this page now, and now you see it is showing welcome to our first website based on Nginx. So what really happened was when I typed example.com, the configuration, because there is a server name which says example.com,
So whenever a request of example.com arrives at Nginx, it will follow the configuration which are mentioned within this server block. So this server block is specific for example.com. Now you can actually have various other server blocks. Let me show you. So you can have one more server block which states, say, listen 80 server name, you can say example.net, and then you can have various other configuration. So whenever a request comes to Nginx with a domain example.net, then whatever configuration that we will be writing within this server block will be executed. And next time whenever a request comes with example.com as a domain, then this particular server block will be executed. So I hope you got the basic understanding on server block, and because of this we can actually have multiple websites on a single web server. So this is it about this lecture. Go ahead and try this once, because this will become the base on the upcoming lectures that we will be working on. I hope this has been informative for you, and I look forward to see you in the next lecture. Hey everyone, and welcome back to the Knowledge Portal video series. So today we'll be speaking about MIME. Now MIME is a great feature which allows browser to have a lot of flexibility related to customizing and making the user content much more sleeker. So let's go ahead and understand more about MIME. MIME basically stands for Multi-Purpose Internet Mail Extensions. Now when you talk about the word extensions, I'm sure you might be thinking that there are various file extensions that you might find, like .docx, then you have .pdf, .mp4. So all of those are called as the extensions. Now, typically when you talk about websites or a web server, they generally hold a data with a specific extensions as a overall. So you can have image files over there, you can have HTML files, you can have video files, audio files, PDF, Excel sheets, and many more. So these are one of the common files that you will find that they are being stored in the server. Now, let's look into the need of MIME, where you have a client on the left hand side which is a web browser, and on the right hand side you have a web server. Now when a web server sends a file to the client, which can be a web browser, it will be great to know on what type of file this is. So if a web server is sending this file to a browser, it will be much more better if the web server also tells on what is the extension or what type of file it is. So in this case, the web server is saying this is a PDF file. So depending upon the contents or a nature of a file, a web browser might have certain kind of extensions which might open up the PDF file within the browser itself. So let me just show you one of the examples. So I am in my Firefox. Let's say sans firewall checklist, and here you have a PDF file. So let me open this file and let's see on what really happens. So what you see over here is that this file automatically got parsed, and I am able to view this file from the browser itself. Now the reason why I am able to view the file from the browser is because there are certain kind of extensions which are installed in the browser which will automatically process information from a specific file type. So question is how? So let me show you. If you go to tools, options, if you go to applications, and on the left hand side you see that if the content type is portable document format, which is PDF, then the action is preview in Firefox. That means any file which has a content type of PDF, then Firefox will automatically set it to preview. Now definitely you can change it to always ask or save file, but this is the default way of doing things. Now the question is, how can Firefox know whether the file which is being sent, whether this file which is being sent is of type PDF or not? And the answer is that the web server must tell ideally that this specific file is of type PDF. Once the web browser knows that this is a PDF file, then it will use some of the inbuilt extension that will help preview this PDF file itself directly. Perfect. So let's do one thing. Let's take this URL which we had taken and we'll start our curl so that we can see in much more clear way. So I'll do curl -i. We are just interested in headers, and I'll paste the URL. Let's wait, and there's a lot of headers actually, if you'll see over here. Now it all started with 200. Okay, that is quite good enough. Then along with that, there is one important header that we are specifically looking for, which is the content type. And within the content type, it is saying application/PDF. So this is the indicator for a web browser that this specific file which is being sent is of type PDF. Now, as soon as the web browser notes that it is of type PDF, it will automatically make it as a preview with one of the browser extensions. Perfect. So this, I hope you understood the basics. Similarly, let me give you one more example. So let me .com/c.jpg. So as soon as I type the URL, you see the image automatically got processed in the browser itself. Now same goes with this as well. So if I do a curl -i on, let's say, http example.com/c.jpg, you will see that in here now the web server or NGINX is responding back, and one of the headers is of content type followed by image/jpeg. So the NGINX is saying that this specific content which is being sent is of type image and the subtype is jpeg. Perfect. So this is one of the very important headers which is of content type. So let's go ahead and understand more about it. So content type header indicates the media type of a specific resource. So whenever a web server sends certain resource to the client, which might be web browser, it generally adds a header called as content type, and this header has certain values like application/PDF or text/HTML, which will help browser to understand what type of file it is, and accordingly web browser will process it. Now one of the questions that would generally arise is that how does a web server know on what is the value that it should put for the content type header? This is very important because web server needs to know whether it is sending an image file or a PDF file or other files. So this is the first step, and we'll look into how web server comes to know what type of file it is sending back to the browser. So let's look into how web server knows. So if you go to cd etc nginx and we'll open up the nginx.conf. Within the nginx conf, there are two important directives. One is include etc nginx MIME.types. This is very important. So let's go ahead and understand more about it. So I'll open MIME.types, and within this there are a lot of types associated over here, if you'll see. quite lot of them. So let's go with a start. Now, how this really works is, on the right hand side, you have the file extensions. And on the left hand side, you have a value which will be associated in a content type header. So if any file is of extension .html or .htm or .shtml, then the web server will put text/html as a content type header. Similarly, if any file ends with an extension JPEG or .jpg, then the web server will automatically add image/jpeg as the content type value. So this is very similar to what we just discussed. So in this, if you'll see, the value or the extension is .jpg. And this is the reason why in the content type you have image/jpeg that you will find, which is actually taken from a file called as MIME.types. Similarly, if you go a bit down, there are a lot of extensions which are available. If you go down, then if any file has an extension MP4, then the web server will add the content type header with a value video/mp4. So this is how a web server comes to know on what is the content type that it needs to send. Okay, so this is the basic about MIME. Now one more important thing to remember is that after this, we now understood what this basically means. Now there is one more directive called as default_type, which basically says that if there are any files which does not meet the extensions which are present in this file, then the default type would be application/octet-stream. So this basically tells browser to directly download the file and not process it. So this is very important. So if you do a cat on MIME.types and do a grep on octet-stream, you see there are various extensions which are associated with this specific type. So you have .bin, you have .exe. So .exe is for executable in Windows. You have .deb, which is used to install in Ubuntu. You have .dmg, which is used to install application in Mac. You have ISO. So all these extensions, if you see, these extensions are specific to a operating system or specific to a application. So these cannot be directly processed by the browser. So this is the reason why the web server will put application/octet-stream, which basically tells the browser to directly download it, because these are specific to a application or specific to operating system. So this directly cannot be parsed within a web browser itself. And this is what the application/octet-stream really means. So if you want to see on how that would work, let's go to www websites, and if you'll see, I have seed.jpg. Now if I have a file which ends with .exe, or maybe a genuine file which ends with .exe, let's try it out. Let me small Linux ISO download. So this is a damn small Linux ISO. Let's go to the full mirror list. Perfect. Let us find the ISO file. So okay, this should suffice. I'll take this, or let me take this one. This is the .img file. I'll copy the link address and I'll do a wget on the link address. So it will download the .img file. Let's wait for few seconds for it to get downloaded. Perfect. So now this file is downloaded. Now if I do a ls over here, I have this specific file. Let me just rename it. I'll say test.img. I'll rename this pcm. I'll say test.img. And now according to the MIME type headers, which is etc nginx, let's verify. According to the headers, any file which ends with .img extension, the web server will attach application/octet stream in the content type header value. Perfect. So now we have this test.img file which matches this specific extension. So let's open this up and let's do a curl -i on http example.com/test.img. And now if you'll see in the content type header, you have application/octet-stream. So whenever you try to download it in the browser, let's try it out. I'll just specify test.img. Now what web server will do, web server will say that this is of type octet/stream, and web browser will directly go ahead and download this specific file. So you see it directly went and it is asking me whether I want to download. So here the parsing and all does not really happen. So this is it about the MIME types. I hope you got the basic understanding. Now we'll just end with one small topic, which is common MIME types. So there are a lot of common MIME types which are available. You have application/star, you have audio/star, you have image, text, video. Now the first field is called as the main type, and the second field over here which you see is PDF. So this is called as a subtype. So your application is the main type and PDF is a subtype. Similarly, text is the main type, this HTML is a subtype. Similarly, for image, you might have PNG image or a JPEG image. So there can be various subtypes for a specific main type of MIME which can be available. So this is it about MIME and the content type header. So I hope you understood the basic necessity of MIME type, and yet again we understood the two important configuration within nginx.conf, which is the MIME types and the default type. With this, we'll conclude the lecture. I hope this has been informative for you. Go ahead and try this out. It is very interesting to see how things really work. I hope this has been informative for you, and if you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome to the Knowledge Portal video series. And today we'll be speaking about one of the most amazing features of Nginx, which is reverse proxy. So let's go ahead and understand what a reverse proxy is all about. Now, in simple terms, reverse proxy is a type of proxy server which retrieves resource on behalf of a client from one or more servers. So let's understand on how this would really work. So you have a typical internal network where you have a Nginx server sitting over here, and in the backend you have an application server. Now, whenever a client wants to access this application server, what it needs to do, it needs to first send the request to the Nginx server, and Nginx server internally will forward the request to the application server. Similarly, application server will send the response to the Nginx server, and Nginx server will forward the request back to the client. Now this type of architecture is very useful because there is a Nginx server which is sitting between a client and the application server. So your application server is not directly exposed to the client. Now, since you have your Nginx reverse proxy, so this is called as a reverse proxy because it is actually taking the request from the client, sending it to the backend server, taking the response, sending it back to the client. Now, since it is sitting in between, it can actually do a lot of things. Like, for example, it can have some kind of a DDoS protection. So if client is trying to attack with lot of packets, it can be blocked in the Nginx level itself. It can do other things like Web Application Firewall also, and it can do caching, it can do compression. So there are a lot of possibilities which comes when you have Nginx which is sitting behind, and because of this it is called as a reverse proxy. Now, reverse proxy can play a key role to achieve a lot of use cases. Now, one of the very important use cases is that it hides the existence of the original backend server. So this specific client does not really know how many servers are actually there behind the scenes or what is the configuration. So you have the Nginx which is sitting behind, and the client only needs to know about this Nginx server. And if we apply all the hardening, everything over here, and this would actually protect our entire website. So second important point, that it can protect the backend servers from web application based attacks like SQL injection. All if the Nginx reverse proxy has a web application firewall, it can also protect from denial of service and many more attacks. Third important point is that a reverse proxy can provide great caching functionality. So what do I mean by that? Let's assume a client is requesting for an index.html from the application server, and the application server gave it back to the client. Now, after few seconds, one more client is requesting for the same file. So instead of Nginx asking the application server again and again, what it will do is it will store the file within the Nginx server itself, and whenever a client asks for that file, Nginx server directly will send it to the client without contacting the application server directly. So this provides much more faster speed and response time. So that is what is meant by the great caching functionality. Nginx can also optimize the content by compressing it. So it can compress based on Gzip. We'll be looking into it. It can act as a SSL termination proxy, and you can also do various things like request routing and many more. So all of these things that we have been discussing here is something that we'll have a practical session on in the subsequent lectures. So let's do one thing. This has become theoretical. What we'll do is we have an Nginx server and we have one of the backend servers. So we'll do a practical and see on how it would really work. So let me show you. This is our, I'll show you. So this is our Nginx reverse proxy which is running, and on the backend server, so there is one more server which is backend server. You see the IP address is different. This is 17.03 and you have 17.02. So within the backend server, I have an index.html file which says this is a backend server. What we'll do, we'll be sending requests to our Nginx reverse proxy, and we'll look on what response that we really get. Perfect. Till that time, I'll open up the Nginx access log so that it will become much more clear for us for both of them. F-bar log Nginx access log. Perfect. So currently the access log of both of these instances are empty, which means no new requests are coming up. So when I type example.com this time, let's see on what happens. It says this is a backend server. So what really happened was I sent example.com domain is linked to the Nginx server. So I type example.com, the request went to the NGINX reverse proxy. It forwarded the request to the backend server. It got the response from the backend server and it served the response back to the client. Now, if you just want to verify that, let's see. So this is the reverse proxy. Reverse proxy got the request from 172.17.01. So this is the request. And if you go here, this is the backend server. Now that request got forwarded to the backend server from the IP 172.17.0.2. So what we have is the client has an IP of 172.17.0.1. So this is 0.1, this is 0.2, and this is 0.3. So reverse proxy will get the receive request from 0.1 and application server will receive request from 0.2. And this is what actually is happening. So the reverse proxy is receiving request from 0.1, which is my browser, and the backend server is receiving request from 0.2, which is my NGINX reverse proxy. So this is the basic about reverse proxy. Now, since NGINX is sitting between the client and the backend server, we can establish a lot of things like Web Application Firewall or all the hardening related parameters within the reverse proxy. So this is it about this lecture. I hope you understood the basics about what a reverse proxy is, and this is what our intention was for this lecture. If you have any doubts, questions, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now, in the earlier lecture, we discussed the basic about what a reverse proxy is, and we also looked into practical session related to how a reverse proxy would really work. So today what we'll be doing is we'll be configuring our first reverse proxy in NGINX with the help of proxy pass directive. So let's go ahead and understand more about it. So when you talk about the basic architecture of a reverse proxy, this is something that we already know, where client will send a request to NGINX and NGINX will forward the request to the backend server. Similarly, in the response, backend server will send the response to NGINX and NGINX will forward the response back to the client. Now, for NGINX to forward the request to the backend server, it needs to know the IP addresses or the host name of the backend server. So this is something that we have to configure on the NGINX side. So very important. So this configuration of forwarding the request to the application server is done with the help of a proxy pass directive. So proxy pass directive forwards the request to the proxied servers, which are the backend servers, which are specified along with the directive. So this is a very simple example for location, which is root, proxy pass to this specific IP addresses. So what this really means is that any request that comes to root, just forward the request to this specific IP address of the backend server. Now this is one example. There are a lot of flexibilities which we can achieve with the help of proxy pass. Like you can do a request based routing, like any request that comes to /admin, like example.com/admin, forward it to one of the backend servers. Similarly, any request that comes for /login, forward it to a different server. So depending upon the request, you can actually forward that request to different backend servers which are running. So this is about theory. Let's go ahead and do the practical so that it will become much more interesting. And this is really a very fun topic to work along with. So what we had seen earlier is that whenever we opened example.com, it went to the backend server. So what I did, I have removed all the labs and will start from the absolute beginning. So this time when I do example.com, you see welcome to our first website based on NGINX. So it is going to our NGINX server, which is up and running over here. So let's go back, and when I do a PS, you find that there is one container running. So this is the container which has our Nginx setup already. So what we will be doing is we will be taking the snapshot or the image of this specific container, and we'll be relaunching one more container from this. So otherwise what we'll have to do is, otherwise we'll have to launch a brand new container. Let me show you. We'll have to launch a brand new container from this repository, then go ahead and install Nginx, do all the configuration. So this is all is manual work. So in order to take the image of this container, what you can do is you can do docker commit followed by the container ID. I actually have all the commands written, so we'll be pasting these commands directly. So you have the docker commit command here, followed by you also have command related to the reverse proxy and all. So this is something that we'll remember. So once you do docker commit followed by the container ID, then you specify the name of the image that you want. So once I press enter over here, so it is taking the image of this specific container and it seems to be successful. So if you do a docker images now, you will find that there is one more image which is running, which is CentOS-Nginx. So what we'll do is we will be starting a new container from this image, because we need two servers over here. So if you'll see, we need two servers. One will be the Nginx and second will be the backend server. So there will be two servers which will be needed, and this is the reason why we are creating two containers. So since we have our container up and running, and this container already has Nginx and nano and other commands already installed, we'll start a new container from this image. So in order to do that, you can run a docker run command. So I'll just copy this out. Let me paste it, and this time what you have to do is that you cannot use 8080 over here, because 80 port of my host machine is already mapped with the 80 of my container. So instead of using 80, I have to use 8080. So 8080 of my host machine will be mapped to the 80 of my container. Okay, so this is what it would mean, and let's go ahead and start our container. Oops, I made a mistake. It should be CentOS Nginx, my bad. I'll press enter and you have the docker image which is up and running. So let's do a docker ps, and now you find that there are two containers with a different container ID. So this was our original container, which is CentOS 6, and this is a new container which launched from CentOS-Nginx image. So what we'll be doing is the original container will be using this as a reverse proxy, and the new container that we created will be using this new container as a backend server. So let's go ahead and connect to the new container. I'll do docker exec it, I'll copy and I'll put bash. Perfect. So if you do service nginx status, let's do a restart. And now if you'll do, the Nginx is up and running. If you go to var.www websites, and in the index.html, we'll change this. Let's write a simple HTML code. I'll say h3, this is our backend server, and I'll close the HTML. Simple. Perfect. So let's go ahead and verify, because we are actually, if you'll see, it is actually attached to the 8080 port of my host machine. So if you do example.com/:8080, you should find this is our backend server. So this seems to be proper. And when I just do example.com, you have welcome to our first website based on Nginx. Perfect. So now we have both the containers up and running. So we can go ahead and start our practical related to the reverse proxy. So let me just, okay. So this time we will log into our first container, which is based on the original image. I'll say docker exec-it. So we'll be using this container. So this is our original container. I'll copy and put a bash. Perfect. So now if you go to etc nginx conf.d, in the kplabs.conf, this is the simple website that we had configured earlier. Now everything remains the same except the location directive. So this is the location directive where we have to include a proxy pass directive. I say proxy underscore pass followed by HTTP IP. So IP basically will have the IP address of the backend server. Let's quickly verify that. I'll just connect again. I'll verify the IP address of my backend server, which is 172.17.0.3, and the IP address of my reverse proxy is 172.17.0.2. Perfect. So we'll go ahead and modify the proxy pass directive, and this time, oops. I think there seems to be some issue. Let me just open this up again. Great. So there is some issue with the file somehow. Let me delete the entire line and let's start again. I'll say proxy pass HTTP 172.17.0.2. Don't forget the semicolon over here. Actually, it should be 0.3. Do a nginx-t. Everything seems to be successful. I'll do service nginx restart. Perfect. So just verify nginx is running and everything seems to be proper. Let's do a tail on varlog nginx access.log. We'll do a tail here. Along with that, we'll do a tail on varlog nginx access.log, so on the proxy server. So this is the proxy server. I'll open this up once more, and you have, this is our backend server. So now if you go over here, okay, so I forgot to remove 8080. So now I'll put 80, I'll not put 8080 so that it will go directly to the nginx reverse proxy. I'll press enter and it doesn't seem to be loading. So one thing I believe we missed is service nginx restart. So this is something I believe we missed it. And now if I refresh, perfect. So this is our backend server. So now what exactly is happening, if you will see, this is the request which came. So we'll just revise this out. So this is 0.1, this is 0.2, and this is 0.3. Now the request to the nginx reverse proxy came from 0.1, which is my host machine. Now this request nginx reverse proxy forwarded it to the backend server. So in the backend server, you will see we have IP address of 0.2. So 0.2 is the IP address of my reverse proxy. So that means our backend server received request from the reverse proxy. It sent a response back to the reverse proxy, and the reverse proxy sent a response back to the browser. So this is how it would really work. So I hope you understood the basic on how we can configure reverse proxy. I say it is a very, very simple thing to do. All we had to do is we had to change the proxy pass directive to the IP address of the backend server which was running. So this is it about this lecture. I hope you understood the Docker containers, because this thing actually makes life much more simpler. Because in the older lectures, what we used to do, we had to launch one more virtual machine itself, and that used to be quite clumsy. And with Docker container, we can achieve it in like a minute or two. So this is it about this lecture. I hope you understood the basic on how to configure the reverse proxy. Again, if you have any doubts, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome to the Knowledge Portal video series. Now today we will be speaking about X real IP. Now this specific header is a very important header, and if you are running Nginx as a reverse proxy or as a load balancer in production, this is something that must be done. So let's understand the use case on why this header is specifically important. So what is the problem with this kind of a approach where you have a proxy, or this might act as a load balancer as well? So you have three entities over here. One is a web browser. The IP address is 192.168.0.5. Then you have a Nginx acting as a reverse proxy or maybe a load balancer, which has the IP of 192.168.0.10. And then you have the upstream or a backend server, which has the IP of 0.20. Now, the web browser will send a GET request on the URI index.html to the Nginx. Nginx will forward the request to the index.html. Now, since it is the Nginx which is forwarding the request to the backend server, the backend server will assume that the GET request on index.html has been received directly from 0.10. So if you'll see over here, got GET from 192.168.0.10. And this is what actually creates the problem. Now, what really happens is, ideally, the backend server should get the IP address of the client which is initiated the request, and not the reverse proxy. So ideally, even if you have 100 or thousands of connection, what will happen is, for all the connection, the backend server will think that all the connections are originating from the Nginx reverse proxy, and this will create a lot of issues, specifically if the backend application server is doing some kind of a whitelisting based on IP addresses. Then this approach will not really work. So what is the ideal way of doing things? Ideal way of doing things is that the Nginx which is sending the GET request on behalf of the client should also inform the backend server about the true IP of the client which has initiated the request. So if you see, now the web server got a request saying it got a GET from 192.168.0.5, which is the browser's IP address or the client's IP address. So this should be the ideal way of doing things. And if you are running Nginx as a reverse proxy, then this type of configuration must be done. Otherwise, a developer will come running after you, because many of their settings will not work, because a lot of things are binded to the IP address of the client as well. So let's look into how we can do that. We already have two Nginx box running. So this is our reverse proxy box. Now, along with blankly proxy passing or blankly forwarding the request, one important thing that you need to do is you have to set a header, which is proxy set header. And I'll just copy the header. Let's just use this. Perfect. So what this basically does is, if you remember the remote underscore ADDR variable, whatever value is stored in this variable will be assigned to x-real-ip. So let me show you the remote ADDR variable. So if you go to etc nginx.conf, and again here you see you have a remote ADDR variable. So this variable is responsible for getting the IP address of the client which sent the request to the web server. And this is the reason why if you open up the log, the first field you see over here is basically the IP address. You see it is the IP address of the client which has initiated the request. So what we want is this IP address of the client that initiated the request should be forwarded to the backend server. So this IP address which Nginx received in the remote ADDR variable, it will send to the backend server with the header x-real-ip. So this is what exactly it is doing. Let's close this and let's go to the kplabs.conf. Perfect. So this is the header that we are passing to. Let's do nginx-t. Everything seems to be successful, and I'll do service nginx restart. Perfect. So now we have done this configuration. Now there is one more important configuration that needs to be done on the backend server side. So let's explore. So in this as well, in here we have to add a header file as well. So I'll add a header, let's say, because we have to capture the header in the logs which the Nginx will be storing. Let me put, I have written the exact format, which is the http_x_real_ip. So I'll just use this and I'll paste it over here. Perfect. So let's save this first and then we can explore. Let's restart the Nginx. Perfect. So now if I do a tail over here and let's try example.com. Perfect. So this is the backend server, and if you go over here, now in the first field, which is the remote ADDR field, you find this is the remote address of the reverse proxy. However, in the last field over here, you see you actually get the client's IP address. So first you are getting the IP address of the reverse proxy, and in the last field you are getting the IP address of the actual client. So this is how actually it would work. Now you can actually, depending on the configuration that you might want to have, you can remove this specific field, and you can add the variable HTTP x real IP over the first field over here. So this is also quite decent enough. So this is it about the x real IP and its importance in a production environment. So go ahead and do this. Again, I would encourage, do the practical that we have been performing, and in production this is something that you should not be forgetting. I hope this has been informative for you, and if you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. And today yet again we'll be speaking about a very important header called as proxy host header, which basically is used specifically when you have multiple websites in the backend. So let's understand the need of proxy host header. So understanding the problem, you have a web browser over here, you have a Nginx acting as a reverse proxy or a load balancer, and in the backend you have a web server. Now, when a client sends a GET request, you see there are two headers which are present. One is the GET and one is the host. Host is kp.in. Now this request is received at the Nginx reverse proxy, and Nginx reverse proxy, depending upon the settings of proxy pass directive, it will forward it to the backend server. Now the challenge here is that if you see in the first request which the client has sent, it had included a host header over here, which is kp.in. So this host header Nginx will not send. So the original host header which the client had sent will be removed from the reverse proxy end. and then it will forward it to the backend server. So this is not a very big issue if you just have a single website. But if you have multiple websites in the backend, this is where the issue will start to arise from. So let's assume now where you have a backend and there are two websites over here. One is kp.in and second is kp.net. Both of these websites have index.html page which are present over here. Now, when a web browser sends a GET request, you see the host is kp.net. It will send it to the reverse proxy. Reverse proxy will remove the original header and it will just send a GET request to the backend server. Now the problem is, since backend server has index.html on both, like there are two websites, it will not know which website this GET request is actually referring to, whether it is referring to kp.in or kp.net. And this issue arises because of NGINX removing the contents of the host header over here. So in order to solve this, what we do is we manually add one more header in the NGINX, which will take the value of the host header and it will pass on to the backend web server. So this header is called as the proxy host header. So let's do one thing. Let's go ahead and understand this with a practical so that it will become much more clear. So this time we'll do a packet capture. So if I just do yum y install tcp dump, I have already installed this in my backend server. So this is my backend Docker container where I have already installed it. So we'll start to capture the packets. So I'll run the tcp dump command, which is present in your forum. I have added the list of commands that we are already typing. Once you type this command, you see tcp dump has started to listen already. So what this command basically does is that it listens on the interface ETH0 for port 80 traffic, and if it gets the traffic, it will copy the traffic to the temp/headers file. Now let me do a curl. Let me do a curl on example.com, and you see this is our backend server. So this request went through the reverse proxy and it got received at the backend side. So what happened was we sent a request now to example.com. It received at the NGINX side and NGINX removed the host example.com and then it sent it to the web server. So if you want to see this particular part, we'll open up the temp headers. And now if you'll see over here, this is the request which was being sent by my curl client. So now you have a GET request. Xreal IP is something that we have already looked into. So this is the header which NGINX is sending. However, when you talk about host, you are actually getting the IP address of my backend server itself. So the IP address of my backend server is 172.17.0.3. However, instead of example.com, the host header just has the IP address of the backend server. So this is something which will create a problem, specifically if you are having multiple websites. So in order to solve this, what we will be doing is we'll open up the kplabs.conf. So this is the configuration of our reverse proxy. And now in here, I'll say proxy underscore set underscore header. This time it will be host and I'll have a host variable. So what this will do, it will take the host header. So let me show you. It will take the whole value of the host header, which is kp.net, and that value it will associate with this specific header which is called as the host. So whatever value which client sends over here, it will be associated with the host header which it will be passing to the reverse proxy. So let's do a nginx-t and I'll do service nginx restart. Perfect. So now going back to the backend server, I'll just remove all the contents of temp headers
and we'll just restart the TCP dump. Now this time, let me send the curl request again. Perfect. So request is sent, and I'll stop the packet capture with Control C. And this time when I go to temp header, you see over here, the host header contains example.com. And this is something that we were looking for. So if there are multiple websites like example.com or example.net, now the web server which is running in the backend can know that this specific GET request is for example.com domain, and then it will go to the appropriate root and it will fetch the index.html file. So this is the basic about proxy host header. Again, this is very important in lot of use cases. So I hope this has been informative for you. And if you have any doubt, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching.
Hi and welcome back to the Knowledge Portal video series. In today's module, we'll be talking about a very interesting topic called as load balancers. So before we go and understand load balancers, let's look at a traditional setup in which the websites are generally used. So let's say this is example.com, and example.com generally gets around 100 users at an instant of time. Now let's say the owner has been doing a lot of advertising, or you have some kind of a sale on the particular website. So during that time you can get around, let's say you have around 800 users at an instance of time who comes to your website. Now it might be possible that your website is not able to handle all 800 users, and it might actually go down. So for the companies whose business is solely dependent on the website, having website go down is a big no-no. One of the also disadvantage of this kind of a setup is that everything is installed in one single box. So let's say if a web application is having some issues, then the whole website will go down. Now let's look at a different kind of a scenario where we can actually fix all of these issues. So there is a second type of scenario where we are actually using load balancers. So what load balancer basically means is that it distributes or it balances the load that it gets across multiple instances. So taking the same scenario in example, so this is an example.com. So whenever someone visits example.com in the browser, they are redirected to the particular load balancer. So we were talking about 800 users at an instant of time. So let's say if you have 800 users at an instant of time who comes to your website, which is having a load balancer. So what load balancer basically can do is it can distribute all of these users across multiple backend instances which are running. So you can say around 200 user per server. So each of this server will get 200 users, and thus the load of 800 users is actually distributed across all the 4 servers. Now there can be a possibility that one of the server goes down. So let's take a scenario where server 4 is going down. So the load balancer has the capability to know that the server 4 has gone down. So during that instant of time, load balancer will actually close the link to the server 4, and all the traffic that comes, it will send only to the server 1, server 2 and server 3. Now after let's say 1 hour, the system administrator has actually fixed the server 4. So the load balancer will again has the intelligence to detect the server is working again, and it will consider server as healthy, and now it will evenly distribute the load. Now there are a lot of algorithms through which a load balancer can actually distribute the load, like round robin or based on weighing methods and so many other things. So we'll be talking about those algorithms in the upcoming lectures. So in this module, which I just wanted to show you an overview on what exactly a load balancer means. So I hope this topic has been informative for you, and I'd like to thank you for viewing.
Hey everyone, and welcome back to the Knowledge Portal video series. So continuing our journey with the load balancer related configuration, today we'll be speaking about server waits. Now this is a very interesting parameter because this is one of the use cases which a lot of organization faces with. So let's go ahead and understand the necessity of it. So many times what you need is, instead of a equal distribution of traffic like 50-50% configuration, you might need an unequal distribution in traffic. Now one of the use cases of having an unequal distribution of traffic is when you have one server, let's assume this is of 1 GB RAM, and you have one more backend server, and this backend server is of 4 GB RAM. So now when you have a load balancer, you might expect that since this server is much more larger and much more faster, more requests should go to this server and less requests should go to the second server. So this is one of the use cases that you might want. Like example, you want 80% of the traffic should go to the larger server. However, only 20% of the traffic should go to the smaller server. So similar to this, there can be a lot of use cases, and one way to achieve this is through server waits. So let's go ahead and understand on how server waits are implemented. So I'll go to my NGINX configuration. I'll open up the kplabs.conf, and I have two servers over here. So what we will be doing is, we will be adding a parameter called as wait. Let me actually open it with VI. Okay. I'll add a parameter. I'll say wait is equal to 3. So when you do not really specify wait over here, what NGINX does is it by default consider this server as wait 1, second server as wait 1. So the request will be distributed evenly. So let me put as 2, and I'll click on save. And if you do a service NGINX restart, perfect. So now if you want to test this out, let's do a curl. You got an output, this is container 3. Let's do it one more time, and you have this is backend server. I'll do one more time. This is container 3. This is container 3. So now you see there are two requests which are being sent over here. These are the two requests, and the next request will go to the backend server. Okay. Now again, next two requests will go to the container 3. So this is the first request, this is the second request, and the third request will go back to the backend server. So what exactly is happening over here is that we have defined that two requests should go to this server, and the next request or the third request should go to the first container. So this is how you can put unequal distribution of traffic. It might happen that this container has much more higher resource, so then you can adjust the wait parameter accordingly. So this is it about this lecture. I hope you understood the basics about server waits. Go ahead and try this out, and I look forward to see you in the next lecture.
Hi, and welcome back to the Knowledge Portal video series. So in this module, we'll be talking about one of the load balancer method, which is least connect. So we have already seen on how exactly the round robin works. So this is one of the other methods which NGINX provides as far as reverse proxy and load balancer is concerned. So let me give you an example before we actually go into the least connect. So let's assume there are two PHP files. I'll write big.php and small.php. Now big.php basically uses a lot of resources and takes around 20 seconds to execute. However, small.php is a very fast PHP script and takes around, let's assume, 1 second to execute. So basically the big.php is 20 times slower and more resource consuming than the small.php. So here we have two servers. This is server 1 and this is server 2, and 5 client requests. So let's say the client request comes to the server 1 and it is asking for big.php. I'll just write b.php, and there is a second client request b which comes to the server 2 which asks for small.php. Now basically, in order for server 1 to process this client request, server 1 it will have to take 20 seconds and equivalent amount of resources. However, for the server 2 to execute this request, it will take around 1 second to execute. Now if this was a round robin algorithm based load balancer, then the third request, which is request number C, should ideally go to server 1. But in this scenario, server 1 is already busy trying to execute the big.php, and the server 2 is already free now. So ideally during this time we want the request C to go to server 3 and not server 1. So during this type of scenarios, running a round robin based algorithm is not very feasible. So we have another algorithm called as least connect. So what least connect basically means is forward the request to the server which has least number of active connections. So currently we have b.php which is already executing, so there is already an active connection which is going on. However, for server 2 there is no active connection because the small.php is already executed. So for this, the C should go to server 2. So the C request has to go to server 2 if it is following the least connect based method. So let me actually show you on how exactly it works. So I have two servers in upstream. This is server 1 and this is server 2. So let me just refresh the page, and here you see it is waiting for PHP script to be executed. So it will take around 20 seconds for this PHP script to be executed, and we'll just wait for a while. And now it is executed. So it took around 20 seconds, and this is small.php. I'll refresh it, and here you see it got executed instantaneously. So what we want is we want to apply the least connect based method of algorithm for our load balancer. So I've already configured it. I'll just show you the configuration. etc nginx conf.d web.conf. So here what we have mentioned is we have mentioned least underscore con in the upstream directive. So in the round robin we don't have to mention anything because it takes round robin as a default. However, if you want some other load balancing algorithm, then you have to specify the name of algorithm that you want to choose. So for this we have choose least connect. So let's go to the server and let's do a Apache bench. So what I'll do is I'll do a tail to the Nginx logs. So this is server 1 and this is server 2. So this is server 1, this is server 2. Server 1 has big.php, server 2 has small.php. Now the naming across both the server is same, which is test.php, So let's keep that in mind, and let's run an Apache bench. So let's say number of connections limited to 20, concurrent let's say 10, followed by the IP address of the reverse proxy, which is this. I'll copy this, I'll paste it over here. Oops. Followed by the port number. So what basically this will do is it will send 10 concurrent requests to the reverse proxy. So this is the reverse proxy, and total number of requests would be 20. So ideally, as we are using least connect, the server 2, which is having small.php, should get the most number of requests. However, the server 1, which is running big.php, should get least number of requests. So let's run the Apache bench and let's see on how many requests each server gets. Apache bench and 20. Let me figure it out. Okay. Apache bench followed by the total number of requests that we want to send, which is 20. Concurrent requests will be 10. The address of the reverse proxy server, which was 52.6.237.228, 6.237.228, followed by the optional port number, and it seems to be giving some error. Let's remove the port number. Okay, or you can just put 28/ and this seems to be working now. Okay, so now it is sending 20 number of total requests. So ideally, let's see on how exactly the logs work. So this is server 2, which is running small.php with the name test.php. So this seems to have got the maximum number of requests. So let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the server 2 has got 15 requests and the server 1 has got only 5 requests. So you see, with least connect, the reverse proxy will send the request to the server with least number of active connections. So this is sometimes useful in a production environment where one of the servers has some very big scripts while others has the smaller ones. So this is it about the least connect based algorithm. I hope this has been informative for you, and I'll be posting the scripts the content of the scripts on the website, so you can download it and you can test it on your machines. So this is it about this video. I hope this has been informative for you, and I'd like to thank you for being.
Hey everyone, and welcome back. Now in the earlier lecture we discussed the basic about high availability and how we can achieve high availability with the help of load balancers. So in today's practical session we will be implementing load balancer with the help of NGINX. So let's look into our setup. You have a 50-50% based configuration, and you have two servers. You have two backend servers over here, and then you have a load balancer. So load balancer will equally distribute the traffic to both of the backend servers. So this load balancer can be based on various type of softwares. You have HA proxy, you have a AWS Elastic Load Balancer, you also have NGINX which does the job. So for our case, we will be using NGINX as our load balancer configuration. Now, in this type of a setup, there are three servers which will be required.
you have two backend servers and you have one server for the load balancer itself. So what we'll be doing is, since we already have a server where we had reverse proxy configuration which has been configured, we'll use that server for the load balancer. We already have one backend server which is ready. So all we have to do is we have to create one more server. So let's go to the terminal, and once I type docker ps, you see there are two containers which are present. This is our reverse proxy container, and second is our backend container which was created. And what we'll do is, since we'll need two backend containers, we'll go ahead and launch one more from the CentOS-nginx which we had earlier created. So if you remember the command, let me just show you. If you remember the command, just paste this out. Let me just copy and I'll paste this. So what you need to do is you have to change the image name, which is CentOS-nginx with a tag of latest, and port you have to change to 8081 since we have the container running on 80 and 8080. So this time we'll use 8081 and I'll press enter. Perfect. So our container got created. If you do a docker ps, we have one more container running on the host port 8081 binded to the containers port 8080. So if you do a docker exec -it, paste the container ID followed by bash. So now I'm inside that new container. What I'll do is this time I'll go to www websites, and within the index.html I'll type this is our container 3. I'll save it and I'll restart the Nginx. Perfect. So if you just want to verify, since this container is binded to 8081 of the host port, let's do one thing. I'll do example.com 8081, and now you see this is our container 3. Perfect. So our container 3 is working perfectly. We'll also verify the IP address of this container, which is 172.17.0.4. So let's exit out of this container and let's connect to the container which is running our reverse proxy configuration. So I'll do a docker exec -it followed by bash. So now we'll go to the reverse proxy configuration and go to etc nginx conf.d, and I'll open up the kplabs.conf. So this is our reverse proxy configuration that we had done until now. Now load balancer configuration is very simple. The only extra thing that you have to do is you have to add an upstream block. So let me call it as backend, and you have to put the IP address of the server, which is 172.17.0.3 and server 172.17.0.4. I'll close this block, and the next change that you have to do, let me save this and open this with VI, because Nano seems to be having some problem with the terminal. So instead of IP over here, you have to put backend. So within the backend, you have two servers which are configured, and proxy pass is sent to the backend. So this is a simple load balancer. So any request that this server receives on example.com, the proxy pass will forward it to the backend, and backend is the name of the upstream directive which will load balance across the two servers over here. So this seems to be good enough configuration. Let's do a nginx -t and nginx restart. Perfect. So everything seems to be working perfectly now. So in order to verify, let me open our MobaXterm. Perfect. So we are avoiding browsers because of the caching issues that it generally has. So this time I'll do a curl on HTTP example.com. And you see, first request goes to, this is our backend server. Let's run this again and now you see the request went to the different container. Let's try this out once more. Again, it went to the backend server. We'll try one more. It went to a container. So what exactly is happening over here is that we had two backend servers which are configured. First request went to the first backend server, second request went to the second backend server. Again, the third request which you send goes to the first, and the fourth request you send goes to the second backend container. So this is the very basic load balancer configuration. I would really suggest you go ahead and practice this once. It is very simple. If you see, we did not really do a lot of technical stuff. Very simple, and this is the beauty of NGINX, which makes things quite simple. So this is it about this lecture. Go ahead and try this out once, and if you have any questions, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back. So since we now have a working configuration of a load balancer that we did with NGINX, the next important topic is health checks that we have to look into. So let's look into the basic of health checks. Now, one of the very important capabilities of a load balancer is the health checks of the backend servers. Now, this is very important. So let's give an example. So we have two backend servers over here, and you have your load balancer, which equally distributes traffic across both the backend servers in a 50-50% configuration. Now, due to some reason, the backend server 1 failed. Okay. Now, once the backend server 1 failed, you see the 50-50% configuration went away, and now the entire 100% of the traffic will be directed to the backend server 2. Now, after some time, once the system administrator fixes this server, and once the server is up, then this 100% configuration will go away, and then what you have is you have a 50-50% configuration back again. So in order to make this working, there has to be a way for the load balancer to know whether the server is up or the server is down, and this is one of the very important capabilities of a load balancer. Now, there are various ways in which you can actually detect whether the server is up or down. But before we look into that, let's look into the practical session and see on how this would actually look like. So we already have 3 containers here, and these are based on the load balancing configuration. So if you just look into here, this is something that we did in the last lecture. If I do a curl on example.com, the first request will go to the container 1. The next request will go to the container, other container. Again, container 1, you have container 2, container 1, container 2. So you see there is a round robin based 50-50% configuration or 50-50% based traffic routing that is really happening. Now, let's do one thing. Let's actually create a scenario where one of the containers stops working. So let me connect to the container, one of the containers, and let's stop the NGINX over here. Oops. Okay, so now we have stopped the NGINX. So we have created a scenario where one of our backend containers or backend servers is stopped working. So now NGINX should be able to detect, because it is a load balancer, it should be able to detect that this server is not working, and then once it detects, it should pass the traffic to the working backend server. So let's look whether it really does the job. So now if I do, you see it went to the container 3. Again, if I send a request, it went to container 3, and again when I send a request, it went to container 3. Perfect. So let's start the NGINX again in the backend server. So now what actually happened was, once the Nginx was able to detect that the backend server was down, it actually stopped sending the traffic to the non-working backend server, and all the traffic went to the working backend server. Now after a system administrator fixes this server, then Nginx, depending upon the health check, will again start to send the traffic back. So now that we have started our Nginx, that means our backend server is up and running once again. If you send the traffic, you see it is not being sent to the first server. So there is some kind of a time interval which the Nginx will wait for once the server is down. So once the server is down and it is not responding, Nginx by the passive health check will wait for certain amount of duration. Let's assume 20 or 30 seconds. So for that amount of time, even though the server is up, it will not send the traffic back. After that duration has completed, Nginx will again send the traffic according to the passive health check. So now you see, after a certain duration went, now again it will go to the load balancer based round robin method. So this is the basic on how the health checks would really work. So let's look into the two types of health checks which are available, which are active health checks and passive health checks. So these are the two type of health checks which are available as far as the Nginx is concerned. However, when you talk about active health checks, this is the ideal way of doing a health check, but this type of health check is not part of the Nginx free version. This is part of the Nginx Plus, which is a paid subscription. So when you talk about the free one that we have been using till now, it only supports the passive health checks. And we will be looking into both passive as well as active health checks in the upcoming lectures. So I hope you understood the basic about the health checks, and if you have any doubts, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back. Now in the earlier lecture, we looked into basic on why health check is important for load balancer. So what we'll do is today we'll look into one of the types of health checks which Nginx supports, which is passive health check. So let's go ahead and understand more about it. So in passive health check, Nginx monitors the communication between a client and an upstream server. If the upstream server is not responding or rejecting the connections, the passive health check will consider the server to be unhealthy. So this is the basic about passive health check. This will become much more clear when you take a look into our nice little animation that we do. So you have two servers, you have a load balancer which evenly sends the traffic. Now let's assume that this server 1 went down. Now by default, Nginx will not know that the server is down in passive health checks. So Nginx still assumes that this server is up and running. Now there is a traffic which came to the Nginx server. There are 5 requests. This is request 1A. You have request 2, request 3, request 4 and request 5. So Nginx still does not know that the server is down. So what Nginx will do? The first request, it will send to the first backend server. Now the backend server is not responding, or it is timing out, and it did not send a reply back to the load balancer. So since load balancer did not get a reply, it sent this request to the second backend server, from which it got a successful response back. Perfect. Now there is a second request, which is request B, which now load balancer sent to the backend server 1. Backend server again did not reply back, or it timed out. And since it timed out, or since this server is not responding, The load balancer took the request and sent it to the backend server 2, from which it got a successful reply again. So now what load balancer checked is, I am sending 2 requests. I sent 2 requests within a certain duration. Let's assume 2 requests within 10 seconds. And for both of the requests, I did not get a reply back from the backend server 1. So load balancer will assume that this server is down and it will stop the communication with this server, or it will stop sending requests to this specific server for a specific amount of time. Let's assume 30 seconds. Now within this 30 seconds, even if this is a 30 second, let's assume after only 5 seconds the server is up and running, but this connection will be broken for that 30 seconds. So even though the server is running, but in order for the traffic to be sent here, the load balancer will wait for 30 seconds. And after the 30 seconds interval has passed, what will happen is load balancer will remove the connection, and the next request, which is request C, it will try and again send to the backend server 1, and this time it received a successful response, and now the load balancer will again assume that the server is up and running, and it will move to the 50-50% based configuration. So this is how the passive health check works, and we have already looked into this in the earlier lecture, where I am into one of the backend server 1 and I stopped the process. So I say service nginx stop. So from my curl client, when I send a request to example.com, the request is going to the backend server 2, since the backend server 1 is down. So now I'll start the backend server 1. Okay, so now the backend server 1 has started. However, if you see, if I still send request, the first 2 requests went to the server 2, and after a certain amount of duration went by, Nginx again started to send a request to the server 1 to check if the response is successful or not. And now you see the response is successful, and then you will automatically switch to the round robin based configuration again. So this is the basic about passive health checks. There is one more which is called as the active health check, which we'll be looking in the subsequent lectures. So this is it about this lecture. I hope you understood the basic about passive health checks, and I look forward to see you in the next lecture. Hey everyone, and welcome back. Now in the earlier lecture we had discussed the basics about passive health monitoring. However, in that approach, all we were doing is we were using the default configuration. So today we will be customizing the passive health checks according to our requirements with some additional parameters. So this is our container, which basically has the load balancer related configuration. So I'll connect to this specific container with docker exec it. I'll paste and I'll go to the bash shell. Perfect. So if you go to etc nginx conf.d and open up the kplabs.conf file. So there are 2 upstream servers over here, and the passive health checks actually apply over here. So any parameters that we want to give related to health checks has to be under the upstream block. This is one important thing to understand. Now, there are 2 important parameters as far as the passive health checks are concerned. One is the max fails, and second is the fail timeout. So let's do one thing. Let's try this out. So let's put them. I'll say max fails is equal to 2 and fail underscore timeout is equal to 30 seconds. Let's just verify. Okay, it seems to be proper according to our configuration, and I'll save this. Let's do a nginx-t. The configuration seems to be successful, so just do a service nginx restart. Perfect. So now what actually we have done is we have set to the NGINX load balancer that if this specific server fails to respond or gives a connection timeout 2 times within 30 seconds, then stop sending any traffic to this server for the next 30 seconds. I hope you got it. If the load balancer does not receive any reply or it receives connection timeout from this specific server for 2 consecutive times within 30 seconds, then what load balancer will do is load balancer will consider this server to be unavailable and it will stop sending request for the next 30 seconds. Perfect. So I hope this makes sense. So let's do one thing. Let's open up the command prompt and do a docker ps. I'll connect to the 172.17.0.4 server. So okay, let's quickly verify if this is the right server. Perfect. So this is the right server. Just to re-verify if everything is working, you will see that we are based on the round robin based default configuration and everything seems to be working now. So what I'll do, I will stop the NGINX over here. Now, since the NGINX is stopped, the load balancer does not know that the server has gone down. So only way for it to know whether the server has gone down in passive health check is when the server stops responding to the requests. So let's try again. So I'll do it responded back. Now the next request will go to this specific server and it went and it failed. So let's try it one more time. And now what happened is that the server did not respond for 2 consecutive requests. So now what will happen? Now let's start the NGINX. Now the NGINX is started. Now if I do a curl, you see it will only go to the backend server which is responding for the next 30 seconds. After 30 seconds, the request will start to go into the other backend server which we had intentionally failed, you see. So this is where it really works. So it waited for 30 seconds and after 30 seconds, NGINX decided to allow one request to go to this specific server. It responded back and now NGINX will consider this to be healthy. Now, depending upon your configuration, you might actually decide to make it as 60 seconds or 120 seconds as well. And if the server did not respond for 2 consecutive times within the failed timeout interval, then NGINX will stop the connection to that server for the same amount of time which is configured over here. So I hope you understood the overview about the 2 parameters that we put in the passive health checks. Go ahead and try this out and I look forward to see you in the next lecture. So in the last video we were talking about the passive health monitoring, and in this video we'll have an overview of difference between an active as well as passive health monitoring. So before we go into what an active health monitoring is, let's just revise again on what a passive health monitoring is. The reason I'm putting more emphasis on passive health monitoring is because it is important to know what a passive health monitoring is and how active is more better than passive. So I've decided to use new color of pen. So just for change, I hope this is good and visible again. So one of the drawbacks of the passive health monitoring is that there is no direct way of a load balancer to know whether server is down or up. So let's take an example again. So this is server 1 and this is server 2. So by default, load balancer does not have any mechanism to figure out whether the server are down or server is up.
So the way in which passive health monitoring works is, let's say these are the 5 client requests. So load balancer or Nginx will send the request first to server 1. So let's say this is request A, and if server 1 fails to respond due to some reason, then the load balancer will assume that the server 1 is down, and then it will send the same request to server 2. And this is how it works in passive health monitoring. So one of the disadvantages is that client will have to wait for bit longer time in order for request to be preceded. So let's see on how active health monitoring helps. So let's go down, and this is active health monitoring. So what active health monitoring does is, it tries to contact to the server, both the servers, every 5 seconds. So by default the interval is 5 seconds. So it is something like every 5 seconds load balancer will try to connect to the server and will check if it is getting response from the server or not. If it gets the response from the server, then it will assume that the server is up. If it does not get the response from the server, it will assume the server is down. And then whenever the client request comes, it will only send a client request to the server which is on the up state. So here the major difference is that in active health monitoring, it will not send client request to the server which is down. So the load balancer has the intelligence to detect whether a server is up and running or it is down. So let me show you on how exactly it works. So this is my NGINX Plus machine. Active health monitoring is only supported in the NGINX Plus version, so it will not work in normal Nginx. So this is my NGINX Plus machine. I'll show you there, and here Nginx is running. So this is the NGINX Reverse Proxy, and in the upstream this is one of the servers. So let me actually do the tail of the log file. So let's wait. So here you see every 5 seconds the Nginx reverse proxy will send GET request to this particular server and verify if the server is up and running. If the Nginx load balancer will get 200 or between 200 and maybe 300 responses, then it will assume that the server is up. And if it gets say 404 or maybe 500, then it will assume that the server is down. So every 5 second Nginx will try to connect to the server and check whether the server is up and running. And this is one of the ways in which Nginx will make sure that the servers are up and running. So this is the overview of difference between a active health monitoring and a passive health monitoring. So we will be talking about both of them in detail in the upcoming videos. So I hope this short lecture has been informative for you, and I'd like to thank you for viewing.
Hey everyone, and welcome back to the Knowledge Portal video series. Now continuing a journey with the load balancer health checks, today we'll be looking into the active health checks. So let's get started with this. Now a basic Nginx Plus instance can periodically check the health of an upstream server by sending a special health check request to each server and check for the response. So what this basically means is, if this is your Nginx Plus which is acting as a load balancer and there is a upstream server. So in active health check, what really happens is the Nginx Plus will periodically send a special GET request to the upstream server to verify if it is working perfectly or not. So you have a GET request. So this GET request will be sent periodically to the upstream server, and ideally it will wait for a perfect response. Now, if there is any communication error or timeout occurs, or if Nginx Plus receives a response code other than 2xx or 3xx, the upstream server is marked as unhealthy. So, because ideally what you would want is for the GET request, you would want a 200 OK. So that is the ideal condition, but sometimes you might get 404 or 500. So those response code basically means that there is something wrong that is happening in the upstream server. So in that case, the load balancer will consider that the backend server has stopped working and it will mark that server as unhealthy. So this is about the active health checks. One important thing to remember over here, that active health check is only supported in the NGINX Plus. It is not supported for the NGINX free version that is available. So I have my NGINX Plus server which is up and running. So I am connected to the NGINX Plus server. So if you do a service NGINX status, I have my NGINX up and running. So this is basically the NGINX Plus version. So if you go to etc nginx conf.t, and I have configured this server to act as a load balancer. So if I go to server.conf, you have a proxy pass to backend, and within the upstream backend you have one server. So this is a Docker container which is listening on the host port 8080. So if you just want to see, I do a docker ps, and there is one Docker container which has a Nginx installed, which is binded to the port 8080 of my host machine. Perfect. So if you go into the configuration, you have a new parameter called as health check. So this health check parameter basically denotes that this is going to be an active health check. And what Nginx Plus will do is Nginx Plus will periodically send the GET request to the backend server to verify if the server is up and running. Now, the default time at which the Nginx Plus server will send the request will be 5 seconds. So every 5 seconds, the Nginx Plus load balancer will send a request, a GET request to my container, and verify if my container is up and running. So let's do one thing. I'll connect to my container, and here you see I have Nginx status. My Nginx is up and running. So if I do a tail on var log nginx access.log, what you really find is, let's wait for a request. So this is the first request. Now after 5 seconds there will be one more request, and after 5 seconds there will be one more request. So if you look into the timestamp, this is at 35th second, this is at 40th second, and this is at 45th, and you have at 50th second. So every 5 seconds you have your Nginx Plus load balancer health check which is coming. Now the health check method is get, and the response code that you see is 200. That means the Nginx Plus is receiving the response code of 200 OK from my backend server. Now along with that, I wanted to show you an interesting thing, because we are actually using the Nginx Plus. You have a nice little GUI. So this is the GUI. It actually gives you the high level information related to what is happening. So you have a upstreams over here, and within upstreams you find that there is one server which is present. So let's do one thing. Let's stop the Nginx in the upstream, so the health check will fail. So as soon as I stop it and I go over here, within 5 seconds, ideally the health check should fail. Let's just refresh it, and it did not. Let's just verify. Oops, we had ran a wrong command. There's a service Nginx stop. Perfect. And now I go to the GUI. You will find that the server, it is showing that one server is failed within the upstream. So this is a very nice way of telling for those who wants to see in a GUI way. So if you go to the upstream, it actually tells you the upstream server IP address, which is 127.0.0.1:80. It will also tells you related to how many checks have been happening. So every 5 seconds, this specific interval will be increased, and you see after this interval increases by 1, the fails also increases because the server is actually failing. So let's do one thing. Let's start the Nginx. I'll start the Nginx back, and in the next request, now the fail is 12. Now this will not increment and the server will go back to the green status. So if you go back to the GUI, you will see the alert message has gone away. So this is the basic about active health check. Now one thing that I wanted to show you is that we can actually modify this specific behavior because it is actually checking every 5 seconds. So you can modify it with the interval parameter. So if I put interval is equal to 10, now what will happen is instead of checking or instead of sending a GET request every 5 seconds, now the Nginx will send a request every 10 seconds. So if you do a docker ps now and do a tail on var log Nginx access log, what you will find here is that now the request that will be coming will be with the interval of 10 seconds. So this should be 29. So this is 29. Now the next request will be on the 39th second. So let's just wait. You have 39. So similarly, you will have a interval of 10 seconds before the health check is being sent. So this is the basic about the active health checks. I hope you understood the difference between an active health check and a passive health check. And go ahead, and if you have the Nginx Plus instance, go ahead and try this out once because this seems really fun to do. So with this, we'll conclude the lecture. I hope this has been informative for you. And if you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now in the earlier lecture, we looked into the basics of health checks. Now one thing that I would like you to see is that by default, whatever health check which is being performed is performed on the slash. So if you go to var log nginx access.log, the health check is actually performed on the root, which would ideally be the index.html file. But this is something that we will be able to modify in the Nginx Plus configuration. So let's go back and edit our server.conf. Now within the health check, I'll specify URI is equal to /test.txt and I'll save it. We'll verify if the Nginx seems to be proper. Perfect. And I'll restart our Nginx server. Now I'll go back to the Docker container and we'll do a tailf and var log nginx access.log. And now you see what is happening is instead of slash, this time the Nginx Plus is sending a GET request on /test.txt. Now since we do not really have this specific file, the response code is 404. Basically that means not found. And in the similar way, if you go into the upstream, you find that the server is failed. Now even though my Nginx is running over here, the server is actually running, but the Nginx Plus is not getting a proper response of 200 or 300 series for the get test.txt. So in order to solve this, let's go to user share Nginx HTML. So this is the default document root, and I'll do a touch on test.txt and I'll put echo hi within this specific file. So now if you do a tail, what will happen is the next request that it receives for test.txt is of type 200, which means processed successfully. So now if you'll see over here within the upstream, the server is up and running again. So this is one parameter that you can use. Now along with this, there is one more interesting thing that I wanted to show you. Let's try this out. So I'll say match server underscore test. Within this, the status I'll say between 200 to 399, and the body, let's say if body is not equal to maintenance, and then close this server block. Similarly, within here I'll say match is equal to server underscore test. So let's do one thing. Let's quickly verify if the syntax is proper, and I'll restart the Nginx server. So we'll see on what exactly we have just done. So URI part, I hope you understood the URI part. Now within this, I have included a match condition. Now again, this match condition is only for the Nginx Plus. So within this match condition, I have defined the block with a name server underscore test. So these conditions which are part will be included within the health check. So what exactly is the part over here? Let's consider this part first, which is the body. So this basically says that look for the contents within test.txt, and if the content does not have this specific word, then you can consider this as successfully working. So let me show you. Now you see the upstream is not giving you an error. However, if I go inside the Docker and let's modify the test.txt file as a user share nginx html test.txt. This time I'll use a word maintenance. Okay, and I'll press Y, and let's go to our status, and you see the server is actually failing. So if you would like to see the log, I'll just open it up, var log nginx access.log. Now you'll see that even though the Nginx Plus is sending on test.txt and the response code is 200, that means it is successfully processed. However, even with this, the health check is actually showing as failed. And the reason, again, we have already discussed, the reason is because the body contains a word called as maintenance. Now it happens a lot of times that a website might actually work, the backend server might actually work, but the contents within the website is having certain kind of a error message, like error connecting to the DB instance. This is a very common error that you will find. So in those cases, you want Nginx to stop sending requests to those servers. So this is one option. Now the second way you can do is, you can say that the body must contain, I'll say welcome to Nginx. Now if a body will contain any other things other than welcome to Nginx, or if the body will not contain this specific keyword, then the overall status will fail. So let's quickly verify this as well. So I'll restart my Nginx. Now currently, since the test.txt is showing as maintenance, it is failed. So next time if I do docker ps, I go to user share nginx html test.txt, I'll remove this word and I'll say welcome to nginx. Perfect. So now what will really happen is ideally this alerts should go away if we have not done any mistake, and it doesn't seem to be going away. So we seem to have done some mistake somewhere. Let's verify. It is test.txt user share nginx html. We'll verify the contents. It says welcome to nginx, but still here it is showing an error. Okay, so let's quickly verify. The body is already welcome to, you have a capital N over here, so this is the reason why it is failing. Now let me change it to the small n and I'll restart. And now what you will see is the server, the health check is successfully passed. So this is very important, and this is one directive that I really like, which is the match directive, which is part of the active health check of the Nginx Plus configuration. So this is it about this lecture. I hope you understood the importance of a URI and the match directive within the active health checks. I hope this has been informative for you. And if you have any doubts, suggestions, questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching.
Hi and welcome back to the Knowledge Portal video series. So in the last few videos we were talking about the passive health monitoring as well as the difference between an active as well as passive health checks. So in this module we'll be talking in detail about active health monitoring as well as shared memory for worker processes. So we have already discussed the basic NGINX architecture, so I assume you already know why worker and master processes are used for. So basically here we have 3 clients and we already know clients connect to the worker processes. Now let's assume that this is client 1, this is client 2 and this is client 3. Now client 1, let's say it's connected to the worker process 1. So this is where the client 1 is connected. Now worker process 1 tries to retrieve the resources from the server pool. So there are 3 upstream servers over here. I write 3, and it first contacts the server 1. So this is server 1 and the server 1 fails to respond back. So it writes an entry into its table saying server 1 is down. Then it tries to contact, let's say, server 3. Even server 3 fails to respond back. So it writes an entry to the table saying the server 3 is also down. And then finally it contacts the server 2 and the server 2 responds back. So for this particular worker process, the server 1 and server 3 are down because they are not responding. So any new request that this particular worker process will get, it will not send to this server 1 and server 3 for a certain interval of time. It will only send those requests to server 2. Now one of the issues is that the table is specific to a worker process. So let's assume that the client 2 connects to the worker process number 4. Now according to the worker process state table, there are no servers down. So it will try to contact server 1. Server 1 is not responding. So it will write server 1 is down. Then it contacts, let's say, server 3. Even server 3 is not responding. And it will note that the server 3 is down. Then it will contact server 2 and server 2 responds back, and again worker process 4 knows that the server 2 is up and running. Now the problem with this type of approach is that every worker process has different zone file for maintaining the state table, and this is a big problem. So this is resolved with the help of shared memory. So let's go down and let's see on how shared memory based architecture helps. So what happens in shared memories, there is one common zone file, and this zone file is read by all the 4 worker processes. So taking the same example again, so client 1 connects to this particular worker process. This worker process will contact server 1 and server 3, and they fail to respond. So the worker process will write an entry to the state table saying server 1 and server 3 are down. So if client 2 connects to the server 4, server 4 can read the zone file from here and can easily make out on which servers are up and running or which servers are down. So here the worker process number 4 knows that the server 1 and server 3 is down, so it will directly contact the server 2 instead of trying to contact server 1 and server 3 again. So this is why it becomes beneficial to have a common zone file. So in active health monitoring, we use a common zone file for all the worker processes. So let me show you the example. So let me open the NGINX configuration. I have already configured this NGINX for active health monitoring. So there are 2 new directives over here. One is zone and one is health check over here. So zone we have already discussed. So this zone is basically the shared memory. So this is what we were talking about. So zone backend 64K. So 64K is the amount of memory that the zone file will have. So this is the reason why we have mentioned zone backend 64K. So for this backend, there will be 64K of shared memory which all the worker processes will be using. And the second thing that we have to add in the active health monitoring is we have to add health_check directive. So by default, once you add the health_check directive, it will start to send the GET request to both of the upstream servers every 5 seconds and verify that the servers are up and running. So again, we have already discussed this in the last lecture also. If I do a tail over here, you see it is actually sending the GET request every 5 seconds to make sure the server is up and running. And this is what a basic active health monitoring is. So always remember, if you are using active health monitoring, you will have to have a common zone file and you need to include the health_check parameter beneath the proxy pass directive. So this is it about the basics of active health monitoring. We'll be discussing in more detail about this in the upcoming video. So I hope this has been informative for you, and I'd like to thank you for viewing.
Hey everyone, and welcome to the Knowledge Portal video series. So today we'll be speaking about an important topic which basically rules our internet life behind the scenes, and the topic name is called as caching. Now I'm very sure that most of you might have heard about this word caching, and caching proves to be a great importance as far as the HTTP protocol and browsing is concerned. So let's go ahead and understand the basics about caching. So with our favorite example that we take every time, you have a client and you have a web server. So a client basically sends a request. So in our case, it is get request on myseed.png, and the web server responds back with a PNG file. Now this is a very simple HTTP request and HTTP response. Now the problem that arises over here is what happens if the client sends the same get request 10 times, like he keeps refreshing the page. So this get request will be sent to the server 10 times, and the server will have to process and send the response 10 times again. And basically this might not seem to be a big issue, but when you talk about big websites like Facebook, Amazon, or any big websites you can consider, they have like millions of users who visits their website every day, and most of us, we refresh the page. Like how many of you open Facebook? Like many of you open like 10 times a day, 15 times a day. And basically what happens, like there are certain static contents like your DP picture or DP of your friends that will not change often. So the more you open, the more same request will be sent to the web server, and the more web server will have to process the same response back. So this is where the problem arises. And in order to solve this, there needs to be a basic caching mechanism, and this is something which is implemented. So what happens in cache mechanism is there is a middleware server. So this middleware server is responsible for caching. So now what happens is the client sends a request. The request is forwarded to the web server with a cache in middle. Now in the response, the web server responds back to the cache, and the cache sends the response back to the client. Now let's look it in a HTTP way. So the client sends a request called as get on myseed.png. The request is received on the cache server. Cache server will send the same request to the web server. Now since this is a get request on myseed.png, the web server will respond back with a file. So this is the myseed.png file. Now what cache server will do is, cache server has its own storage. So what cache server will do, cache server will store this file myseed.png within this storage, and then it will reply back to the client with the file. Okay, so now what would happen is, if the client decides to refresh the page, then what would happen is, or if there are multiple same requests, now we already know that the cache server has stored the myseed.png file. In that case, if the user decides to refresh the page, you have get on myseed.png. So user is sending the same request again. So now what cache server will do, cache server knows that there is already a file called as myseed.png within its local store. So the cache server will respond with the same file. So in this case, what happened was the cache server did not send the request to the client or to the web server. It responded back with the local cache. Now this specific local cache can be a hard disk drive, or it can be a memory also, to fasten the things up. So let's look into how that would work. Now this local cache can be a dedicated server which an organization can have, or it can be a software based appliance also. So most of the browsers does have local cache. So this is mostly a software appliance as far as the browsers are concerned. So let's look into how that would work. So I have a Firefox browser. So if you go into about:cache, this will basically tell you all the caching related information which the browser keeps. So you can consider this as a software appliance of the browser. Now there are two important things to remember is that the cache can be stored in memory and the cache can be stored in disk. Now if you store it in memory, then definitely it will be much more faster. However, disk is also quite fast but not as fast as memory, but overall retrieving files from disk is much more faster than actually contacting the web server and fetching the files. Now if you go look into the disk, it basically tells you how many entries are part of the cache. It also tells you about the storage and the storage location where the cache is stored. So now if you go to list cache entries over here, it will basically tells you what are the files which are being cached over here. Now along with that, it tells you about, it talks about the fetch count, basically tells on how many times the item has been fetched. It talks about the expiry time of that a specific cache value. So if you look into this specific entry, so this is something related to a PNG file, stars.png, which is of 1 to 73 bytes. It has been fetched 2 times in total, and for how much time it will be cached. So it has, the first retrieval time was 24/10/2017, and it has been actually cached for a good amount of time. You see, 11/1/2027. That is actually a amazing caching amount of time. So generally files are cached for like 1 year, but these seems to be quite good enough. Anyways, so let's do one thing. What we'll be doing is let's open a file, the dexter.kplabs.in/myc.jpg. So this is basically a image file which is retrieved from dexter.kplabs.in/myc. So now if I keep refreshing the page, question is, should a browser send a request to the web server every time and expect a response? That would be much more slower. So in this case, what the browser will do, a browser will basically cache the image file. So now what would happen is, if you look here, the fetch count is 13. So this basically means that this file is already cached and it has been fetched for 13 times in total. It talks about the last modified time and it talks about the expires time, like when will this file expire from cache. So next time, even when you refresh the page, the chances are that it will be retrieved from the browser cache and the GET request will not be sent to the server directly. So this is it about the high level overview about what the caching is all about in HTTP protocol. Now definitely one last thing that caching does bring, if you note, it does bring a good amount of benefits. Now one of the very good benefits is that it reduces the overhead of the server resources. Now since the browser is retrieving the file from the cache, the web server does not have to process the response and send it back to the client. So it basically reduces the overall overhead. Second is, it decreases the network bandwidth. Now every time a user refreshes the page and if the request is sent to the web server, then the overall network bandwidth will be tremendously high. And since now a browser retrieves it from the local cache, the network is not congested. And third, pages are loaded much more faster since the entries are cached within the desktop or within the server itself. So these are some of the benefits of caching. In the upcoming lectures, we will be speaking in great detail related to caching and caching related headers. So this is it about this lecture. If you have any doubts, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching.
We have already seen on how we can add a HTTP expire header for different file formats as far as Nginx is concerned. So let's go back to the configuration file just to revise. So if we look over here, the any file which ends with .png, it is set to expire for 1 hour. So if we do a curl example.com logo.png, you see it is actually expiring for 3600 seconds, which is 1 hour. So this is just a header fields. So how can we be like 100% sure that browser is actually storing this particular file in its cache for maximum of 1 hour? So let's see on how we can be very sure that the browser is doing as instructed in the HTTP header fields. So this is a Mozilla Firefox browser. So let's go to about cache, and this basically gives caching related information as far as browser is concerned. So if we see over here, the number of entry in the disk is 1696 and the number of entries in the memory is 0. So let's open a image file from the server, say example.com image1.png. Now before we open this, just make sure this is 1696, and if I see, the image has been loaded, and if I refresh the page, you see the number of entry has been increased by 1. So if I go to list cache entries and if I search for image1.png, this is the URL that we had opened. This is the size of that particular URL, and here it is also saying the time of response and when the response will be expired. So this is the time where the cache was stored, which is 7.5, and at 8.5 this cache will be expired. So if we look into the header field, you can see the cache is expiring exactly after 1 hour. So now we can be 100% sure that the browser is actually storing this file into its cache memory for 1 hour. So this becomes very useful when debugging issues comes into picture. So this is short video. This is what I wanted to show to you. This is something which will be very useful in the production environment when you have caching related issues. So this is it about this small module. I hope this has been informative for you, and I'd like to thank you for viewing. In the last module, we have already seen on why the HTTP expires and the HTTP date headers are useful as far as the HTTP caching is concerned. So in this module, we'll configure our Nginx machine to include the expires header for different file formats. So for our scenario, we have two file formats that we'll be using. One is .txt and one is .png. So essentially they are the text and image file format. And for each file format, we will set a different expiry header. So let's see on how we can do that. So let me do a curl on example.com/logo.png. So sorry, logo.png. So if we see over here, the date header is included. However, there is no expires header for this particular file. Same goes for the sample.txt. The date header is mentioned, but there is no expires header. So let's see on how we can configure the expires header for both of them. So I'll go to etc nginx conf.d, and let's open web.conf. Now this is a simple configuration file. So let's add one more location directive that will basically specify for any image file on the website, cache that image for, let's assume 48 hours. So browser, when it opens image from example.com, it will cache it for 48 hours. So let's include location directive, say for any image, say I'll say PNG file. You can even include JPEG. I'll say expires 48 hours. You also have to mention the root location for the images, which is, I'll just copy it from the here. Okay. Okay, so the expires directive basically tells that any file that ends with PNG extension, which is from this particular directory, the expires of that file should be 48 hours. So basically what Nginx will do is Nginx will add a expires header which will expire after 48 hours of the time of response. So I'll save this particular and let's do Nginx T. Okay, let's reload Nginx. Awesome. So now if we do a curl I on HTTP example.com logo.png, then now you see an expires header has been introduced. Now we have already mentioned 48 hours. So if we look into the date header is 18th November, Wednesday at 1:10, and expires is 20th November at 1:10. So this is exactly 48 hours from the time the response has come. Now if you also notice, Nginx has also introduced the cache control header max-h followed by the seconds. So this basically, if you multiply, then it becomes 48 hours. So this seconds corresponds to the number of hours after which the image or the cache should be considered stale. Now we have already discussed expires header is specifically for the HTTP 1.0 protocol. In the 1.1, the Nginx or the HTTP have introduced a new header field which is cache control, where the expiry is mentioned in seconds. So for all the HTTP 1.1 client, they'll actually read the cache control directive and not the expires header field over here. So even if you don't mention explicitly, the cache control Nginx will automatically add when you add the expires field within the location directive that we have already added. Now this is specifically for the image file. So if we go on sample.txt, still it is not showing any expires header. So we have to specify for the text file as well. So if I will have to add one more location directive, say for anything which end with .txt, root would be the same, I'll say expires, I'll say 1 hour. I'll save the file and I'll reload the Nginx. Let's clear the screen and let's do a curl again on example.com/sample.txt. And now you see the expires header has been added, and for ease of readability it is 3600 seconds, which counts to 1 hour. So it will tell the cache that this response can be considered as the latest response for 1 hour. Now, going back to the web.conf, you can actually specify the negative value as well. So if I say -1 over here, and let's do reload, and if we curl, here you see basically the date was 114 and the expires is also 114. So basically this means that do not cache this particular response. So sample.txt should not be cached. So even if you see in the cache control, there is a new field which is no cache which has been introduced. So if you want to include, or if you want to instruct the browsers to not cache this particular responses, then you can actually say expires -1 and this will do the job. So this is it about how you can include the expires header as far as the responses are concerned. So this is it about this module. I hope this has been informative for you and I'd like to thank you for viewing. Welcome back to the Knowledge Portal video series. Today we are going to talk about a very important aspect of the HTTP connection handling, which is keep alive connections. So we have two examples over here. This is example 1 and this is example 2. So example 1 is one of the old ways of doing things in the HTTP protocol. So let's see on how it works. So there is a HTTP request which has been sent from client to the server, and corresponding to the request, the server sends a HTTP response back. Now, as we know that HTTP works based on TCP protocol, and in TCP, before any data can be sent, there has to be a three-way handshake that has to occur. So essentially, before a HTTP request is sent from the client to the server, there has to be a three-way handshake that has to occur, and this indicates three-way handshake. So this is an open function call and this is a closed function call. So the gap between these two indicates a single TCP three-way handshake connection. Now, in the older times when the HTTP protocol was introduced, for a single request and response, there used to be a single TCP three-way handshake that had to occur. So essentially, if you want to send a bunch of request and response, say here there are 3 request and response based packets, and for 3 request and response based packets, there were 3 TCP three-way handshake that used to occur. Now, it doesn't seem much, but nowadays, if you compare the modern based websites where there are a lot of jQueries, JavaScripts, even CSS files, even if you open a single website, essentially a browser has to make around 50 to 60 HTTP requests to the server. And if we still implement the old way of doing things, then for 50 HTTP requests, there has to be a 50 three-way handshake that had to take place. And this is not an optimal way of doing things, because not only it consumes lot of bandwidth, but also TCP three-way handshake in itself is a CPU consuming thing. And this was one of the reasons why keep alive based connection were introduced. So what happens in keep alive based connection is, whenever a client sends a request to the server, it adds a keep alive in the connection header saying please do not close the connection. And in response to that, the server sends the response saying that I am not going to close the connection with a keep alive header. So essentially, if we compare these two examples, in order to send 6 packets of HTTP request and response, there were 3 TCP connections that had taken place. However, if we talk about modern based approach, there is only one TCP three-way handshake, and within that there are multiple request and response based packets that takes place. So essentially this is what is a optimal way of doing things. So if we look into how exactly it looks, so a client sends a GET requests, and along with that, in the connection header, it includes a keep alive directive, and in response to that, the server sends a response with the keep alive directive saying that the connection is not being closed. So let's look on how it looks in the Wireshark. Then the concept will become much more clearer. So what we will do is we'll see both the approaches and we'll compare on why the first approach is not an optimal way of doing things. So I've configured my Nginx to not use keep alive. So essentially we'll be using the old approach first. So I'll go to Firefox and let's open our inspector and let's go to example.com followed by mindex.html. Before we run this query, I'll open up my Wireshark and start a packet capture. Now I'll just open this up, and essentially what you have seen over here is there are two requests which are made. First is for this particular text and second is for the image file. So I'll just close the Wireshark packet capture and let's look at what has happened. So if I go to view source, the first source is for the text document that we have seen, and the second request, which is mindex.png, is made for the image file. So comparing the old way of doing things, as there are two requests which are sent, essentially there will be two instances of TCP three-way handshake that would have occurred. So let's verify it with our Wireshark once. I'll go to follow TCP stream, and essentially if we minimize this, here if we see, this is the first TCP three-way handshake since SYNAC and ACK. This includes or this indicates the open connection. So this open connection indicates the first three packets, and after the server sends the response to the GET request, so this is where the response has come, the connection is closed with SYNAC and ACK. Now let's go to the next TCP stream, and again for myindex.png. So this essentially is the second GET request. There is a new TCP three-way handshake connection which has taken place. Once the response comes from the NGINX server for this particular request, the connection is closed again. So essentially for two HTTP request and response that we have seen over here, there are two three-way handshake that has occurred. So if I show you my NGINX configuration, here we have actually disabled the keep alive, and that is one of the reasons why for each request and response there is a new TCP three-way handshake that takes place. So let me actually comment it out and let's use keep alive based connection. I'll save this and I'll restart the Nginx. Now let's start the packet capture again. I'll clear it up and let's go to the browser. I'll open up a new tab, example.com, and this time we'll load mindex2.html. So essentially same thing has happened. Two requests has been sent, and now if we look into the Wireshark, and if I go to the follow TCP stream, within the first TCP stream you see everything has occurred. This is the first GET request and this is the second GET request, and both of the GET requests are under the same TCP three-way handshake stream. And this is what the keep alive based connection means. So if we look into the connection header, the browser has sent a keep alive and the server has also sent keep alive. And this is one of the reasons why multiple requests and response can be sent within a single TCP three-way handshake. So let's open the inspector and let me go to knowledgeportal.in. This is just for an example. I just want to show you on how many requests are sent from the client browser to a modern based website. Okay, so the page has loaded, and if we see over here, there were total of 104 requests which were sent overall from loading a single web page. And this is essentially the reason why having a keep alive based persistent connection is very essential. So in the HTTP 1.0 protocol, the keep alive header was introduced. However, for HTTP 1.1 based protocol, keep alive is a mandatory thing. So in 1.0, having a keep alive is an option. However, for HTTP 1.1, all the sessions are assumed to be persistent. That means all the connections should have a keep alive based headers. So this is it about this lecture. I hope you got the basic reason on why the keep alive header was introduced in the HTTP 1.0 and mandatory in the HTTP 1.1 based protocol. So this is it about this video. I hope this has been informative for you and I'd like to thank you for viewing. Welcome to the Knowledge Portal video series. So today we are going to talk about two of the important HTTP headers which are useful specifically for the HTTP caching is concerned. So revising the caching concept that we have already learned. So if a client sends a request, the request goes to the cache. Now if the cache does not have a response stored, then it will forward the request to the origin server. Now the origin server will send the response back to the cache. The cache will first store the response inside its cache memory and also send it back to the user. Now the question that comes is for how long the response should be stored in the cache. Should it be stored for 1 hour, maybe 24 hours, maybe 48 hours or maybe even 1 year? So you do not know that. And just storing based on probability is not a right way either. And this is one of the reasons why HTTP has introduced two of the important headers which are date and expiry. Now, expire headers basically defines for how long a resource should be stored in the cache memory. So expire headers can tell the cache to store the response maybe for 2 hours, maybe for 1 hour, or to not store the response at all. So if we take a look into an example, this is one of the expires header that comes along with the HTTP response packet, and it says expires followed by the date. Now the date that it is sending is in terms of GMT and not the local date of the server. Now talking about the date header, the server also sends the current date of the HTTP response when it was sent. Again, if you notice, the date is in GMT and not in local. Now let's assume that the client is receiving this header. Now it might be possible that the date in the client system is bit out of sync. So it might be possible that during that time the response will not be properly cached. So it is very important that the cache response should be up to date and it should not serve stale responses. So this is one of the reasons why the date and expire headers are used in conjunction. So let's assume that this is the date and this is the expire which the Nginx sent in the response. So if we subtract this, you see the date is same 2353 and the expires is also 2353. However, the only difference is the day, which is 17th and which is 18th. So you see the so if we subtract this data, then we get 24 hours. So now the cache knows that it should store the response for 24 hours. So the response will be particularly valid for 24 hours. And after 24 hours, cache should contact the origin server again to get the fresh copy of the particular resources. Now, let's go to the Nginx server and see on how exactly it works. So let me do a curl I followed by HTTP example.com slash I have a PNG file and let me see, and here you see there is a date header which is introduced. So a date header is something that it is mandatory to send in all the responses. Along with the date there is a expire header also. Now if we see, the current date is 18th November 1237 and expires is 20th November 1237. So if we subtract these two header fields, then we can get that this is a 48-hour time period. So that means that the web server is saying that this particular resource logo.png should be cached or should be stored in cache for 48 hours. Now there is one more header called as cache control followed by max-age is equal to this particular value. Now this is in seconds, which also indicates 48 hours. Now we have already seen the difference between HTTP 1.0 and HTTP 1.1, and the expires header is specifically for HTTP 1.0. So for HTTP 1.1 there is new directive which is cache control which was introduced. So we'll be talking about this in more detail in the upcoming lectures, but for the compatibility we have expires header as well. Now this expires header, or you can say max age header, can be different for different kind of resources. So if I say sample.txt over here, and if you see over here the max age, the reason why I'm saying is because it becomes much more easier to read. So this is 3600 seconds, which is 1 hour. So if you compare this 0039 and 139, then it becomes 1 hour as well. And through this you can actually calculate, or a cache server can actually calculate on how long should it consider, or for how long should it store this particular response before it consider the response as old. So this is it about this module. I just wanted to introduce the two headers, which are date and expire. Again, just remember, date header is sent with all the responses, and expire header is something that we can configure depending upon the resources that we want to cache. The maximum amount that RFC basically recommends that you should cache is 1 year. So you should not store, or you should not tell the client to cache for a resource for more than 1 year. So this is it about this module. I hope this has been informative for you, and I'd like to thank you for viewing.
Hey everyone, and welcome to the Knowledge Portal video series. Now, in the earlier lecture, we were discussing about the HTTP caching and we had an overview about it. So continuing further, today we'll be speaking about the cache control headers in the HTTP protocol. So let's get started. Now, in the earlier lecture, we discussed about this use case where you have a cache server, and cache server has basically have the PNG file which was requested earlier by the client. So next time when the client refreshes the page, what would happen is that the request will go to the cache server. Now cache server already has this myc.png in the local cache repository. So instead of sending the request back to the server, what it will do is it will fetch the response from the cache repository and it will send it back to the client. Now there is one challenge over here, is that what happens if this file which is stored in the cache gets updated with a newer file. So let's assume that this cache copy is sent to the client, but on the backend side, this PNG file got updated on the server side. So in that case, what really happens is that client has got a stale response, or you can say client received a older response and not the newer response. Now there can be lot of such cases. Now one example I can share you is of a stock market or a share market, where what you want is you do not want anything to be cached, because if you get an older response, then there can be a huge financial losses. So in the domain of stock markets or in banking systems, you do not want things to be cached. So how do you do that? How can you tell a browser, or how can a web server tell a browser or a cache server to not cache the responses at all? And the answer is through the cache control headers. So cache control headers are basically used to specify various directives which are used for caching mechanisms. So there are certain directives of cache control headers, and these directives needs to be followed by the caching servers, be it in browser or be it a dedicated cache servers. So these headers are used to define various caching policies with various directives provided by the header. So there can be various caching policies which can be dictated by the website. So one of the caching policies is like do not store any kind of cache at all. So this is one caching policy. So this can be followed by stock market or banking systems, where they do not want client browsers or any caching proxies to store any cache. So this is one example. Second example is store the cache but verify with the web server whether the file is modified or not. This is second kind. Third example is store the cache for 24 hours. So these are three different examples that we have looked. So let's do one thing. Let's go into our practical session and understand this in more detail. Now what I have done is I have two files over here in our lab environment. One is nostore.png and one is myc.jpg. So let's do one thing. Let's do a curl. I'll do a curl -i on, let's do dexter.kplabs.in -myc.jpg. So now what will happen over here is that you don't really have any cache control headers. However, if you do a nostore.png, now you see there is one header called as cache control header and it says no-store. However, for earlier file, there was no cache control headers. So this cache control headers are the policies which are dictated by the web server to the caching servers. So caching server will read these headers and then it will determine what are the policies that it should apply for this specific file. Now again, since this cache control header says no store, then the browser will actually not store this specific file in the cache. However, as far as myc.jpg is concerned, since there is no caching policies which is explicitly dictated by the web server, the browser will go ahead and store this specific file in the cache. So we will be looking into this in a great detail in the next lecture, where we'll be speaking about the no store header. But for the time being, I hope you got what the cache control headers are. Now going back to our PowerPoint presentation, now there are various cache control headers directives which are present. So this is a cache control header and there are various directives to cache control headers like no store, no cache. They can be used in combination together, like no store, comma, no cache, comma, must revalidate. Along with that, there are other cache control headers like public, private. There are more of them. And we will be discussing about these headers with practical in the upcoming lectures to see what each of these headers really do. So this is it about this lecture. I hope you understood what cache control headers are all about. And if you have any doubts, suggestions or questions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching. Hey everyone, and welcome back to the Knowledge Portal video series. Now in the earlier lecture, we discussed about the cache control header. We also looked into the difference between two files where you have myc.jpg, which does not have any cache control headers, and you have nostore.png where you have a cache control header. So what a web server is saying to the client, that this specific file nostore.png should not be stored in the cache. And when you talk about myc.jpg, there is no explicitly mention by the web server on what to do with this file. So a browser may or may not store this file in the cache depending upon the browser caching configuration. So let's do one thing. Let's try this out in our browser so that we can know how exactly this would work. So I'll copy this file and I'll paste it in my Google Chrome. And if I press enter, you have a myc.jpg file. However, now if you go to about cache, let's try this out. You will see there is a file called as myc.jpg, which is stored in the cache of my Google Chrome. Perfect. So now let's copy the nostore.png file. I'll just copy the URL and let me paste it here. And here you have nostore.png file. Now again, this is an image file. So let's open about cache again. And let's verify whether we have myc.jpg, but we could not find the nostore.png. However, just to verify if you're not missing out, I'll do a Control F to search and I'll say nostore.png. So you don't really have a file. So this is just the Google result. So just ignore this. However, we are looking for a file. You can actually copy the URL to get a better result. So when you copy the myc.jpg URL, you are getting it. However, when you copy the URL of nostore.png, let me check this out. You see, you are not getting any result. So one important thing to remember is that browser will store the result as a key pair. Now I'll give you one simple example. So I have a about cache, and if you look into the caching entries, so let me open one of them. So you see the key is basically the URL, entire URL, and this is the reason why the key is the entire URL which is stored. So when you just copy the URL, you can find the URL as stored as a key in the caching entry. Okay, I hope this specific concept is much more clear to you. So let's do one thing. This is a small lecture which I wanted to show you. Go ahead and try this out from your side, see how exactly it will work. I'll make sure that these files exist in the server so you can do a practice from your side as well. And in the next lecture, what we will be doing is we will be configuring our own cache control headers in our Docker Nginx that we have been working with. So this is it about this lecture. Small lecture, but I hope you got the overall concept related to the no store header, and I look forward to see you in the next lecture. Hey everyone, and welcome back. Now in the earlier lecture we basically used our browser to look into how the cache control header really works. Now in today's lecture we will be configuring our own Nginx Docker instance to include various kind of cache control headers, and we'll start with no store for now. So let's go ahead. I have my Docker Nginx container up and running. Now before we start, what we'll do is we'll download these two images. So let's do one thing. So I have one image called as myc.jpg. I'll copy the URL and I'll do a wget. Perfect. And similarly, I'll copy the nostore.png. Perfect. So I have done wget for both of them. So you'll see both of these files are part of my Docker. Now just to avoid confusion, what I'll do, I'll rename the file called as dockerseed.jpg, and I'll rename nostore to docker nostore.jpg.png. Perfect. Now we have both the files up and running. Now just to verify if everything is working, I'll do a curl -i on http example.com dockerseed.jpg. You got a proper response, and you will see there is no cache control header over here. Similarly, I'll do a docker nostore.png, and again you will see there is no cache control header over here. So whenever you open this file in the browser will store the file in the cache depending upon its own configuration. So what we will be doing is, for this specific file or for this extension, PNG extension, we will be adding a new header called as cache control header, which signifies a no store directive. So let's look into how we can do that. So I'll go to our NGINX configuration, and if you look into kplabs.conf, we don't really have a explicit headers which are mentioned on. So we'll go ahead and create our own header. So I'll say location. For all the location which ends with PNG, or for all the extensions which end with PNG, I'll say root is var www websites. So this specific aspect I copied from here, and there is one important configuration which is add header. So add header will specify adding of new header in the response. Now I'll say cache control, and this actually is a problem with nano somehow in Docker when you use the CMD. So cache control will be no store. Okay, and I'll close the file. Let me do a nginx-t. Everything seems to be successful, and I'll do a service nginx restart. Perfect. So things seems to be working correctly now. Let's do one thing. Let's do a Docker no store. And now what you see is, you see there is a new header called as cache control, and the value is no store. Now we did one mistake. There seems to be 2 colon over here. This is not expected. So this is something which we added by mistake. I'll just restart Nginx and let's try this out. And perfect. So now we have a perfect cache control header for docker nostore.png. So as expected, browser should follow this header and it should not store the docker nostore.png. However, when you talk about the docker seed.jpg, as it does not have a cache control header, browser will go ahead and store this file in its cache. So let's try this out. I'll copy this URL and let's close the earlier terminal and I'll paste the URL docker seed.jpg. Perfect. So now we have the image. Correspondingly, we'll copy the second URL, which is docker nostore, and I'll paste it again in my Chrome. Perfect. So now we have both the images which you will see. However, if you do a about cache, since these are the key, I'll just copy the URL. So you have the URL over here, docker seed.jpg. You see the Chrome has cached this entry. However, now if I do, you see I do not really get any result over here. And this is what the no store header basically is all about. So last thing, just to reconfirm, the add header is basically used to add a header in the response. Now it will not add header for all the response. It will only add header for the response with the extension .png. So you have a location which is specific for extension.png files and specific for any file which ends with png. The add header directive will be included. So go ahead and try this out. This is quite interesting and fun to do. I hope this has been informative for you, and I look forward to see you in the next lecture with the next cache control directives. Hey everyone, and welcome back. Now in the earlier lectures we were discussing about the HTTP cache control headers and we looked into the no store header in detail. So continuing our journey with the cache control headers, today we'll be speaking about if modified since header. Now this is quite important header, and this specific header is sent quite a lot by the browsers. So let's go ahead and understand more about this header. Now we had looked into the scenarios where there can be multiple same requests by the browser. So if a user refreshes the page 5 or 10 times, then what ideally a cache does is it sends the response from the cache itself instead of connecting to the web server. So let's look into the scenario. So let's assume there is a file which is already cached in the cache server. So what happens is a client sends a request of get myseed.png. Now since the cache already has this file in its local storage, what it will do is it will send the file from the local store itself. Now this is quite good enough, but the problem is what happens if the file in the web server side is updated? Now in that case, the caching server has sent a older response. That means the new updated file is not sent because of the cache server's misconfiguration related settings. So in order to solve this kind of a issue where a older response might be sent, a new header is generally used called as if modified since header. So what really happens is, let's assume you have this is a myseed.png file which is there in this web server side, and it is also there in the cache server side. Now when a client sends a request, a GET request on myseed.png, although the cache server has this file, it will still verify whether the file which is there in its local cache is the latest updated one. So how can a cache server know how this file is updated or not? So what it can do is, the cache server will send a GET request on myseed.png asking whether this file is modified since this specific amount of time. So this time is basically the time associated with the last modified header of this specified PNG file. So the cache server will send a GET request asking if this file is modified or not after this specific time. If it is not modified, then the web server will send a response saying 304 not modified, and then the cache server will serve the file from the local cache itself. However, if this file is modified, then the web server will not send 304, it will send a 200 with a new file. Perfect. So let's do one thing. Let's go into the practical and let's understand this in great detail. So we have been looking into the practical and we'll try and keep the link same. So you have dexter.kplabs.in/myseed.jpg. Now if you do a curl -i on this specific URL, you will see there is one specific header called as last modified, and it has a modified, or it has the time at which this file was specifically updated, myseed.jpg. Now let's take the example of our Docker instance so that it will become much more easier for us to do practical. I'll do a curl -i and it contains the last modified time of this specific file. Now if you look into the, I'll copy this key, and in my Chrome browser, if you look into the about cache, you see this specific file is already cached. Now whenever I enter this in my URL, the entry should be retrieved from the cache itself. However, in order to make sure that the older file is not sent, what browser will do, what the browser cache will do is it will send a GET request to the server with a if modified since header. So let's try this out. Just remember that this file was modified on Sunday 18th October 2015. Quite old file. So this is basically a PNG file. We are actually recording this lecture at the end of 2017. But anyways, so let's do one thing. I'll do a tail on var log nginx access.log. And now let's open this file up and let's refresh. Okay, now if we look into the Nginx access log, what you see? You see a 304. So the reason why you're seeing a 304 is because my browser cache asked, it sent a GET request on the file name asking whether it was modified since. Now since the file was not modified, the web server sent a 304 not modified response back. So this is the basic. Let me show you this output in TCP dump. So I do a TCP dump -a -iet/0 and on port 80. Now this will give you a much more clear idea. Just remember, this is the last modified time. Now I'll start my TCP dump capture. Okay, so the capture has started. I'll refresh once, and again the browser must have sent a if modified since header. Let's see. And here if you see, this is basically the, let me go up. Let's go up. Perfect. So this is basically the file. So now you see, this is the if modified since header, where the browser is asking whether this file, you see the get request is get dockerc.jpg, because we actually requested for dockerc.jpg, and now there is a header which browser has added saying whether this file has been modified since this specific time. So whenever a browser or a cache server stores a file, this specific file is stored in the cache, it will note the last modified date. So it will note this specific date. And whenever the cache server will send a request to the web server, in the if modified, it will append the date of the last modified. So since the last modified is 18th October 2015, it has appended that specific date and said whether this file is modified since this specific time. Now, if it is not modified, then the web server, if you look into the next response, the web server has sent that this specific file is not modified after this specific date. And now since my cache or a web browser now received a 304 response, what it will do is it will serve the file from the cache itself. Now one important thing to remember is that whenever a web server sends a 304 not modified, it will not send a file, it will just send a response without a file. So this is the basics about the if modified since header. I hope you got the basic understanding on the importance of if modified since header. I hope this lecture has been informative for you. Again, go ahead and try this out because practical is very important. And if you have any issues, you can let us know in our forums. So this is it. If you have any questions, doubts, suggestions, feel free to connect us at Twitter, Facebook or LinkedIn, or mail us at instructors@kplabs.in. Thanks for watching.
Welcome back to the Knowledge Portal video series. So in the last module, we were discussing about the date and the expire header and how they help cache to know till what time it should store a document which should be considered fresh. However, the expire header does the basic job. Still, it is not a very ideal solution as we consider a modern internet to have. And this was the reason why in HTTP 1.1 protocol, a new header called as cache control was introduced. So revising the date and expire header again, we have already seen it in the earlier modules. If we subtract the both of them, we can find that here the timings are the same, even the month is the same, the only difference is the day. So if we conclude these two values, then we can find out that the document expiration can be considered as 24 hours
And this was a basic way for cache to know that how much time it should store a document for before revalidating it with the origin server. So, modern internet has become much more complex than it was thought when the HTTP 1.0 protocol was designed. So, we have already seen that a particular response can be cached either by a cache server, which can be at the intermediary node, or it can also be cached on the browser side. So all the modern browsers have their own caching mechanism where a cache response can be stored either in the memory as well as in the disk. So in the expires header, there was no way of specifying if a response should be stored in explicitly in this or explicitly in the intermediary node or in the caching node. However, with the cache control header, an origin server can explicitly specify whether a response should be either be stored in the intermediary proxy or it should be stored in the client side cache proxy server. So let's look into the cache control directives, then it will become much more clear. So these are the 6 directives which comes along with the cache control headers. So the first one is no store. The no store means do not store this particular response anywhere. So by anywhere, I mean the intermediary proxy as well as the browser cache. So this can be considered as anywhere. The second directive is no cache. So no cache basically means you can store the cache. So the cache can be stored either at the intermediary or the browser side. However, before sending the response, so if the cache is stored in the intermediary proxy over here, so if a client sends a request, so before a cache can send the response back, it should revalidate with the origin server if the response is the latest one or is the fresh one. And this is what is considered as no cache. The third directive here is max age 0. So max age 0 we have already seen corresponds to the maximum age in seconds for which a document should be considered valid. Then is the s-max age 0. Now s-max age 0 is explicitly for the intermediary proxy node. This is not for the client side caching. Then we also have the must revalidate header. So must revalidate is somewhat similar to no cache. We will be talking about the difference in the upcoming module. However, if you just have an overview, must revalidate means that a cache must revalidate the document after it is expired to back to the origin server. And there is one more header called as pragma no cache. So this basically is used for as backward compatibility. So pragma no cache is somewhat similar to the cache control no cache. However, pragma no cache is specifically for the HTTP 1.0 based applications or browsers. So coming back to our favorite SSH, so let me show you our NGINX configuration. So here if you see for .png file we have already added expires as 1 hour. So this means cache can store this particular response for 1 hour. So if we do a curl for example.com logo.png, so sorry, it should be HTTP. I'll say
logo.png. This is the third time making mistake. Slow and steady wins the race. Okay, so this is perfect. So here you see the Nginx is including both the expires header as well as the cache control header. Now it's important to know that cache control header followed by max-age specifies the maximum age of a document that can be considered fresh in terms of seconds. The reason why expires and cache control header both are introduced by Nginx is because there can be some browser or some application which is still following the legacy HTTP 1.0 based protocol. And for backward compatibility, for them to understand, the expires header has been introduced. However, if both expires as well as cache control headers are introduced, the modern browser will just read the cache control. It will not consider expire header. So this is something which is important to know. So this is it about the basics of cache control headers and why they are introduced. We'll be talking more about them in the upcoming lectures. So I hope this basic information has been informative for you, and I'd like to thank you for viewing. So welcome back to the Knowledge Portal video series. So we have finally reached the stage where we can actually talk about the content negotiation in the HTTP protocol. So let's explore on what it is. So let's take an example where this is a client or a web browser and this is a video streaming server, something similar to YouTube. Now, there are a lot of videos in this video streaming server, and each video is associated with three qualities. One is 480p, one is 720p, and one is 1080p. Now, whenever a client requests come to this particular server asking for a video, how will a video server determine on what is the quality of the video it has to serve to the client? So one of the techniques is based on the user agent string. So it was assumed that the mobile clients always had a slower connection than a typical broadband. So whenever a video streaming server used to get a request with a user agent based on a mobile, then they tried to serve the lowest quality. So in this case, the quality that would be served would be typically 480p. However, if a user region is based on a desktop browser, then the video streaming server can actually send video based on 720p or 1080p quality. So that really depends on what algorithm the video streaming server uses. So one of the ways in which a video streaming server can determine the quality that it has to serve is based on the client itself. So client along with the video URL will also specify on what is the quality of video that it wants to be served. So in this example, if you see, the client is saying that I want to watch a documentary. Preferred version is 1080p, 720p is less preferred. So that means the client is willing to accept 720p, however it wants to watch video based on the 1080p quality. So here there is no mention of 480p, so client would not like to watch a 480p based quality. So now it becomes easier for a video streaming server to determine that what is the quality of the video that it would like to serve to the client. And this is the preferred version because generally nowadays even mobile phones are starting to have a 4G based network. So even they have a very fast internet connection. So the way in which a server can determine on what is the type of content that it wants to serve is based on the relative quality factor which HTTP protocol provides. Now the relative quality factor is based on the Q parameter scale. So Q parameter basically ranges from 0 to 1, 0 means least preferred, or I can also say as not preferred, and 1 means most preferred. So if we take an example of the one that we have already discussed over here, to the Q parameter scale, we can determine that 1080p would be associated with one value. So 1 means most preferred. However, 720p is less preferred, so it can come somewhere in between. So we can assume it can have a score of 0.5. That means less preferred. So let's take an example, then it will become much more clearer. So the first example is related to website which has multi-language based contents. So a browser in the accept language header is saying that it prefers DA, ENGB, which is British English, and EN as well. Now notice that the language is associated with a Q parameter. So the Q parameter is basically the one that we were talking about here, which ranges from 0 to 1. 0 means least preferred or not preferred, and 1 means most preferred. So if there is no QA parameter associated here, that means that it defaults to 1. So as there is no Q parameter associated with DA, DA is Danish. That means DA is associated with Q parameter 1. So if we translate this, then the client browser is preferring Danish language of content. If Danish language of content is not there, then it is even ready to accept British English. So the second preference is British English with 0.8 parameter score. And the third is 0.7, which is English. So if we translate it, then it comes to I prefer Danish language of contents. If Danish language is not available, then even British English is also okay. If British English is also not available, then you can even serve me normal English contents. And this is how the Q parameter works. One more example over here is that the client is willing to accept page which is based on text /HTML. So these are the MIME types. We already discussed the MIME types. So as there are no QA parameter associated over here, it means that all of these are associated with default value 1. So here for application /XML, the Q parameter is 0.9. So this is the second preference. And if the second preference is not available, then for any other, the Q parameter is 0.8. So this is how a client browser can tell to a server on what are its own preferences. And this is why it is called as content negotiation, because there is a negotiation of content that takes place. So as we have already seen the basics of content negotiation, let's open our Wireshark and see on what exactly happens in the background. So I'll start my Wireshark, and along with that, let's open our Internet Explorer and let's go to example.com. I'll go to example.com/mywebsite.html. Okay, so this is a content and this is an image file that has come. So if I stop the packet capture, let's go to get my website. So this is the stream and let's follow the stream. Okay. So let me show you. If we look over here in the image source, when the server is making a GET request for my kpz.png, in the accept header, there is a Q parameter that is associated. So if we see over here for image/png, as there is no Q parameter, it means it defaults to 1. Even for the second MIME type, it defaults to 1. However, for any other MIME type, say image/
GIF or image slash JPEG, etc., the Q parameter associated is 0.8. However, if even this is not available, then the client is ready to accept any MIME type with Q parameter 0.5. So in this way, the client is telling to the server that I would prefer to have a PNG based image. If it is not available, then it goes to second, then the one with the lower Q parameter scores. So this is one of the ways in which the client can tell to the server about its own preferences, and in this way the content negotiation takes place. Now the content negotiation even works as far as accept language is concerned. So here, as you see, as there is only one language, that means the client would prefer to have a content based on EN/US, that is English based on US. So this language has a Q parameter of 1, as there is not defined by default. So this is one of the ways in which the Q parameter can help in the content negotiation. Even if you go to YouTube, there is a lot of content negotiation that takes place to see what type of video quality a client would prefer. So this is it about the Q parameter and the basic content negotiation. I hope this video has been useful for you, and I'd like to thank you for viewing. So welcome back to the Knowledge Portal video series. So in the last module, we have already discussed the two directives within the cache control header, which were the max age and smax age. Today we are going to talk about the no cache and must revalidate directives. So taking our previous example again, so we have already seen this diagram in the last module where a client is requesting for a particular file and the cache is getting the response. It is storing the file within the cache memory, and also it is sending it to the browser. Now we have also seen where we mention no store directive, which specifies that this particular file or a document associated with a no store directive should not be stored either in the public cache or in the private cache. So there is one more important directive called as no cache. So no cache, as the name indicates, does not mean that do not store the cache. It just means that you are free to store the file in your cache, but whenever you serve it to the client, just revalidate it with the origin server whether the file is fresh or not. So this is the only thing which no cache means. So let me show you in the NGINX server so that it becomes much more clearer. So if we go into the NGINX configuration, here we have one header which is cache control no store. So if we do a curl, and here you see the web server is responding with no store header. So if I go to example.com/web3.html, you see the website has opened. Now if I go to about cache in the browser and go to web3.html, it will not find, because the no store header has been introduced, and this is the reason why Chrome is not storing this particular document inside its memory. Now let's comment out this header and let's add a new header which is cache control no cache. I'll save this and I'll reload Nginx. Let's do a curl again to just verify, and now here we can see we have no cache header. So if we refresh the page, let's open this page in one more tab, and the page has opened. So if we go to about cache now and search for web3.html, Now you see the Chrome has actually saved this particular document in its cache. Now if I open this document, Chrome will have to revalidate it with the server again to make sure that this is the updated document. And this is what no cache means. So every time I open this document, Chrome has to send a validation query back to the server asking whether this is the latest and the most fresh document which is available on the server. Now there is one more important thing that we should remember, that let's say a server has sent a no cache and the document is stored both in the intermediary proxy as well as the browser cache. Now what happens if the origin server goes down? Then how will a cache revalidate whether the document is the latest or not? So that is a big question. So during that time, what happens is the cache will send a header called as age with a warning saying that this is a stale document and I'm serving you the stale document. Stale basically means older version of the document, which cache is not very aware if that is the latest one. So many times requirement comes that you should not serve stale document at any cost. So during that time, there is a header called as must revalidate, which comes into the picture. So talking about must revalidate, I'll add a header, say cache control must revalidate. So this basically indicates that cache in no circumstances should send a stale document, and it should revalidate every time for a document freshness. So if a origin server is down due to some reason, then it should throw an error back and it should not serve a stale response. So this is very important thing to know. One more directives, we have already talked about a public and private. So let's see on how we can use this in conjunction with other headers. So I'll say add header cache control. I'll say private followed by max age is equal to 200. So before we do this, let's just delete the older headers. Okay. So this basically means that cache control should be private followed by max age of 200 seconds. I'll add one more header. This will be specific for the public proxies. I'll say cache control public followed by s max age is equal to, let's assume 500 seconds. So this basically means that for private cache, which basically can indicate browser related cache, max age should be 200 seconds, and for public cache, s max age should be 500 seconds. So this is how you can actually add multiple header fields. You can also add, say, cache control. First should be no cache as well as must revalidate. So this basically means that the browser or a cache server are free to store the document in its cache, but it should revalidate every time a request is received. So if the server is down, then you should not serve stale responses. So if we would have not included the must revalidate header, then lot of cache servers will serve the stale responses if the server is down. So it is very important to remember this. So this is it about the no cache as well as the must revalidate header. So I hope this basic concept has been clear to you. I hope this has been informative for you, and I'd like to thank you. So in the last module, we were discussing about the basics of the cache control header and the directives for the newer HTTP 1.1 protocol. So today we are going to talk in detail about the cache control header directives, and two of the important directives are max age and smax age. So revising our concepts on caching. So if a browser requests for a particular document and if there is an intermediary proxy in between, then the request first goes to the cache proxy over here. The cache proxy will try to validate if the file is present within the proxy memory. If it is not present, then the proxy will forward the request to the origin server where the file is present. Now in response, the origin server will send the file back to the cache server. Cache server will store the file depending upon the cache control headers which origin server has sent, and it will also send the file back to the client. Now there are two important concepts that are important to know over here. The concepts of public and private cache. So if we talk about this intermediary cache server, it can happen that within an organization there is one intermediary cache server and that actually does the caching of say 200 users within an organization. So essentially this cache server is being used by multiple users. So this can be considered as public cache. However, we know that even browser has its own cache memory, and that cache is private to a particular user, and this is why it is called as private cache. So again revising, we have two important concepts. One is public cache and one is private cache. So talking about the max age and smax age directives within the cache control header, we have in the cache control max age is equal to 120. So this 120 is basically the timeline in seconds. So if Nginx or if a web server sends along with a document this directive, which is cache control max age is equal to 120. So it basically determines that the web server is saying to the cache proxy, both public and private, to consider this document as fresh for 120 seconds. After 120 seconds, this document will not be considered fresh and it will ask the cache to revalidate it. Now, there is a second header called as smax age. Now, smax age is specifically for the intermediary cache servers. So let's assume for a particular file there are two headers which are sent, which is max age is equal to 120 and smax age is equal to 200. So what it will mean is, it will mean that the public cache server should store this file for 200 seconds before it gets stale. However, for private cache, the file should be considered as fresh only for 120 seconds. So these are directives specifically for public and private cache. So let's go back to our Nginx and see on how exactly it works. So let me do a curl on with to show the headers for http example.com web1.html. So here if we see there are no cache control headers which are present, even the expire header is not present. So the web server specifically is not saying when the document will expire. So during these cases, the browser will have its own heuristic method to determine the expiration time. So let's go to the Nginx configuration and let's mention our first cache control header. So I'll say add header. So this is basically used for adding the header, saying cache control followed by max age is equal to 120. So this basically means that any document that ends with .html will have a cache control header with a directive max-age is equal to 120 seconds. So I'll save this and let's reload the Nginx. And if we do a curl again, curl I say example.com web1.html, and now you have seen the cache control header with max age is equal to 120 seconds has been added. So let's open our favorite Wireshark and let's clear this up and let's start a new packet capture. Okay, I'll go to my Chrome and I'll say HTTP or I'll say example.com web1.html, and this is a simple website which has been loaded. So if I go to about cache and let's filter bit on web1.html and let's click here, and it will basically give us the headers that it has received. And here you can see cache control where max -age is 120 seconds. So this basically instructs Chrome that this document is valid only for 120 seconds. And after this time has expired, the Chrome should again revalidate with the server to check the freshness of a particular document. Okay, so now let's go back to the Nginx and let's look at one more directive. So I'll comment the first one out, and as it's very interrelated with the cache control max age, I'll add this in this video itself. So it's no store. So what does no store means is that do not store this particular document in cache. So this specifies both to public as well as private cache servers to not store this document at all. So let's see on how it works. So I'll save the Nginx. I'll do reload. Let's do a curl again. Let's open up one more document, and here if we see the web server is sending no store directives along with the web2.html file. Now let's open the web2.html over here. And the same website has loaded. So now if I go to about cache in the, and if I try to find web2.html, this is just a Google search which I had done previously. Here you will not find specifically example.com/web2.html. So if I search over here, you see it is not finding. But if I type web1.html, which had the cache control header, here you will see it is present in the cache. So this is why it is important to know that if you have some document which you don't want a client to store or even a cache server to store, then you can add a no store header to the document or to the HTTP response, and this will instruct the browser as well as the cache server to not store the document. Now there is the third header which I'll add it up. Add header cache control smax age is equal to 200. Let's save this, and if I do a curl, you see there are three headers which are added. One is max age, no store, and s max age. So let's see max age and s max age. So if we have max age is equal to 120 and s max age is equal to 200, then the browser will store the particular document for 120 seconds. However, the cache server or the public cache server will store the document for 200 seconds. Now, if the smax age directive is not present and only the max age directive is present, then both
the browser cache as well as the intermediary proxy cache will store the document for 120 seconds. So adding a Smax age allows us a lot of flexibility to determine on whether the document should be stored in the public cache or in the private cache, and if yes, then for how many seconds. So this type of flexibility was not provided in the HTTP 1.0 protocol, where we just had a expires header. So this is it about this video. I hope this has been useful for you, and I'd like to thank you for viewing.
Hi and welcome back to the Knowledge Portal video series. Today we are going to talk about a very important topic as far as a NGINX or a performance tuning aspect is concerned, and it is called as static assets. If we take a look at a normal scenario where NGINX is acting as a reverse proxy, so here there is a web browser and there is an upstream server. A web browser is sending a GET request to index.html. Now this GET request will arrive to the NGINX reverse proxy first, and NGINX will forward it to the upstream server. Now if we take a look at the index.html contents, it has two JPEG files, it has two style sheet files and two JavaScript files along with some dynamic generated content. Now generally, if a client wants to load the whole index.html, there will be in total 7 requests which will be made. First one will be for index.html and the next 6 will be for each of this particular file. Now this does not seem to a big issue if the amount of visitors who are coming to a website are less in numbers. Now let's say if you have 100 visitors, then for 100 visitors the amount of requests that will be made just to load index.html will be 700 itself. So the 700 requests will go to the NGINX server first, and then the NGINX server will forward all the 700 requests to the web server. So in total, if we see, the amount of requests that will be parsed will be around 1400. Which is a very big number. Now this is one of the reasons why the static assets is generally implemented in most of the enterprise websites. Let's look into how it works. So what we generally do in static assets is the static files, which are generally JPEG or JavaScript files, we move them from the web server or from the upstream to the reverse proxy. So essentially what will happen is, when a client will send a GET request to index.html, the request will be forwarded to the upstream server and this dynamically generated script will be sent back to the client. However, for the rest 6 requests, NGINX itself will serve the response back. So for the 6 requests, NGINX will not contact the upstream server at all. And this is one of the reasons why the overall performance of the upstream server will be good, as well as the overall response time will be better. Now, this is one of the reasons why in almost all the SMBs you will find static assets are implemented. Now let me show you a log file of the upstream server where static assets are not implemented. So this is a log file for a single index.html GET request, and this is just one page. Actually there are 2-3 more pages, but in this particular PPT I could not fit it all. And just from a single page you can determine on how many GET requests are being made to the upstream server just to load a single index.html file. However, if after we have a static asset in place, the amount of requests has gone from more than 50 just to 3. And this is one of the reasons why having a static assets is very efficient. Now NGINX is very good in serving static contents, and
This is one of the reasons why, if it is feasible, then you should always load the static files to the Nginx itself. Now let us go back to the browser and see on how exactly static assets can prove to be useful. So I'll open up the console, developer console, by pressing F12, and let's open knowledgeportal.in. I'll just scroll down. Okay, and if you just look over here, the amount of requests that have been made just to load a single index.html file is 47. And in the type section itself, we can see what are the type of contents that are being fetched. So you'll have either GIF or you have plain. You also have lot of image files, so PNG, and some of them are JavaScript files as well. So if we look over here, around 80 to 90% of the files which have been loaded for this particular index.html are the static files. So essentially, taking a look at the diagram, what we can do is we can put all of those static files in the Nginx reverse proxy itself, so that the query is not made to the upstream server. And this will not only result in good performance, but overall response time back to the client will also be very fast. So this is it about the static assets. This lecture was just a basic introduction to static assets. We will be learning on how we can implement the static assets in the Nginx reverse proxy in the next lecture. I hope this lecture has been informative for you, and I look forward to see you in the next lecture. Thanks for watching. Welcome back to the Knowledge Portal video series. In the last chapter, we already looked into the basics of static assets and why static assets are used. So today we'll be implementing static assets in our Nginx proxy server, and we'll look into how it can improve our performance. So just revising again on what was the scenario. So this is a scenario without static assets where the client sends a GET request for index.html. This GET request comes to the Nginx proxy. It then sends back it to the upstream server, and the upstream server will fetch the index.html and send it back to the reverse proxy, and reverse proxy in turn sends it back to the web browser. Now the index.html has 6 files over here. So that means for each of the 6 files, the web browser will send a GET request. So in total there will be 7 GET requests which the web browser will have to make in order to retrieve the whole index.html. Now this was the earlier scenario, and if we look into the better scenario where the static assets are implemented, what we are actually doing is we'll take all the static content and we'll move it to the Nginx reverse proxy server. This is called as static assets, and here what will happen is for the 6 requests which are the static assets, the response will come from the Nginx itself, and just for one request which is index.html, the request will be moved to the upstream server. So in a lab setup, we have 2 servers right now. So this is the Nginx reverse proxy and this is the upstream server. So I'll say reverse proxy over here, and here I'll say upstream server. Now there'll be a test domain called as kp.in. When I open kp.in, ideally it will move to the reverse proxy, and from there it will go to the upstream server. Now for the index.html, for this particular website, there will be around 40 to 50 GET requests which will be made because there are a lot of contents inside the index.html. So this will be the first normal scenario. In second scenario, what we will do for the static contents, we'll move everything to the reverse proxy, and then we'll see the logs and see on how much improvement we have made. So let's see on how we can implement this. So I'll go to our favorite Nginx machine, and this is the reverse proxy. This is machine 1 and this is machine 2, which is the upstream server. So let me show you the configuration file. I'll say etc nginx conf.d kp.conf, and here for server name kp.in, it is doing a proxy pass on the upstream server. And this is the simple configuration file. If I go to the upstream server and let's open the configuration file here itself, etc nginx conf.d kp.conf, and in the upstream server for server name kp.in, the root is var www websites kp. So if I just do a ls on var www websites kp, so these are all the website files. Now let's open up a web browser. I'll close this up. Let's open a new session of web browser and let's try to open kp.in. So before we do that, I'll just let me go to var log nginx. So we have access and error.log. Let's empty both of them so it will be much more clearer to parse them. I'll say tailf asterisk. So this is access and error log. So let open kp.in. And this will essentially open the knowledgeportal.in website. Now, if I go back to the logs, you see there are so many logs generated. So this is something that we already looked into the PowerPoint presentation. Just to load a simple index.html file, there are so many dependencies of JavaScript or image data present in there. And this is what we want to improve upon. So what we will do is, if I go to var www websites and kp, so this is the whole website file. So what we can do is, there are a lot of CSS, image and JavaScript files. What we can do is we can move all of these files to the reverse proxy and we'll remove it from the here. Now what I have done, I have copied this entire folder to the reverse proxy. So if I go to my desktop, kp, and this is the entire folder. Now we won't need the entire folder. All we need to do is we want to move the static assets here. So what we'll do, I'll go to nginx, I'll etc nginx conf.d kp.conf. Oops, I'll do a nano. And let's add a location block. Say for location, anything that ends with CSS or JavaScript or say JPEG or JPG or maybe even PNG. I'll say root is equal to var www say assets, and I also include a try files block. So what I'm essentially saying to the reverse proxy is, if any file that ends with CSS, JS, JPEG or PNG, try to give the response from this particular folder. So I'll save this particular configuration and let's create that folder var www assets. Now we'll move the static contents to this particular assets folder. So I'll say CPR, we'll move CSS, we'll move image, we'll move JavaScript as well, and let's move master as well as vendor to the var www assets. Great. Doing a ls on var www assets. Now we have all of the static files over here. So now whenever the request will be made for kp.in, the dynamic files will be fetched from the, or the index.html will also be fetched from the upstream server. However, for all the files related to style sheet, image, JavaScript, etc., it will be fetched from the local assets folder itself. So let me do nginx t to check if the configuration is proper, and it is not. Let's open conf.d and we are missing one. Okay, let's verify once and it is successful. So let me reload nginx and everything is set. So essentially now we have moved the static assets to the reverse proxy itself, and we'll test the logs again. So I'll go to var www websites. So let's go to var log nginx and let's do echo again on both the log files. An error log, and along with that what we were doing was I went to var www websites kp and let's remove the static assets that we have moved to the reverse proxy machine. So I've deleted those static assets, and now let's do a tail again. So I'll go to var www nginx, var logs nginx, and let's do a tail. Now if I open, or let me refresh kp.in, and essentially what has happened is the amount of requests that you see over here has decreased considerably from what it was previously, and you can decrease it much more further by moving more static contents to the reverse proxy, and essentially this will do the job for you. Now static assets is something which is implemented in most of the enterprise related websites or the websites which has getting lot of traffic. Nginx is also very good in serving static contents. So ideally if you have a 2-node server, then it is better to move everything to the Nginx reverse proxy itself and let it do the magic. So this is it about how to move the static assets to the Nginx reverse proxy. I hope this has been informative for you, and I really urge you to try this once because it is very important that you try it out, and this will help you have a clear concept itself. So this is it. I hope this has been informative for you, and I'd like to thank you for viewing.
Welcome back to the Knowledge Portal video series. Today we are going to talk about one more way in which you can have a stringent access control on your files in your web server with the help of whitelisting. Let's look into how it works. Now essentially if you have a web server on the internet, the chances are that you might be getting visitors from all over the world. Now let's assume this is an example.com web server and you have a /admin portal. Now what you want is you do not want everyone to access the /admin page. You only might want to allow only certain IP to access that particular page. Now the way in which you can do that is through whitelisting.
Now taking this example, there are 3 clients over here, each has a unique IP addresses. So as a web server, what you can do is you can allow access to a certain resource only if the client has a particular IP address. So if we say to a web server to only allow /admin page to be accessible from 192.168.10.5 and deny all. So essentially that means that only one computer can access the particular admin page and no one else. Now if you look into the syntax, it is a very simple way of doing it. So here the location for /admin. In this we have a allow directive where it is saying allow followed by the IP address and deny all. So essentially this is a very simple way to say only allow this particular IP address to access the admin page and deny everyone else. Now this is a very simple whitelisting based approach which is very helpful. Let's look into how we can implement it on NGINX. So I'll minimize this and I'll go to our server. Now let's go to our favorite web.conf, and essentially I have a /admin page over here. So let's define a root location. So root will be var www websites example. Say index will be index.html, and let's include a allow directive. So allow 127.0.0.1 and I'll specify deny all. Now what this essentially means that only allow localhost to open /admin page and deny everyone else. I'll save this once. Let me test the configuration. It is successful, and let's reload to NGINX. Now if I do a curl on example.com/admin, essentially NGINX will give me a 403 forbidden because I am not allowed to access this particular resource. Now let's allow our IP address as well in the nginx.configuration. So I'll copy the IP address over here. I'll open the nginx.configuration, and in the allow section, let me specify the IP address once again. So essentially now we are allowing our IP address over here. So if I do nginx reload, okay, now let's do a curl again. So I'll do a curl example.com/admin, and essentially here you see it is showing the secret admin page. This is the reason because our IP address is in the whitelist. Now one more thing that I wanted to show over here is if there are a lot of IP addresses, then essentially this is not a very optimal way of doing things. So what we can do over here is I'll take these 2 directives, I'll copy it, and I'll create a new file, say whitelist, and I'll paste the 2 directives over here. Let me save this. Let's go to the web.conf, and essentially what I'll do is instead of specifying allow directive all the time, I'll just use the include directive followed by the path, say conf.d whitelist. So what this basically will do is it will take the allow directives from this particular file. So if I save this and let's reload Nginx. Now essentially what has happened is Nginx has opened this particular file and it has taken the IP addresses from the particular file itself. This is a very proper way of doing things, specifically if you have like 10-15 IP addresses that you want to mention, and mentioning them in the configuration file is not a very optimal way of doing things. So this is it about whitelisting. This is a short video, but whitelisting is something that proves to be very useful in the production environment. This is it. I hope this video has been useful for you, and I'd like to thank you for viewing. So welcome back to the Knowledge Portal video series. Today we are going to look into a very interesting module called as limit_con. So basically it means limit_connection. So this module is specifically useful for servers which are providing download related content. So if you have a server with lot of files which people will be downloading, then limit_connection module will be a very useful tool for you. So let me give you an example. So let's say this is your server and you have NGINX in it. Now you have bandwidth of 100 Mbps. And approximately you expect there are 10 users who wants to download a file. So you have a big file over here, maybe a software or maybe a video documentary which around 10 users wants to download it. Now among the 10 users, 2 of them have 50 Mbps connection and rest 8 of them has around, let's assume, 2 Mbps connection. Now the problem that will happen over here is the 2 users with 50 Mbps connection, when they try and download the file, they will be occupying the full 100 Mbps bandwidth of the server. So rest 8 people, when they try to download the file, either the download will be slow or the server will return 503. So during these type of scenarios, it is very important to limit the amount of connection speed that you give to each individual user. So during this instance of time, let's say you give 10 Mbps to each user, then essentially all the 10 users will be able to download the file. But if you do not have any restriction on the amount of download speed a user can have, then typically the people who will have very fast download speed will choke up the whole server. So let's see on how exactly it works. So this is one of the CentOS directory where I'll download a sample CentOS file. We'll download this 600 MB file. So I've copied the link and let's try and download it. So I'll go to temp. I'll paste it over here. So before we download that, let's actually test our speed. So I have this 100 MB test file which basically will help us know the true speed of the server. So I'll do wget and let's see on what is the speed that our server is downloading the file. Okay, so the 100 MB file got downloaded and the average speed was around 17.7 Mbps. So you can consider 18 Mbps download speed. Now let's take this particular file CentOS. Let's copy the link location and let's do a wget and try to download it. Now typically if you see, these are the websites who generally get thousands of users at an instant of maybe a day who will be downloading all of these files. So they actually cannot give full speed to all the users. So they actually have lot of bandwidth based restrictions on the file. So here you see I am able to download the file at around 600 kbps, 600 to 700 kbps maximum. Even though I can download it more than 17 Mbps, but the server has a restriction of around 600 kbps. So no one will be able to download this particular file at speed more than 700 or 600 kbps. So this is something which is very important for the servers who are hosting files to download. So we'll be doing the same thing for our NGINX machine, and let's see on how we can do that. So let's go to the NGINX configuration. And let's create a new location directive called as downloads. So I'll say location / downloads. The root will be var www websites example, and I'll close the directive. Let's save this, test if the configuration is okay, and it is good. So let's go to var www example, websites example. Let's create a folder called as downloads. And inside downloads will be the file which people will be downloading from. So we have already downloaded a 100 MB test file. So let's copy this file from temp directory to this download directory. And inside download directory we have a 100 MB test file. Let's also reload the NGINX. Okay, so inside the download directory we have a 100 MB file. So let's use some other server to download the particular file. So this is my second server. So what I'll do is I'll go to temp directory and let's do a wget on server a.com/downloads followed by the name of the file, which is 100 MB.test. So similarly, the file has been downloaded and the average download speed is 17 Mbps. So as there is no restriction, the server was able to download it at a full speed. So now let's use the limit_con module and let's put up restrictions. So let's go to our NGINX, and inside the download location directive, beneath the root, there is a directive called as limit_rate, which let's put it as 50K, and let's save it. And let's reload the NGINX configuration. So basically what we have told to NGINX is only allow the file to be downloaded at maximum 50 kbps. So if I try to download the same file again, you see from 17 Mbps per second to 50 kbps per second. So this is how basically the restriction on download limit is done. Now let's me show you some more interesting stuff. So let's connect to server B. I'll use root. Okay. So This is server A from which we are downloading the file, and this is the server B from which the file is getting downloaded. So what will happen if I download the same file in server B multiple times? So let me copy this again. Let's copy this and let's paste it again. So you see there are two connections from same IP address, and each connection is able to download the file at 50 kbps. So if you have say 10 connections, then essentially you can download 50 into 10 connections worth of speed. So this is generally not ideal. So we have to limit the amount of speed that we give to each and individual connection. So we can also do that with NGINX. So in order to do that, we have to define a zone similarly to the zone that we had defined earlier for shared memory and buffer. Let's define one more zone. So I'll say limit underscore connection underscore zone. Here it will be binary remote ADDR. The zone name, let's put it as ADDR, and the amount of space that we want to give is say 10 MB. So what basically this means is the binary remote ADDR, this is an alternative to remote ADDR. Basically this means the IP address of the client who will be downloading the file. So in this, let's add one more directive, limit underscore con ADDR 1. So basically what this means is for the downloads directory, a particular IP address can only have one connection at an instant of time. So if I save this and if I do a reload, and let me do a Control C on both the instance. So let's download the file again over here, and you see it is getting downloaded. Now there is already a connection which is established. Now if I try to download one more file from the same IP address, basically it will give a 503 because there is already one connection from a particular IP who is downloading the file. So this is something that you can do on your production machine. Now there is one more interesting directive that you should remember is I'll say limit underscore rate underscore after. So what this basically means is first 50 MB allow the user to download it at the maximum speed. After 50 MB limit the rate to 50 kbps. So I'll save this. Let's reload the NGINX and let's Control C and let's try downloading the file again. So now you see the first 50 MB it downloaded instantaneously. After 50 MB the speed will be reduced back to 50 kbps. And this is how lot of websites specifically for if you try to download a file and if you are not a premium user, you see there is a bandwidth restriction that you get. Maybe you will be only be able to download file at 100 kbps maximum and so on. So these are some of the things that you can do with the HTTP limit underscore con module. So I hope this has been informative for you and I'd like to thank you for viewing. Hi and welcome back to the Knowledge Portal video series. So today we are going to talk about a very interesting topic called as HTTP authentication. So before we go into what exactly it is, let's take a real world scenario to understand where HTTP authentication can be used. So let's take an example. So you have a website called as example.com. So this website is open to the internet. So everyone from the internet can access this particular website. Now, generally, you do not want some, or sometimes you might want that certain pages within your website should only be allowed to particular person. So, say slash admin page. So, slash admin page, you don't want whole internet to access it. So, there has to be some kind of a authentication mechanism where if a user wants to open slash admin page, then he has to authenticate. And this is where the HTTP authentication comes into picture. So here I have a small picture. So it's something like if someone tries to open example.com/admin, then HTTP will ask for an authentication where user has to enter username and password, and if both of them are correct, then the user will be able to open the page. So if we talk about authentication, so this is HTTP authentication. There are two major types of them. So one is basic, one is digest, and there is third one which is NTLM as well. So NTLM is something which is not much used, but basic and digest based authentication are something which is used frequently in many of the websites. So let me show you on how exactly it works. So let me open Internet Explorer and let's go to example.com. And here you see this is a knowledge portal video series. So this is a normal website. So if we want to go to some important critical pages like /admin, then there will be a prompt for username and password. And this is what the HTTP authentication basically means. So let me put in the username followed by the password. And if I say OK, then the admin page opens up. So this is an abstract overview of the HTTP authentication. So let's see on how exactly it works internally. So let's go down and this is what happens. So the first step, the user sends a GET request. We have already seen the HTTP request and response headers. So the very first thing that happens is the user sends a GET request to /admin. So this is the first thing. So once the server, so this is a server. So once a server receives the GET request on /admin page, it will immediately send a 401. 401 basically means authorization is required. That means you have to authenticate. And along with the 401, it sends a www authenticate header saying what type of authentication mechanism it is using. So here you see it is saying basic. So we already seen there are three types: basic, NTLM and digest. So this is what the authentication type is. And along with this, whenever the user receives the second request, they'll see some kind of a form with username and password credentials. Now, as soon as user fills the username and password and clicks on submit, the browser will send the GET request again, get/admin, along with the username and password. Now here you see the username and password are basically encoded by base 64 and then sent to the client. Now remember, this is encoding and not encryption. There is a difference between these two. So before we go into all of these, let me show you the packet capture. So let me open my Wireshark and let's start a packet capture. So I'll go to Firefox, I'll go to example admin, and here it is asking for username and password. So I've already configured it on my NGINX box. Say OK, and here you see this is the secret admin page. So let's look into the Wireshark and see what exactly has happened. So let's go a bit up, and get/admin starts from here. So let me follow the TCP stream and let's see what has happened. So the browser has requested for /admin page, and in the response you see the server has given 401 unauthorized, and along with that it has sent a authenticate header asking the client to authenticate, and this is when we see the username and password column. Now along with the authenticate, it is saying that the server has implemented basic authentication. Now if we go a bit down, then you see this is the response, again the get/admin. Now here it is saying authorization, means it is providing an answer to basic authentication, and this is the username and the password which is encoded in the base 64. And then if we go down, then you see you get a 200 OK, means the server has verified that the credentials are proper and it has given access. Now this is a base 64 encoded value. So if we just copy it in the browser, just type base 64 decoder, and if you paste this value in the decode format, you'll actually get the format back, which is admin and password. So the username was admin and the password was password. So if we talk about the base 64, all it does is it does the encoding. So you can actually retrieve your plain text data from the base 64 encoded value. So in this type of scenarios, so let's say this is a client, and this is a server. Now the client has sent a password to the server encoded with base 64. Now in this type of scenarios, if there is a hacker who is listening over the network, so this is a hacker, the bad guy, and if he manages to capture this traffic, then even hacker has the base 64 encoded format. All he has to do is he has to decode the base 64 value, I'll say base 64 value, and then he'll get the original username and password back. So this is one of the reasons why basic authentication by itself is not preferred. Now there are a lot of sites which still implements basic authentication, but if you want to implement basic authentication, then you can use on top of SSL. So if you use on top of SSL, then this whole data is encrypted. So even if the hacker tries to get the data, it will be in a jumbled up format. So the hacker won't be able to decode it. So this is one of the reasons why HTTP basic authentication is ideally used along with SSL. If it is not used, then it is very easy for a hacker to, or hacker who is monitoring the traffic, to hack into the server. So this is it about the base 64 and the basic HTTP authentication. I hope this has been useful for you, and I'd like to thank you for viewing. So in the last chapter, we were looking into the basic type of HTTP authentication. So we looked into the overview on how exactly it works. So in this video, we'll look into how we can implement HTTP basic authentication in NGINX. So the very first thing that you have to verify if the HTTP tools package is installed, because this basically will be useful in the basic authentication. So you can say HTTP tools and you can see it is installed. So if it is not installed, you can do yum by install HTTP tools and this will be good enough. So we have two pages. So I'll show you the configuration. So here we have two location directives. One is location for root and one is admin page. Now we have already discussed admin page contains secret data. So this is something that we want to have an authentication for. So if I go to the browser and let me open example.com/admin, and here you see the admin page is not protected. So let's use the HTTP basic authentication and protect this particular page. So within the admin location directive, because this is where we actually want to protect our page, we'll say auth_basic followed by the name that you can give any name. I'll say basic authentication. So this becomes the realm. Followed by the auth_basic user. Let's take it etc nginx.ht password. So basically the first line signifies that this is going to be basic authentication, and for server to verify if the password and username is correct, this is a particular file. So in etc nginx.ht password, the username and password will be stored. So I'll just save it, and this is etc nginx directory. So let's create our own password file. HTTP password C in etc nginx, say HTTP password. C stands for create a new file. We also have to specify the username. So let's say username is admin. Oops, it's HTTP password. So for admin, it is asking me for a password. I'll say password, and it created a .ht password file. So if I do a cat HT password file, you see there is an admin followed by the password associated with it. So let's verify if the NGINX configuration changes are successful, and it is. So let me reload the NGINX and let's open the browser and let's refresh. And now you see it is asking for username and password when we go to /admin. So this is basically how a basic authentication in HTTP is implemented. So again, if you want to implement basic authentication, always try to use it along with the HTTPS or SSL. Otherwise, this is a big security vulnerability. So I hope this lecture has been informative for you, and I'd like to thank you for viewing.
Hi everyone, and welcome back to the Knowledge Portal video series. This is Zeel, and in today's topic we'll be talking about hashing. Hashing is one of the very important functions that is available, and as an information security person, hashing is one of the things that will be always useful throughout your life. So let's see what hashing does. So here we have a sample document. So let's consider this as a notepad file, and inside a notepad file there is a text called as secret text. Now once we pass this notepad file to a hashing algorithm will generate a unique output. Now this output depends upon the text which is written inside the file. So here if we see, it is secret text. Now let's look into another example where we have changed the contents. So instead of secret text, we have written secret text 1. So there is one number that is added to the file. We pass that file to the hashing algorithm and we get a output. Now compare this output which starts from A71, ends with D6 to the original output which starts from 64 and ends with EF. So here you see, even changing one character or one number of a file, the whole output of the file changes once you pass it over to the hashing algorithm. So what does hashing algorithm does? Well, hashing algorithm will tell us if the file is modified or not. So if we talk about viruses basically attach to the files and they change the structure of the file. So it is through the help of hashing algorithm, it is possible for us to know whether a file is modified or not. So before we go into this slide, I'll give you a small demonstration on how hashing works. I'll minimize the PPT. And yeah. I'll maximize the screen. So here, if we see, this is my Kali Linux machine which I am connected to PuTTY. So it is running on the background in my virtual machine. So here there is one document. There is a text file called as document, and if I do a cat, I'll see the contents of the file. So the content of the file is secret space text. Now let me find the MD5 sum of this document. So I'll run MD5 sum. This will give me the hash value and followed by the name of the file, which is document. So here it gave me some hashed value of the document. Now let me open the document and let me add a full stop over here, right? And I'll save it. So now we have modified the file. Let me again take the hash value, and if you compare this hash with the below hash, you can easily identify that the file is changed, right? So hashing helps us to identify whether a file is modified or not. So if you look into a production environment, generally files would not be modified. So in production environment, for all the important files, there is a program which monitors whether the file is changed or not. And if the file is changed, the program will immediately email to the system administrator saying this file is modified. So coming back to the presentation. Now, if we ask what is the difference between an encryption and a hashing. So basically encryption is a two-way function. So what does two-way function mean? So here you see, first this is a plain text data knowledge portal. We encrypt it and we got some encrypted value. Now by applying the key on a decryption algorithm, we are getting the plain text back. So here we are applying key once on the encryption side and applying key second time on the decryption side. So if we have this encrypted value, we can always recover the plain text from this encrypted value by applying the key. But hashing does not work this way. Hashing is a one-way function. So that means if this is a document and you pass it to the hashing algorithm, then you get this output value. Now, from this output value, you will not be able to recover the document back. Now you will ask, then what is the use of hashing function? So let's explore on what could be the benefits of this kind of a way. First benefit is your system files do not change. If it has changed, then there is a high probability that a virus has done it, right? Most of the system files will not change anytime. Only and only if some person is manually changing the file, which is highly unlikely, or if a virus is doing it. So in a production environment, all the time there is a file integrity monitoring software that runs, which will email us as soon as some file is modified. And how it knows if the file is modified? It compares the hash. Now the second use of hashing is you can store your password in a hashed value instead of an encrypted value. So let's go to OneNote and understand this. I'll use my favorite pen and I'll go back to the full screen. So whenever you log into, let's say, Windows machine, right, it will ask you for a user and it will ask you for a password. This is your Windows box. So in order to log in, it will ask you for your username and it will ask you for a password. Now, how will Windows verify that the credentials that you have supplied are correct or not? Well, certainly it would have some file, right, where it would check that if this username and password is right. So there has to be a file where the username and password must be stored. So whenever you type username password, your Windows operating system will verify it from the file. If it is correct, then you will be granted access. Now, let's explore about this file a bit. Let's say your username and password is stored in plain text data, right? So if my username is Zeal and password is Motorola. So if the plain text username and password is stored over here, that means any person can open this file in Notepad and can see the contents of it, right? So we were discussing this is why encryption is used, so that even if the person gets hold of the data, he will not be able to read the data, right? So there can be two scenarios which can be used over here. The first scenario is encryption and the second scenario is hashing. Let's look at the first scenario first. So if we are using encryption, that means that your Windows has to store some secret key somewhere in the file, right? So secret key has to be stored somewhere so that Windows can actually decrypt the file and can see the contents of it. Now what happens if the secret key gets leaked? All the username and passwords are leaked, right? So this is not a very, I would say, optimal way. Second way is hashing. So what happens in hashing is your Windows will take a hash value of this Motorola, right? And it will have some hash value C52N1S. This is some random value, right? And it will store username as well as hashed value in the system file. So if I open the system file, it would be something, say Zeal followed by the hash value C52N1S. So let's say hackers gets access to the system file and they are able to read Zeal followed by this. Now as we have seen, hashing is a one-way function. So from this value, from this hash value, we cannot recover the password back. It is not a two-way function, it is only a one-way function. So even if the hacker sees this file, he will not be able to find the password. So this is the reason why hashing is used in almost all the operating system to store the password. So let me show you one of the example. So in Linux, the passwords are stored in etc shadow. So let's open etc shadow. So here you see First is the username. The username is root followed by the hashed value of the password. So this is not a encrypted data. This is the hashed value. So hash means one-way function. So from this we cannot recover the original data back. So now the point is, how will system know that this password, the password that you write, matches the password which is there in your system? So what system does is, whenever you log in with username and password, say Motorola, your system will first take the hashed value of this password. It will hash this password and it will get some hashed value. It will compare this hash value with the hash which is stored in your system file. And if the two hash matches, and also if the username matches, it will grant you access. So here, if I type Motorola 1, that means your system will first take a hash value. Now as we have added 1 at the end, the hash will completely change, right? This is the hash. It will compare hash with the hash in the system file. And now as the hash does not match, that means the password is wrong. And this is how your system verifies it. Now, there is one more use of hashing. Let's see how it is used. I erase everything and okay, let me create a new document and let's view it in the full screen. So let's say this is the second use of hashing. So let's say this is a server and this is your laptop. This server contains lot of softwares. And this is the internet. So as this is the internet, that means there'll always be a hacker somewhere, right? So let's say you are downloading this is a Microsoft Office. Okay, you're downloading Microsoft Office from this server to your computer. Now, this file will come through the network to your computer. Now, there can be a possibility where hacker would maybe say block this file and insert his virus version of Microsoft Office. It is always possible, right? You never know, because this server might be in US and your laptop might be in India. So there is a very big communication channel between these two countries. So how will you make sure that your software that you have downloaded is the exact version which is there from the server? The thing that is used is MD5, not MD5, I would say hashing. So what happens is, whenever you download a software from a server, they generally give a hashed value along with the software. So this is our Microsoft Office, and along with the Microsoft Office, they'll give you a hashed value. So once you download the Microsoft Office from the server to your laptop, now your job is to take a hash value of this, say this is the hash value that you get, and compare it with the hash value which the Microsoft has provided. Now if the hash value are same, that means you have downloaded the correct version. Now if the hash value is different, there can be two possibilities. One is that your software is not downloaded correctly. Some portion of the software
must have been corrupted. That is one possibility. Second possibility is from the network there has been some modification that has been done to the file. So there can be two possibilities for that. So always check for a hash value when you are downloading the software. Nowadays, most of the companies who are providing software online, they give the hash value on their website when you try to download the software. Coming back to the slides. So the third point that we discussed was verify the integrity of the software that you download. So this is all about hashing. Try to make a file, try to hash it, modify the file, see the hash value, see if you are getting some different hashed value, and this is all about hashing. So I hope you have enjoyed this lecture, and in the next module we'll be talking about viruses, and it is going to be a very interesting one. So thanks for watching. Have a nice day. One of the videos that I have included before this lecture is about hashing. Now I have taken that video from our intensive ethical hacking course. So the reason why I decided to include the hashing video was because hashing is something which is very important that you understand, not just for security but also for the next HTTP authentication, which is Digest Authentication, which relies completely on hashing. So before we go into the HTTP Digest Authentication, let's again revise the basic authentication and one of the fundamental flaws of that. So one of the things, again, the client sends the GET request /admin page. Now as the admin page is having the basic authentication method, so the server sends the www authenticate header with the basic authentication type. And in order for client to verify, the client actually sends the base64 encode value of username and password. Now we have already seen that if a hacker is sniffing the traffic, then he can actually get the base64 encoded value and can easily decode it within few minutes. So in fact, even if you have a pen and paper, you can actually decode the base64 value within few minutes. So this was one of the fundamental flaws of the HTTP basic authentication. And this is why if you want to implement basic authentication, then try to use it on top of SSL. So now let's talk about digest authentication. Now one of the reasons of digest authentication was to provide an advantage over the basic authentication. So again, in digest authentication, the first step remains the same, where the client sends GET request for /admin page. Now in the second response, which is the 401, as similar to basic authentication, here you see the realm has changed from basic to digest, and there is two more values that have been added generally. One is the nouns and one is the QOP. Now in the third request, if you see in the response, generally the base64 encode which the basic authentication used to send, now instead of this is basic, in digest it sends the MD5 digest, or I would say MD5 value. So we have already seen that the hash value cannot be a two-way function, it is just a one-way function. Now the question is how the hash value is calculated in digest authentication. So let's see. So the first step generally that happens is, so first the username plus the password plus the REN are calculated. Let's say this is H1 and the MD5 of these three things are taken. Then there is a H2 value that is calculated, which is the URI. The URI plus the request method. So URI will be /admin and request method would be get. And the MD5 of this is taken. Now, once H1 and H2 are calculated, then both the MD5 value, so say MD5 of H1, MD5 of H2 is taken and then a nonce value is added. And then for all of these three things, one more MD5 hash is taken and that MD5 hash goes as a response to the server. Now, if you're wondering about what a nonce value is, so there is a concept called as nonce, which is included in the Digest Authentication. So basically, this is used to prevent replay attacks. So let's say a hacker captures this response, and after 1 hour, he decides to send the same response back to the server. Now, as the username, password, and realms are correct, ideally server should be able to verify it. So this is one of the flaws. So what happens in Digest Authentication, a nonce value is added, and this nonce value keeps on changing every interval. So even if hacker captures this particular request and replays it after half an hour, he won't be able to get the authentication because the nonce value has changed. And because the nonce value has changed, the whole MD5 value has also changed. So this is one of the ways in which the Digest Authentication works. Now, generally, as far as NGINX Plus is concerned, it does not really support the HTTP Digest Authentication. So we will not be including the practical part of Digest Authentication for this course. However, just for knowledge purpose, I decided to include Digest Authentication. So if you're using Apache, then you can actually implement the Digest Authentication there. So I hope the basic overview concept of Digest Authentication is clear to you, and the difference between a basic and digest is also clear. So I hope this video has been informative for you, and I'd like to thank you for viewing.
Welcome back to the Knowledge Portal video series. In the last 2 lectures, we discussed about the basics of the Digest Authentication as well as how we can calculate the response based upon the various values. Today we'll look into how we can actually implement Digest Authentication on a web server. Now, Digest Authentication is not supported by NGINX, so we'll be using Apache in this case to have a Digest Authentication upon. Talking about the scenario, let me open up the Internet Explorer, and when I go to example.com/admin, here you see it is showing a secret admin page. So what our case study is that we have to protect this particular page, which is /admin, with a Digest Authentication. Now let's see on how we can do that. The very first thing that you have to do is you have to install Apache, or just verify if you have Apache installed with rpm qa grep httpd. In my case, it is there. Also, make sure that if you are having both Apache as well as NGINX, NGINX should be stopped. In my case, I have both Apache as well as NGINX in single server. NGINX is stopped, however, Apache is running. Great. So as you have done this, let's go to the Apache configuration and see on how we can have a digest based authentication. So I'll go to etc apache httpd conf httpd.conf. Now if I search for mod_auth, so these are the modules. If we look over here on the second module
is related to mod_auth_digest. So this module is used for digest based authentication. Make sure you have this particular module installed. To verify, just verify that you have this particular line in your Apache configuration. Let's go down and let's write our digest based authentication directives. So the very first thing that you'll have to do over here is specify the location block. Location for say admin. So whatever I write below this will be applicable for /admin location. First important directive is auth type. There are two major auth type, which is basic and digest. So as we are implementing digest authentication, we'll write digest over here. Next is the auth name. This is basically the name of the realm. So I'll say knowledge portal. Now I have to tell the digest module that if anyone comes to /admin page, provide a username and password based login screen. So the auth digest domain will be /admin. So that means if anyone comes to /admin page, a username and password will be asked to the user. Once this is done, let's say auth digest provider, I'll say it file followed by the auth user file. So this is the location of the username and password which will be stored in a particular file. So I'll say etc, let's put it in HTTP itself, and let's name it digest_pw password. I say pwd. So this is the location where the username and password will be stored, and the last directive will be, and say required valid user. I hope this is correct, and I have to close the location block as well. So summarizing, for /admin, the auth type is digest, the realm is knowledge portal, the password and user are stored in this particular file, and whenever someone tries to access /admin, he'll be provided with the login screen. So I'll save this, and before we restart Apache, we'll have to create the digest_pw file that we have defined. So in order to create, we'll use htdigest. So this is the command. So I say htdigest. C is followed. C is basically to create a new file. I say digest_pwd. So this is the file name, followed by the realm. So this is the realm. So our realm is knowledge portal. I'll say knowledge portal, and the username. Let's have username as admin. It will prompt for a password. I'll type in the password over here, and if I do a ls, a digest_pwd file is created. Let me restart the Apache, and it had failed due to some reason. So let's verify what we did wrong. Let's go down. And I think this is it. Okay. So now let's go back to the Internet Explorer and let's refresh the page, and now you will see it is asking for the username and password, and this time the authentication is based on digest. So I hope this has been informative for you, and I would really urge you to try it once and do it for yourself.
This is it about this lecture. I hope this has been informative for you, and I'd like to thank you for viewing. Few months back, I got a message from one of my friends saying that his website is getting attacked by a lot of people. So we decided to go into the Nginx logs and we went to Splunk to see what exactly is happening. And we figured out that most of the attacks that were coming on his website were specific to a particular country, which was Russia. So attacks ranged from brute force to SQL injection attempts and so many other things. And they were like 2000, 3000 every hour. So one of the things that we determined was that his website was specific to clients in India. So there was no need to open up the website for the whole world. So then we decided to block the website for specific countries. Now in Nginx, if we want to do that, then there is a very amazing module called as the Nginx HTTP GeoIP module, which basically allows you to block the website based on specific countries. So if you talk about Linux, so there are two ways in which you can block a particular IP address. So let me give you the real world scenario itself of one of my friends. So basically this is a server, and within the server there are multiple websites hosted. So all of these are the websites, and this is one Linux server. So there were around 5 websites which are hosted. Now one of the ways where we could actually block the countries was through the firewall. So this is a firewall, and in the firewall layer itself we could have blocked. But one of the challenge was that we only wanted to block one website and not all. So if you just want to block one website based on the server name parameter, then doing this in firewall does not become a ideal solution. So during that, you actually have to use the GeoIP module which Nginx provides, which can block countries based on the website which they are trying to access. So let's see on how we can do that in the Nginx configuration. So there is a module called as GeoIP which is available. So let's do a GeoIP grep. And here you see there are GeoIP modules available. Now you will need these modules if you want to do the country based blocking. So if you do not have this module, then you can simply install the package which is GeoIP-devil, and this will actually install both the modules. For me it is there. So if you install the Nginx via yum, then this modules will be by default there. So let's open the Nginx configuration and let's write our first code. Okay, so I'll say GeoIP underscore country user share. I hope this is a GeoIP.dat. I'll explain the code. Then we map. So we map the host variable. Now host is basically the host that it is trying to attach. A client is trying to connect, followed by the GeoIP country code. And if let's say we define a variable deny by country. So if anything starts from, let's say, example.com, if it is not from India,
Then let's give it an value of 1. However, the default value is 0. Let's save this. Okay, it's successful. Now second thing that you'll have to do is go to the NGINX conf.t. Stay with me on this and I'll just explain you. And inside the server directive, we add a include if deny by country, then return 403. Let's check if the tests are successful. Okay, and let's reload the Nginx. Okay, so let's see on what exactly I have written. So the first directive over here is GeoIP underscore country. So this basically means that this is the location of the database file. Now this database file basically contains IP to country mapping. Now if we look into the internet or if we look into the IP address based schemes, each country is given a specific set of IP addresses. So let me open the Firefox, and if we look over here, this is one of the websites. I'll be posting it on the forum itself. So this basically gives IP address corresponding to particular country. So if I say India, then there are IP address blocks which are assigned to Indian ISPs, and there are a lot of them. So specifying each and every IP addresses based on country is a very difficult task. So there is a organization called as MaxMind, which has already done that for us, and that mapping country to IP mapping is stored in the GeoIP.dat file. So the first thing that we are doing over here is we are including this GeoIP.dat file. In the second directive, we are mapping the host. So host is a variable. So we have already looked into the HTTP header where we have a host header. So host with the GeoIP country code, and deny by country is a variable. So the default value for deny by country is 0. And if any host variable, so this is host, if any host variable comes with Indian IP, then the value is 1. So let me explain you on how this works. Let's use our favorite OneNote. So the first, we are doing a mapping and we have a host variable over here, and GeoIP underscore country underscore code. So let's say if a host is example.com, so it will be example.com, and let's say GeoIP code is India. So this will become a mapping to this. So if any visitor, so if any user tries to come and opens example.com, and if he is not from India, then block him. So this is what we are actually specifying over here. So I just had to add over here. That's it. Okay, so this corresponds to this semicolon. So again, let's revise. Map host variable to GeoIP country code, and if anything's come and any visit comes to example.com, and if it is not from India, so here we have specified if it is not from India, then the value is 1. By default, value is 0. And within the web.conf, if you have said if deny by country value is 1, then return 403. So that means if any visitor tries to access example.com from any other country other than India, then the value of this deny by country becomes 1. Otherwise, it is 0. And if the value becomes 1, return a 403. So this is how the blocking happens. So as I am from India, let's not include India in the list. So I'll put, let's say, US. So before we do that, I'll just show you that a website is working. I'll say example.com. It is showing forbidden. It looks like, or it seems cache. Okay. Let's see what happened. The code seems good. Let's restart Nginx and let's do a tail. Tail always helps on what exactly is the issue. So let's refresh this. And this is working now. So those things were because of the old testing and the cache in my browser. So now example.com is working. So now let's block example.com from India. So I'll open the nginx.conf, and so by default it is allowing only India and no other country. So let's remove India and say let's allow US. So now only client IP address from US will be allowed and rest everyone will be blocked. So if I reload this and try to open, basically it will give me a 403 forbidden, which means the IP address is not allowed. So this is very useful if specific website is only targeting customers based on a specific country or a specific city. So even if you look into security wise, so if your website is specific to a particular country, let's say India, then why do you want that website to be accessible throughout the world? You can actually block countries where a lot of attacks that comes from, specifically Russia. Lot of attacks comes from there. So you can actually do that. Now, one more interesting question that comes is how will we know the code for each and every country? So IN, US, and so many other things. So there is a database from MaxMind itself, which has country code mapping. So AU stands for Australia, for India it is IN, and for each country they have given a specific country code. So this is something that you can use to enhance your blocking capabilities. So I'll be posting this in the website itself so that you can refer it. Now, this is the basics about how you can block the countries from your whole website. So we have looked into GeoIP based country mapping. So you can do a lot of things with the HTTP GeoIP module. You can even use city based blocking. You can use longitude as well as organization based. So organization based means that some organizations are being given a specific set of IP address. So specifically if you see universities, so if I say university of California. So this University of California, many times they are given a specific range of IP addresses. So you can actually use GeoIP module based on the university names instead of the country code. So a lot of things that you can do, you can always do trial and error, test many things depending upon the requirements. So this is it about the basic GeoIP module and how to block country based upon the GeoIP block. So I hope this video has been informative for you and I'd like to thank you for viewing. Logging facility is something which is very important for any program. So specifically if you are a developer, you need log files to help you determine what exactly is happening inside the program. So as far as Nginx is concerned, Nginx helps a great deal through its logs. So let me give an example. So through Nginx log, you can actually determine from which country the visitor is coming from, what is the IP address of the visitor, or what in website a visitor is trying to access. You can also determine from which platform a visitor is coming from, maybe Android, Windows, Linux, and from which browser the visitor is opening the website from. So there are a lot of things that you can actually get from the logs. So if we talk about Nginx logs, there are two types of logs. One is the access log and one is the error log. So in this video, we'll be talking more about the access logs. So I'll just write access log. So this is something that we'll cover in this chapter. So Nginx basically writes information about a client request in the access log after the request is processed. So if this is a client, so I'll say this is a client and this is a server. So we already know HTTP is a request response based protocol. So if a client sends a request to the Nginx, Nginx will send some kind of a response back. Now this response will have some kind of a status code. So maybe it is 200 OK, or it is 404, or it is say 500 internal server error, or so many other things. Now basically all of these is considered as some kind of a response. So in access log, Nginx will store the response, or you can say Nginx writes the information about the client request right after the request is processed. So all of these information is stored in the access log. So let me give you an example for this. So let's minimize this and let's go back to the logs. So if I go to var log nginx, let's do a ll on var log nginx, and you find that there are two types of logs. One is the access log and one is the error log. So let's open access log and see what exactly is there in it. Var log nginx access.log. So lot of things. On the basic overview, you can find that there is a IP address over here. So yes, okay. So you can find the IP address, you can find the date and time, you can find the type of request, get or post or whatever you want. You can even find the browser as well as the operating system version, and maybe this is a user agent string and so many other things. So from this request, we can find that a
client from this IP address at this time on 21st October, he tried to send a GET request using HTTP protocol 1.1, and on that the Nginx gave a 404 response back. That means page not found. So this is something that you can take out from the log files. Now talking about access log, there is already a predetermined format through which a log file is stored. So if we go to the Nginx configuration file, so let's go below, and if we look into the log underscore format, now log underscore format is a directive which is brought by the Nginx logging module. So by default, logging module is pre-compiled when you install Nginx, and that module brings the log underscore format directive. Now inside the log underscore format, we give a name of a format. So this is main. So this is something that you can change accordingly. Followed by the name, there are some variables which are being assigned. Now these variables correspond directly to the type of logs which are stored in the Nginx. So let's do a mapping. So let me do a tail f on var log Nginx access log. So this is something, this looks some kind of a hacking incident which people are trying to make on the server. Anyways, so we'll talk about security maybe sometime later. Let's say, let me open this myseat.jpg, and the image is loaded. So if we go inside the log, you see this is the log format. So let's split the screen so that we can actually determine on what exactly these fields are. So let me split the screens and let's do a vertical split. Okay. So actually I did yeah. So this seems much more better since we are able to read the entire log file. So let me go down. Okay. So the first portion of the access log is the variable remote ADDR. So remote ADDR basically is the IP address of the client who is trying to connect. So here you see the first field that you will find over here is the remote ADDR field, which is the IP address. Followed by the remote ADDR is a hyphen. So you will see a hyphen over here. Then is a variable remote underscore user. Now remote underscore user is basically a field when you do a HTTP basic authentication. So in HTTP basic authentication, we provide a username and a password. So this variable corresponds to the username. As there is no basic authentication, you will find that here you again have a hyphen. I just messed up, and let's clear both the screen and let's open the log file again. Okay. So after remote underscore user, there is time underscore local. So basically this is the timestamp, the time in which the request has come. So here we see the timestamp, which is 12th November 2015 at 6:29. So followed by the timestamp, there is a request field. So request corresponds to the request that the client is sending or the URI. So here it is saying get followed by myseat.jpg. Now we have already seen different type of request headers which can be get, post, head, options, and so many other things. Also followed by that is the HTTP protocol version, which is either 1.0 or 1.1. Now after the request variable, there is status variable. So status is the response status, which can be 200, 404, 500. So here you see it is a 200 status. So means this request is processed successfully. Followed by the status, it is a body bytes sent. So this is the size of the response which Nginx has sent it back to the client. Then we have a HTTP referrer field, which is empty because the user has directly opened the website from the browser. After the HTTP referrer field, there is something called as the HTTP user agent field. So user agent field basically tells about the browser and the operating system sometimes that the client is accessing the page from. So from here we can see the client is trying to access this particular request from Mozilla browser, followed by the version number as well, which is Firefox 33. And the last field here is HTTP X forwarded for. So X forwarded for is something which is useful when there is a proxy in between. So this is something that you can determine. Now you can always change these variables according to the needs that you have. So if you do not want say body underscore bytes underscore sent variable, then you can always remove that and it will be reflected in your logs. Again, you can always add new variables if you want, depending upon the type of access log that you want to have. So this is in simple a generic overview about the Nginx access log. I hope this has been informative for you and I'd like to thank you for viewing. In the last lecture, we were talking about the basics of Nginx logging, as well as we had an overview about the basics of Nginx access logs. So we'll continue with that, and in this video we'll have our own custom format for the logging facility as far as access log is concerned. So let's go to the Nginx logs or the Nginx configuration. I know nginx.conf. And before we go ahead, I just wanted to show you one more directive, which is access underscore log. So followed by the access underscore log is the file system location in which the logs will be stored. So currently it is varlog nginx access.log. So this is something that you can change according to your environment. And one more directive which was present is the main. So the main corresponds to the log format context. So if we have multiple log format sections, then we can actually mention the sections over here. So let's define one more context for the log format. So I'll say log underscore format. I'll name it master. And for this type of logs, I just need remote ADDR followed by the status code. So I'll say, and I'll change the context from main to master. So now the access log will be storing only two variables which are mentioned in the master context. So let me save the file. Let's check if everything is proper and let's reload the Nginx. Okay, so go into the tail. Let's try to open example.com myc.jpg, and it seems to be the cache. So let's do myc1.jpg and let's reload it. And now you see the format in which the log has been started to store is different.
So here it is only showing the IP address of the client followed by the response code. So first is 304 and second is 200, which directly corresponds to the format which we had written in the nginx.configuration file. So coming back to the nginx.conf, so this is the format in which the access logs are stored. Now, one of the downsides of mentioning the format over here is that it is a global directive. So if you have multiple websites on a single server, all the website will start to store according to the master context. So if we want that website 1 should store logs in the main format and website 2 should actually store logs based on master format. So this is a flexibility which Nginx allows us to do. So we can actually specify this in the virtual host configuration. So if I go to conf.dweb.conf, so below the server directive, if I mention access underscore log, I can also specify the custom location. So here if I say var log nginx example.log followed by the context that we want. So I'll say main and I'll verify and let's do a reload. Okay. So let me refresh the page. And now if you go to var log nginx, now you see there is a third file which is example.log which is stored. So if I do a less on example.log, here you will see the example.log is actually storing the log in the format of main. Now let's close this and let's modify the web.conf again, etc nginx conf.d web.conf, and let's modify it to master. Let's reload the nginx. Let's do a tail. Tail on example.log. Let's refresh the page from the browser, and now you see it is following the master format again. So this is the flexibility which Nginx allows us to give. First of all, we can define our own log format. It can be either global or it can even be a specific to a particular server location. So this is it about the access logs. I hope this has been informative for you and I'd like to thank you. Welcome back to the Knowledge Portal video series. So you might hear a lot of cracker bursting up in the background throughout the video. So it is Diwali today and a lot of crackers are bursting up. So happy Diwali to you all. So most of you will be watching this video later, so consider this as a futuristic message for the upcoming years. So coming back to the topic, we have already discussed about the Nginx access log and how can we configure our own custom access log directives. Now there is a second type of log called as error log, which are very informational as far as the debugging issues are concerned. Now there are a lot of level of error logs which starts from emergency to debug. So there is no mention on what exactly each of this level of logging means. So Nginx documentation does not have that officially. So if you really want to know the exact difference, then you have to dig in through the source code to see what exactly each one of them is doing. But we'll try to understand or have an overview on what exactly this does. So let's go back to the Nginx configuration file, and here we have something called as error log directive, followed by the path in which the log to be stored. Now, as far as error log is concerned, it is very important to know that Nginx does not allow us to have the flexibility that we had with access log. That same amount of flexibility is not available for error log. So as far as error log is concerned, you cannot have any other format in which the logs will be stored. So the format is predefined and you cannot change that. The only thing that you can change maybe is the level of logging and the file in which the error log will be stored. And this is it. So let me clear the log files before we start, so it will become much more better. Okay, I'll clear the access log as well. So let's open up the browser, and before that let's do a tail. I'll remove the example.log. We had configured this in the access log time and example.log. Okay, let's do a tail on the logs. Okay, so currently you see the access log is empty and error log is empty. So let's open up the browser and let's create some logs specifically in the error logs. So I'll say example.com/ something which is non-existent. F8, press enter, and now you see an error log is generated. So let's try to understand on what can be the predetermined format for it. So the first thing is the timestamp. So this is the timestamp of the request which resulted in an error. Now this is a log level which is error. So we have already seen that there are various type of log level. Now this log level is considered as type error. Followed by the log level is the process ID. Now this process ID is the PID of the worker process which handled this particular request. Followed by the process ID, you can see #0. Now this #0 basically means it is single threaded. So this will always remain 0 because Nginx is a single threaded. Followed by there is a open call for this particular file, example kj which is not there. So it is already saying that no such file or directory. Followed by it is also saying the IP address of the client and the host name. So this is an overview about how an error log looks like. So as we have already discussed that there are various type of logging. So this is of type error. Now if we go above, there are many things like emergency, alert or critical. So emergency basically deals with, let's say, some kind of error in the NGINX configuration due to which NGINX itself will not start. So those kind of very critical logs are termed as emergency. So let's look into what an emergency log might look like. So let's open nginx.conf. And let's say we make some error in the configuration file itself. And if I try to do reload, you see Nginx itself has failed. Now if we go into the log file, here it says this is emergency. Because this deals with Nginx itself not starting at all. So if Nginx itself does not start, that means if there are multiple websites within Nginx, all will stop working. So those type of logs are categorized as emergency. Now there is also something called as debug logs, which actually provides a huge deal of information within the log files. Now debug logs by default are not enabled and you have to compile Nginx manually if you want to enable the debug log directives. So this is a short video about what a error log looks like. So as we cannot configure our own format for error log, there is not much thing that we can have in this video. So I hope this basic concept has been informative for you, and I'd like to thank you for viewing. HTTP compression is one of the very important features of the HTTP protocol. The reason for this is because not only it saves your bandwidth, but also the transverse feeds becomes very fast. So essentially, if a website is using compression, then the website can actually load much more faster than the one which does not use compression. So let's understand on how compression can help as far as the HTTP protocol is concerned. So we have scenario 1 where there is a website which is running without compression. So let's assume that /index.html, so I'll say index.html is of size 3000 bytes. I'll say 3000 bytes. Now in order to send this amount of data through the TCP protocol, we already know that if the MTU size of TCP is say 1500 bytes, then in order to send the index.html, we'll need 3 TCP packets. So this is packet 1, let's say this is packet 2, and this is TCP packet 3. So all of these packets are sent to the client from the server. I'll draw the third packet as well, and before that the client will send the GET request. Now the problem with this is that for each client it is actually sending 3 TCP packets so that it can send 3000 bytes of data associated. Now this is not a big problem if the amount of clients that are connecting to the servers are less. So if we assume that the amount of client are 100, then for 100 client there will be 3 TCP packets for each individual. So amount of packet will be 300. So I would say 300 TCP packets. Now this is also not a big problem. So if we consider corporate websites where you actually have millions of users who are connecting to your particular server, so during that time the amount of TCP packets which will be sent over the network will be tremendous. So it causes two big problems. The first is the bandwidth and the second is the speed. So as it is sending 3 TCP packets, it will take some amount of time to load the website. Now this is considered as, you can also say as, website is running slow maybe. So this is one of the reasons why even Google sometimes penalizes the website because it loads very slow. So this is the basics of scenario without compression. So let's take second scenario where you are actually using the compression. So let's go down, and this is the scenario with compression. We'll have a same. So index.html, I'll say index.html is of 3000 bytes. MTU is 1500, so it will take total of 3 packets to send the data. So what we basically do is, this time we decide to use compression. So we compress index.html, and the 3000 bytes of data actually gets, let's assume it goes to around 2000 bytes. Compression can actually reduce the size by 70% also, so it can actually go down much more further. But for our example, let's consider 2000 bytes. So in order to transmit a 2000 byte, we already know it will take 2 TCP packets with the MTU of 1500 bytes. So now whenever a GET request is made from the server to client, so this is GET, the server actually have to only send 2 TCP packets to transmit the data. So this is 2 TCP packets, and the data is then loaded on the browser. So now there is certain amount of compression. Now, as we have already discussed, if the site is getting around 100 users, then the bandwidth saving won't be much. But this will affect a lot if a website is getting millions of users. Then the amount of bandwidth that is saved is actually a lot. So if we say millions of users, so if we compare scenario 1 and scenario 2, so in scenario 2 actually 1 packet is getting saved. So that means for million users you have million packet which got saved, because now 1 packet is not sent because of the compression ability. The second important benefit is the speed, or you can also say site speed. The reason for this is because as there are only 2 packets sent, the amount of time it takes to send 2 packets is much more lesser. That's the reason why your website will actually load much more faster. And this is why compression is used in almost all the major websites. So there are a lot of ways in which you can compress the data when you use the HTTP protocol. But in this video I just wanted to give you an overview on how exactly a compression can help, not only as far as the transfer speed is concerned, but also as far as the bandwidth is concerned. So I hope you got the basic overview on why compression is necessary as far as the HTTP protocol is concerned. So I hope this video has been informative for you, and I'd like to thank you for viewing. So continuing with our journey on the HTTP compression and decompression, today we are going to talk about the 2 important HTTP headers, which are accept encoding and content encoding. So before we go about learning on how exactly it works, let me show you on how compression works. So here I have a text file which is sshd_config.txt. So let's do a compression on this and see what level of compression can we achieve. So let's do a ls/lh, and here you see it consists of 3.8K worth of data. So there are a lot of compression algorithms which are present. So we'll be using Gzip, which is supported by the HTTP protocol also. So I'll say Gzip 9 followed by C sshd config, and I'll say sshd.gz. Now if we do ls/lh, and now you see the size difference between the uncompressed version and the compressed version, it is actually very different. So this is less than half the size, around 30% of the size of the uncompressed version. So this is the reason why in HTTP protocol the compression and decompression has been introduced. So coming back to our main slide, let's understand on how exactly compression and decompression works as far as HTTP protocol is concerned. Okay. So this is a GET request from the client. So it says get/test.txt followed by the HTTP 1.1 host user agent, and there is one more field over here which says accept encoding Gzip and deflate. Now there are a lot of encoding algorithms, or as far as compression also is concerned, there are a lot of algorithms. There are 3 famous ones which HTTP protocol supports. One is the Gzip, one is deflate, and one is compress. So these 3 are the most famous compression encoding algorithms which are being supported by the HTTP protocol. So we'll be using Gzip, which is mostly used on the internet. Even deflate is used many times. So in this GET request, the client is saying, or the client browser is saying, that it is supporting Gzip and deflate with the accept encoding header. So, and it sends the GET request. Now the server will see the accept encoding header, and now server knows that the client supports either Gzip or deflate. Now on the server side, this is the test.txt, which has following contents. Now as the server knows that the client supports Gzip based compression, what the server will do is the server will actually compress the test.txt and then send the compressed version of the file back to the client. Now the question is, how will client know whether the server has sent the compressed file based on Gzip or deflate algorithm? So what server does is server sends a header called as content encoding, followed by the encoding algorithm which the server has used to encode the data. So here we know that the server has used Gzip to compress this particular data. So the server will include the Gzip directive in the content-encoding header so that the client knows that the data is being compressed with Gzip based compression algorithm. So once the client receives the data, it actually decompresses it with the Gzip decoder. I'll say Gzip decoder, and then the uncompressed version of the data is received. So this is a basic overview on how exactly the compression and the decompression works with the accept and content encoding headers. So let's take a look into the low level data through Wireshark to see how exactly things work. So I'll open Wireshark and we'll listen on the VMnet interface, which is for VMware. So I'll say start. So currently there are no data that is flowing in. So I'll go to my Mozilla. Okay, so let's open example.com/sshd_config.txt. So this is the file which was present on the server, and let's click and you see the file is opening on the browser. So going back to the Wireshark, let's see on what exactly has happened. Let me do a TCP follow stream so we'll get a proper output. So there are around 11 packets of data which got exchanged during this particular amount of time. So it starts with SYN, SYNAC and ACK followed by the GET request. We have already seen on how exactly this works. So going back to the TCP follow stream, here you see the client has sent the GET request followed by the SSHD_config, and along with that the client has added an header which says accept encoding. So accept encoding is the header followed by what type of encoding the client browser supports. So Mozilla is saying that I am supporting Gzip and deflate based encoding algorithms. Now the server now knows that the browser can support Gzip or deflate. So what server does is it will compress the file with Gzip. So here it is saying content encoding Gzip. That means the file is being encoded or compressed with Gzip, and Now it is telling the Mozilla that if you want to open the file, just unzip or just uncompress it with the Gzip utility. And this all is the encoded value which is encoded or which is compressed by Gzip based compression algorithm. So these are the two headers which are normally sent. Now one more important thing that you should remember is that if a client or if a modern client does not send except encoding header, then the server will assume that the client can understand all the type of encoding algorithms, which includes Gzip, which includes deflate, which also includes compress. So this is important thing to remember. So this is one of the reasons why browser or the client always try to specify on what type of encoding they support. Now this is the basics about the except encoding and the content encoding header. Now let's say if the content is being encoded by say deflate and the content encoding is Gzip, then the browser will actually try to uncompress it with deflate based decoders, and then the decoding will not work. So always important to remember that these fields are very important, and if there is any granularity as far as the content encoding is concerned, then the browser might not be able to interpret the data. One more important thing that I'd like to share is that the content type. Now even though the data is in the form of Gzip based file, the content type will always remain to the original file. So the original file was text file which was encoded with Gzip. However, the content type will still not change. So this is the original content type of the data. So this is also something which is very important to remember. So this is it about the basics of except encoding and content encoding. So I hope this basics has been clear to you, and this is it about this video. I hope this has been informative for you, and I'd like to thank you for viewing. In the last lecture we were talking about the HTTP headers which were except encoding and content encoding. So in this video we'll actually start with NGINX to see on how we can configure our NGINX server to support compression as well as decompression. So let's go to the etc nginx directory and let's open nginx.conf. So if we go below, there is a directive called as gzip on. So that means that the Nginx will support Gzip based compression utility. Now just having Gzip on will not actually start to compress your data. You have to have more directives. So let's start with one which is gzip underscore types. I'll say text plain, maybe text CSS, say text maybe XML, text JavaScript, and so on. So it is necessary to specify on what type or what MIME type of data that we have to compress. So all of these are the MIME types. So once the server sees the except encoding header which is Gzip from the client side, and if the GET request has either one of these particular type, then the server will actually compress the data in send. Now generally the reason why we specify this is because we don't want to compress data such as image file or video file, because there won't be much of compression that can be applied on that. So compression can be mostly applied into text-based data, which can be CSS, XML, JavaScript, HTML, or other things. So one more important directive is the Gzip _ disable, which has to be MSI, let's say 1 to 6, if forward. Okay. So the reason why we have included this is because the Microsoft Internet Explorer from version 1 to 6 actually does not work well with Gzip properly. It does not support it. So this is the reason why we have to implicitly specify that disable the Gzip for anything or any Microsoft Internet Explorer browser from version 1 to 6. So this is one of the important parameters that you have to mention. So let's save the file and let's do nginx t, and everything is successful. Let's reload the nginx. Okay, so the nginx seems to be working properly. So let's go to temp, and I've created a directory called as test, and we'll use the curl utility and see how the compression has helped. So I'll say curl, let's say curl followed by the HTTP example.com followed by the sshd_config.txt, and save it as says c1.txt. Okay, if I do lslh, this is the size. Now let's run the same command with -h. I'll explain what this is. Let's accept encoding, which should be Gzip, and let's save this as c2.txt. Let's do lslh again, and now you see the difference between two files. So let's see what we have done through both the curl commands. So this was one of first command, and this was the second command. Okay, so in the first command we are trying to curl for sshd_config.txt, and the output is stored in c1.txt file. However, for this particular request, there is no except -encoding header. So the server will not compress the data. However, for the second request, we are explicitly specifying that the curl will support Gzip based compression. So now server will compress the data with Gzip and will send it to the curl utility, and we are storing it as c2.txt. Now if we look into the size between c1 and c2, you'll see the c2 is much more less than that of c1.txt. So from this you can determine that the compression has worked, provided the except-encoding is sent from the curl utility. So by default curl does not send it, and you have to explicitly mention that. Now one more important thing that you can mention in the NGINX configuration file is the Gzip compression level. Let's say 9. So Gzip has compression level which starts from 1 to 9. So 1 is the fastest, but the compression level is very less. In 9, the compression ratio is great, but it takes lot of computational power to compress that much amount of data. So ideally in server you should select between 1 to 9. So a lot of people select 6, which is ideal to them. Many people select 9, provided you have enough amount of computational resources to compress that much amount of data. So this is it about the compression and decompression as far as the NGINX is concerned. So I hope this has been useful for you, and I'd like to thank you for viewing. Welcome back to the Knowledge Portal video series. So today we are going to talk about a very interesting topic called as image hot linking and HTTP referrer header. So before we go and understand on how to implement image hot linking, let's see on why is it required. So let's say you have a website. So let's say this is a.com and this is a website. Now one day you post a blog on your website and suddenly the website or the blog has become very famous and lots of users are visiting it. So in internet there is a tendency that if there is a very famous blog, lot of other websites will copy paste the same contents of that blog onto their own server. So for our example, we have 3 sites. This is site 1, this is site 2, and this is site 3. Now all of these sites have copy pasted the contents from your blog onto their own websites. Now generally if we talk about blogs, there are 2 major components of it. One is the textual information and one is the images file. So let us understand on what happens once a user visits a website or the site which has copied your content. So this is a user. Now user was searching something on Google, and now as so many websites has copied your contents, some of the website actually came up on the Google search engines. So the user clicks on this link and the site will give the response back to the user, which is a blog. So the blog has textual information as well as an image file. So generally what happens is most of the websites, they actually store the textual information on the server itself. However, as far as image file is concerned, they still reference it back to the originating server from where they had copied the contents from. So whenever a user opens this particular website, it can retrieve the text from the server itself. However, the image on the backend is retrieved from the original website. So during this time there is a header called as a HTTP referrer header which comes into picture. So let's take an example for that. So these are 2 websites. I'll say a.com and b.com. b.com basically has copied the contents from a.com. So the image file, it is still referencing to the a.com. So there is an image file over here. And the user visits b.com and it gets the response back with the text and image. Now the text portion is basically from this server itself. So this is where the text information is there. However, the image contents are basically retrieved from the originating server. Now whenever b.com tries to retrieve an image from the originating server, there is a header called as referrer, and in this header there will be the name of the website from which the request is coming from. So it will be b.com. So basically this HTTP header will help A.com know that the request is actually coming from B.com. So let me give you an example on how exactly this works. So I'll open the log files and let's see what it means. So I'll open server A.com and this is a simple website. So here we have the text information and there is an image. So if we go to view source, we can see that text information is stored in the server itself. However, for the image, it is referencing to some other website itself, which is serverb.com/seeds.jpg. So this image is not stored in the server A. It is retrieving it from some other server itself. So if we look into the log file, let me close this and let's refresh this. Okay, let's go to the log file and here you see get/seeds.jpg and this is the referrer field, which is server A.com. So now the NGINX of server B knows that server A.com is asking or is fetching seeds.jpg file. So there are two important reasons why referrer field is important. One is that the system administrator can know from where the request is coming from. So you can also determine from where the clients are basically coming from. So let's say if you post your website link on YouTube and if you want to see how many people are coming to your website from youtube.com, you can search based on the header field and you can determine the exact number of clients that are coming. Now a lot of time things happen that people copy paste the contents of your website onto their own blogs, and you do not want that, because let's say if this server A.com gets 1000 requests, server B.com, which is hosting this particular image, will also get 1000 requests because the image has to be loaded. So basically this is something like stealing of bandwidth as well as stealing of resources. So many times lot of bloggers or system administrators do not allow this referencing. So let's see on how we can do that. Or this is also called as image hot linking. So I'll show you how it's done. Then it will be much more clearer. So I have uncommented. I had commented out image hot linking. Let me uncomment it. Let's save. Let's reload the NGINX and let's open the tail again. Now what basically has happened is I have enabled image hot linking. So that means that the server B will not respond to any request which comes from server A.com as far as image files are concerned. So basically if I refresh now, the image would not come. So let me refresh it now. And you see the image file is blocked. So if I go to the log files, you see the server B.com got a request which was get seeds.jpg from server A, and it gave a 403. So let's see on why exactly it is doing so. So opening the configuration file again. So these are the directives which is actually blocking it. So location is JPEG, PNG or GIF. So for any image file, if valid referers, so this is a directive, if valid referers directive is none, blocked, serverb.com or any subdomain within serverb.com, then allow, otherwise return 403. So this means, let me open the log file again. So this means if referrer, so this is valid underscore referrer field, if valid underscore referrer field contains none, blocked or serverb.com, then you can allow this particular query, otherwise give a 403 back. So this is one of the ways in which you can actually protect your resources to be copied or your image files to be copied from your server to other server. Now also remember, if you have this kind of a configuration, then Google or Bing or any search engine site which tries to retrieve the images, it will not be able to retrieve it. So one of the idle field that you can add, it depends upon the requirements that you have. You should also add maybe google.com or maybe bing.com that should be allowed to open the images or give a reference to your images. So this is it about the HTTP referrers and image hot linking. And since this video is bit short, let me just explain you one more thing. So here you see it is actually showing the referrer information. So if I go to the log configuration file of Nginx, in the log format you see there is a HTTP referrer variable. So this is one of the reasons why you can see the HTTP referrer in the log file. So if you remove this, basically the log file will not contain the HTTP referrer information. So this is it about this video. I hope this has been informative for you and I'd like to thank you for viewing. In the last modules, we were talking about the content negotiation in the HTTP protocol and how the quality parameter helps client decide what is the content that it wants. So continuing with that, today we'll be talking about the accept and the content language headers in the HTTP protocol. So by the name itself, accept language header tells that it basically is used to determine on what is the language that client prefers within the response. So we have already seen this example where in the accept language, there are 3 languages over here and each of the languages associated with a queue parameter. So the first preference is the Danish. Second preference becomes British English because it has score of 0.8 and the last preference is 0.7. So accept language header is very useful in a website which has multiple languages. So let's see on how it will help us. So let's say this is a server which is example.com which has 2 variants. One is English for English users and one is Japanese for Japanese users. So how will example.com server determine on which page to serve? So during this time the accept language header comes into play. So if the accept language header is JA, which stands for Japanese, then the server will serve the Japanese version of the page. However, it is EN, which is English, then the server will serve the English version of the page. So the server has to know, or it has to extract a value from the accept language header, which the client's browser will send along with the page. Now there is one more important header called as content language, which basically determines the language of the body for the intended audience. Please note that it is not saying that the language of the message body. It says language of the message body for the intended audience. So there is difference. So let's take a simple example where the content language header says EN. So what this basically determines is that the body is specific for intended audience who understands English. So if I give you a day-to-day example, let's say a travel guide for China. So if a person is visiting a China, there is a travel website with a travel guide. Now, the travel guide is intended for English audience or the people who understands English. However, the document also contains basic Chinese sentences that can help people in day-to-day communication in local languages. So during that time, the document contains both English as well as Chinese-based characters. However, it is specifically for people who understands English. So during that time, the content language becomes EN. Although it has Chinese characters, still as it is specific for English-based audience, the content language will be EN. So as we're talking about the multi-language website, let me show you an example on how it works along with the except language headers. So I have a server, and if I do a curl, let me show you curl followed by header. Say header that I want is except language. Say my preference is EN, which is English, followed by the name of the website. Say example.com/hi.html. And the contents are, this is English version of the website. So now let's modify the header from EN to JA. So JA stands for Japanese. And now you see, this is a Japanese version of the website. And this is one of the reasons why the except language header instructs the server on what type of language it would prefer in the response. Now again, it is very important to know the except language followed by EN or JA is specified in the browser. So by default, if you are downloading Chrome or Firefox in the European or maybe even in India, then by default the except language is EN. However, for other countries, the except language might differ in the browsers. So this is something that you can always change depending upon your requirement. So this is it about the basics of except language and content language headers in the HTTP protocol. So I hope this video has been informative for you, and I'd like to thank you for viewing. Welcome back to the Knowledge Portal video series. Today we are going to talk about one of the most optimal way of designing and implementing a system, which is based off modular architecture. Let's understand on what it means. Now, if we take a very simple definition, modular development is a process of developing software modules individually. Now, if we take a simple example to understand, let's take an example of a car. Now, car by itself is a very big product. So generally, developing the whole parts together is not a very optimal solution. So what generally happens over here is each of the components of a car is divided into a separate module, and each of these modules are being developed and designed by different teams. Now once all the modules are designed and manufactured together in a factory, they are brought together and fitted accordingly, and thus we get a full-fledged car. And this approach is generally used for most of the product designing. Now if we take a look at the NGINX also, NGINX is also following a modular based architecture where there are different features of NGINX which are based upon modules, These modules are being designed and implemented differently by different teams, and together they come together to form a full-fledged NGINX web server. Now, if we talk about NGINX, the modules that are available, it can be possible that these modules are external. That means different companies are designing these particular modules, but we can together bring those modules and have a wonderful NGINX web server. Now let's take an example on how exactly this is done. So I'll go to my web browser first, and let me say NGINX module, and let's go and open the first two tabs. If we scroll a bit down, NGINX modules, so it is first classified as core functionality, which is the core functionality of NGINX, and then the additional functionality is being added with the help of modules. So we have GeoIP, Gzip module, which is used for compression related. We have image modules, we have memcache module, which is used for caching related functionality, etc. Now there are also various third-party modules. Third-party modules are the modules which are not being designed by NGINX but are being done by the third party. Now one of the advantages of modular based architecture is we can actually define on which modules do we want and which modules we do not want. So if we take an example that in our NGINX web server, we only want the first 5 modules. Rest modules we do not want. And this is something that we will be able to do if a software is based on modular architecture. Now, I am connected to my web server. So the connection got disconnected, and let me try to connect back in. Okay, so I am connected. So one of the ways in which you can find which of the modules are present in your current NGINX installation is via NGINX-V, and it will basically show you the modules which are available as well as the various configuration option. So if we look over here, we have HTTP image filter module. We also have a GeoIP module which is used to block visitors based on countries, etc. We also have a Gzip module which is used for compression, and we have substatus module and so many other things. So essentially our web server is based on multiple modules, and this is what makes our modular architecture great. Now if we do not want a particular module, this is also something that we can define during the time of compilation. Now as we have installed the NGINX via yum, there are predetermined or predefined set of modules that come pre-installed along with the NGINX web server. We will be looking into how we can compile our own NGINX from source, where we can define our custom modules as well. Now talking about modular architecture, let me give you a few more examples. So let's take an example of Apache. So if I go to etc httpd, I also have Apache installed over here, and if we see over here, there is a directory called modules. So if I go to the modules and if I do ls, you will see there are so many modules that are installed along with the Apache server. So each of these modules have a own different functionality. So if we take an example where we have mod_auth_LDAP, so this module is basically used for authenticating users via LDAP directory server. If I'll give you one more example of modular based architecture, even Linux is based upon modular architecture. So if I do a ls mod, it will actually show you what are the modules that are loaded within the Linux. So we have IPv6 module, and we have ext4 module, and so many other modules which are loaded. So this is it about modular architecture, and why modules are important. We will be looking into how we can install the own version of Nginx with the modules that we want in the next lecture. I hope this basic lecture has been informative for you, and I'd like to thank you for viewing. Hi, and welcome back to the Knowledge Portal video series. In the last lecture, we looked into the basics of the modular architecture. We also looked into how we can see what are the modules that are compiled with the existing Nginx installation. Now, till now, we have been working with the Nginx which we had installed via yum. So that was pretty automatic installation where we are just putting one command. In today's lecture, we'll actually install Nginx from the source so that we can have much more greater flexibility on the amount of modules that will be installed along with our Nginx based instances. Now let's look into how we will be able to do that. Now I'll go to my browser. Let's say Nginx download. I'll click on the second link and it is giving me lot of options from the Nginx 0.1.0 to the latest one. What we'll do is we'll select 1.9.0, which is pretty latest. Now there are two files generally. One is tar.gz and one is .zip. Zip is basically for Windows based instances. For Linux based instances, there will be tar.gz. So I'll right click on it. I'll copy link location. I'll go to my server and let's go to user src and let's copy the paste the link and I'll do a wget. Okay, so this is the file which got downloaded. I'll extract this file with tar xzvf nginx.tar.gz. Okay, now we have this particular folder nginx 1.9.0. I'll go here and this is where we'll be doing all the configuration and compiling. Now before we do that, there is one more important thing that you should know, that before you can actually compile, you will need certain packages which will help you during the compilation process. So I have the name of the packages listed in the notepad file. I'll be also posting this in the website so that it will become easier for you to also install. Now I have installed these packages. You should also do that because without this you'll not be able to compile your Nginx instance. Now if I do ls over here, there is a script called as configure. If I do a less on configure, let me actually open it with nano, and this is actually the shell script which we'll be using to configure various HTTP modules and parameters. Now if I say configure colon help, it will basically tell us on how we can configure this particular Nginx from source. Now the things that are important to us are the first few sections. I'll just copy these sections to a notepad file. And let me actually paste this. Now what this basically means is when we want to install Nginx from the source, we will need to define some kind of a variable to this particular modules. So let's write. So I say configure. The first option is prefix. I'll say prefix. Oops. Okay. Let me start again. I say configure followed by prefix is equal to path. So in the Right hand section, it is saying set the installation prefix. So this basically means the installation path. I'll say etc nginx. So this is where the nginx configuration and everything should lie. The second option is sbin hyphen path. This is where the system binary for nginx should lie. So I'll say user sbin nginx. The third is the conf path. So I'll say conf hyphen path. This is the path of the Nginx configuration as defined over here. So it should be ideally etc nginx nginx.conf. This is what we have been working since ever. The fourth is error hyphen log hyphen path. This is where the error log should be. We can say var log nginx error.log. Then we have user. We can, I'll say user is equal to nginx and hyphen hyphen group is equal to nginx itself. We missed one more option, which is the PID. I'll specify here PID hyphen path is equal to, let's say, var run nginx.pid. So this is where the master process PID will be stored. We have already looked into it in the earlier lectures. Now let me actually copy paste this entire configuration and let's paste this over here. There is one more thing that is important, is that during the compilation itself, we will have to specify what are the modules that we want our Nginx to be installed with. If we do not specify anything, then Nginx will have its default core modules, but the extended functionality related to compression or video streaming, etc., will not be present. So let's take one simple module. I'll copy this. So there are a lot of modules which are available over here. There are also a lot of third-party modules which will not be listed in this particular list, but you can get it from the internet. For our installation, we'll just take one module, which is the Gzip module, which is used for compression, and I'll paste it over here. So just to summarize, from the configure to this particular parameter, these are the parameters which will be used along with the Nginx. After defining the parameters, we are also defining the modules that will be used along with the Nginx instance. Now I'll just press enter over here, and it seems we have done some mistake. Let's clear the screen and see what we have done. Hyphen hyphen config path etc nginx nginx.conf. So this seems to be proper. Let's just verify it once. Let's see what exactly the error is. Invalid option config path etc nginx nginx.conf. So let me just do a configure hyphen hyphen help. Let's go up and see the, which is conf hyphen path, and we have actually mentioned config hyphen path. So this is what the error was telling about. So let's just modify this to conf hyphen path. Okay, so now it should have ideally made a file called as makefile. So this is the makefile over here, and this is what we'll use to install the Nginx. So I'll run make, which will be used for compilation. It might take few minutes to compile. It really depends on the amount of modules that you use. during the compilation. However, for our purposes, we have minimal amount of modules, so it should not take much time. So we are done over here, and the last step is make install. And we are done. So if we go to etc nginx, and you will see all of these files are installed. Now one more thing that you will have to do is make sure that you have a user nginx, because during the configuration we had mentioned the user as nginx. So here the user as nginx and group as nginx. I already had these users, so I did not do it. But if you have a fresh installed machine where you are compiling from source, then don't forget to add user and group as nginx. Now one more thing that you will have to do is you will have to create a init.d script. So if I run service nginx status, you will not find anything because there is no init.d script available. So I have the path from which we can get the init script. I'll just copy paste this link, and what it will essentially do is it will create the nginx script within the etc init.d directory. I'll have to make this executable, say init.d nginx. And now if I check service nginx status, ideally it should return some output which is saying running. Let's verify by saying service nginx restart, and everything seems to be working properly. Now if I mention nginx-v over here, it should ideally show only one module installed, and this is the exact module that we had defined. One more thing that you might want to do is just check if your nginx is working properly. So if I do just curl on 127.0.0.1, it should ideally say that the nginx web server is successfully installed. So this is it about installing the nginx from the source. We have just included one module, but in the production based nginx instances, there will be a lot of modules that you will have to install. This is it about this video. I hope this has been informative for you, and I'd like to thank you for viewing.
Welcome to the Knowledge Portal video series. Today we are going to talk about one of the most awaited topics for the web security, which is the Web Application Firewall. Now generally when we talk about a web application, then web application in a very simple term is a software application which resides on a web server and which runs on a client browser. Now if we take a look at a very simple web application, then login form can be considered as one. Now this is an example.com domain where there is a login form which interacts with a database. Now whenever user wants to enter a website, user has to enter a username and password which will be validated from the database, and then the access is given. Then essentially the login form becomes a simple application which runs on a web browser. Now generally the question comes is how can you protect a web application from hackers? Now looking at a simple firewall based scenario where you have a firewall at the perimeter of your server. But if we talk about traditional based firewall, then firewall can generally check the destination IP as well as destination port as well as the source IP. It can also do rate limiting kind of a stuff. But a traditional firewall cannot look into a HTTP based packets. Now generally as this is a web application, it is susceptible to lot of web application based hacking attempts, which a traditional firewall cannot detect. Now, if we take a look at a firewall versus a web application firewall, then traditionally the attacks which are non-HTTP related, you can say something, let's say for example, brute forcing, those kind of a things can be protected with a firewall. Now, firewall can protect those kind of attacks. However, here if we talk about HTTP based attack, then a traditional firewall won't be able to protect it because it only mostly checks for the source IP as well as the destination port. It has nothing to do with the data related sections. And this is where the web application firewall comes into the picture. Now, WAF or web application firewall typically looks into the HTTP based vectors to determine if the packet that has come is related to a hacking related activity or if it is related to the legitimate use. Now, generally in modern scenario, web applications are the weakest link. Even though if you have a very strong firewall or a perimeter security, if your web application is not secure, then your server will be compromised. And most of the compromised attempts that have been happening, even for enterprises, is because of the web application related vulnerabilities. And this is one of the reasons why having a web application firewall and having a strong web application without much vulnerabilities is one of the critical requirements in today's enterprise level security is concerned. Now, generally, if we talk about OWASP top 10, then mostly these are the web application attacks which are being targeted towards most of the web application related to enterprise as well as the SMBs. Now, let me show you an example on how a web application firewall should look like or is looking like, as well as the on how many web application related hacking attempts that actually happens in day-to-day activity. So if I do a PWD, I am in varlog nginx, and let me actually do a error less on error log 1 with grep. I'll say color learning, and this all of these are potential web application related attacks which are being targeted at our servers. So if you look at this is just the data of few days, and there are so many attacks that are being targeted at the web application that are running at our servers. So this is just attacks that have been targeted towards small enterprises, but if you talk about bigger enterprises, then you literally have tens of thousands of attacks that takes place every single day. And this is one of the reasons why you should actually protect your web application from such attacks. And one of the reasons to do is through a web application firewall. Now we'll be learning on how we can implement a web application firewall on Nginx in the next lecture. I hope you got the basic scenario on why a WAF is important in today's scenario. I hope this has been informative for you, and I'd like to thank you for viewing. Welcome to the Knowledge Portal video series. In the last lecture, we looked into what a web application firewall is and why is it necessary. We also looked into how we can manually compile Nginx from source. Now today we'll be installing one of the web application firewall called as Gzip along with the Nginx. Now we'll have to do that by compiling Nginx from the source itself. Now if I go to the browser, this is a Gzip GitHub page. So Gzip basically is an open source WAF for Nginx. Now in order to install Gzip, we will have to compile Nginx from the source itself. Now we have already seen on how we can do it from the source. So let's start on doing that. So I'll go to user local source. This is where we'll be compiling our Nginx package. Now I have a bit of documentation so it becomes a bit quicker. Otherwise it will take a lot of time. Now the first thing that we'll do is we'll download the Nginx. So here it is Nginx 1.9.5.tars.gz. You can download it from the Nginx website itself, or I'll also be posting the documentation on how to do it. Now we have downloaded the Nginx package. So let's untar it. So I'll say tar xvzf
and Nginx. Okay, so now we have Nginx 1.9.5 folder. Second thing that will be necessary is we have to download the Gzip package itself, because Gzip is a WAF. Basically, Gzip acts as a third-party module for Nginx. So we'll be installing it along with the module directives itself. So let me download the Gzip package and let's unzip it. Okay. So essentially now we have two directories. One is Nginx and one is Gzip. Now before we start compiling, again we have already seen this in the previous lecture as well. You need to have a proper modules for compilation as well as related to GeoIP if you are installing it. PCRE Devel is also a very important module. If you do not have this, you will not be able to compile Nginx from the source. Now I already have these packages. In case you don't have, do go ahead and install it. Now if I do a ls, there are two directories over here. One is Gzip and one is Nginx. Let's go to the Nginx directory, and this is the configure script which we will be used to set the various directives. Now again, as we have seen in the last previous lecture as well on compiling Nginx from the source, we run the configure script. The prefix is where the Nginx configuration will lie. This is the system binary path. This is the configuration path where the Nginx conf lies. And in the add module parameter, the first module that we are adding is the Gzip, which is the firewall module. Along with that, we are adding various other modules. Now, these is just a temporary list, but if you are in production environment, there will be a lot of different modules that you will have to add. But just for our lab purposes, we'll be adding just minimal set of modules. Now I'll just copy this and I'll paste it over here. And let's run this. Okay. Now essentially if I do a ls over here, then a make file will be created. Let's do a make. This will not take much time since we do not have a lot of modules. Okay, and the last step is make install. So finally we are done. So essentially if we go to etc nginx directory, we should have the configuration related files. Now we have already seen the init.d script that we have to put in the etc init.d directory. Now I have not removed the script from the server. So if we go to etc init.d, let's do on nginx. Now I have not removed this script. We had already seen on how to put this script inside the init.d folder in the previous lectures. So let's do a service nginx status, and essentially it is saying service nginx is running. So let's just restart it. Okay, so finally we are up and running with nginx. But what we have done till now is we have just configured we have just installed the Gzip WAF module along with nginx. So now comes the time for configuring the Gzip module. So let's go to user local source, and essentially in the Gzip-master directory there is a folder called as Gzip_config. So let's take this particular file, and inside this there are certain rules. So if I open gzip.co.rules, so these are rules related to SQL injection, We also have rules related to directory traversal, cross-site scripting, etc. Now these rules will be used for checking the HTTP request URI to check if the request that is coming is related to hacking activity or not. We will be copying this particular rule file inside the etc nginx directory. So let's go back to the etc nginx directory, and this is where our rule file is basically stored. Now we'll have to tell the Nginx to see the rules when it checks for the requests. So for that, we'll open the nginx.configuration and we'll put a include directive. I'll say include etc nginx naxi underscore core dot rules. I hope the path is correct and I am not making any mistakes. So let's verify it once, and yes, it is correct. Now there is one more thing that you will have to do, is to configure the server section. Now we have included the Nagzi rules, but we also have to include things in the server location. So what I'll do, let's create a sample server block over here. I'll say server. Let me put listen 80. Server name would be example.com, and for this particular configuration, the location, let's say the root is var www html and index is index.html. So just stay with me on this and we'll look into why are we doing this. So if I open one more text file, let's just copy this and I'll say naxi.rules and I'll paste it over here. Now what we'll be essentially doing is we'll use an include directive and we'll post this particular file within the server block. So what essentially will happen is server block will have this particular naxi.rules file, which is basically telling for a particular request URI, do check that URI and the contents against this particular rules related to SQL, directory traversal or cross-site scripting, etc. One more thing that this particular file is doing is denied URL. So if this particular rules are matched, then this is the text file that a Naxi should show. You can even show a 403 or something like that. Now let me save this file and let's go back to the nginx.conf and let me go a bit up. And I'll say include etc nginx naxi.rules. This is it. Let's do nginx-t and everything is successful. Let's do a nginx reload. Perfect. So essentially our WAF is configured. Now question is how we'll be able to test it. So if we look into here, basically it says that, for example, these are the things that are not supposed to be a part of URI. So what we'll do is we'll put this as a part of URI and check if the Naxi can actually detect this particular behavior. So what we'll do, let's go to the log file. I'll go var log nginx and essentially there are two log files. Let me do a tail f on both of them. So essentially there is no log file over here. Now let me go to example.com, and this will essentially not work because what we have done is uh, let's open the etc nginx.conf. What we had done here is we had defined the root, which is var html, but we have not actually created this particular directory. So let me actually create this directory var html. Let me go over here and let's create a sample file index.html, and let's say hi. This is it. And one more thing that we'll have to do is essentially if we go to etc nginx and naxi.rules. So here there is a request denied.txt. Now essentially we'll have to create this particular text file within var html because this is our root location. So if I, let's say, not so fast. Okay. Now let's reload nginx. Great. So let's come back to the log file where we were, nginx. Let's do a tail on both the log files. So essentially if I open example.com, it should say hi, and if we look into the log as well, it is saying hi. Now let's try to include some characters which a WAF can easily detect. So let's say I put, say, a is equal to person3c. Person3c is a ASCII equivalent of the open curly brackets, and essentially what this should do is this should trigger a WAF related event. So if I put a enter, and here you see it is giving the output as well. But here if we look into the log file, within the error log file, the Naxi is giving us that someone is trying to do a XSS related activity on your website. So it is saying what kind of attack a person is trying to do. It is also showing the IP address from which the request is coming. It is also shows the request related URI. But if we note that Naxi has actually not blocked this request, the reason is because by default the Naxi works on learning mode. So it will not block, but it will just show you various events which it thinks that it might be an attack. Now, if we want to block such kind of attacks, then it's simple. Go to Naxi rules, and here the first directive is learning mode. Let's disable this learning mode, and let's reload the nginx. If I refresh this page, then it should essentially say not found, or it can essentially give you the custom message that you want to have over here. So this is it about configuring the basic Naxi web application firewall. I hope this has been informative for you, and I'll also be posting the documentation on how you can do this in your own server. This is it about this lecture, and thank you for watching. One more thing that I wanted to show, I actually forgot in the last lecture, is that essentially a 404 not found should not come. The reason for this is because in the Naxi.rules, so if I go to Nginx, Naxi.rules, we have actually defined over here that if there is any request that matches one of these rules, request denied.txt should be shown. So essentially the reason why it is saying not found is because Nginx is not able to find this particular request denied.txt file. So if I do a tail, let's go to var log nginx, and let's do a tail on the logs, then essentially if we look over here, then it is not able to find this particular directory. It is saying failed no such file or directory. var HTML was essentially our root location. So let's go to var HTML, and essentially there is no such file. Let's create this file. Actually we had already created, but it seems that we did it in some different directory. So I'll say not so fast, and I'll save this. Now essentially if I reload this page, then it should show not so fast. So this is where you can actually post your custom message for any rule that matches the particular web application firewall. So this is it about this lecture. I hope this has been informative for you, and again I'll urge you, try this out. Nginx is a very nice web application firewall for Nginx. This is it. I hope this has been informative for you, and I'd like to thank you for viewing.
Hi again, welcome to the Knowledge Portal video series. I am Zine, and in this module we'll be talking about asymmetric encryption. So I'm pretty confident that you have gone through all the exercises of symmetric key encryption, and now you are well versed with what and why symmetric key encryption is used. So one of the topics that we had discussed earlier in the limitations of the symmetric key encryption is how we will transfer the key between client and host. So I'm sure that my diagram was good, but this time I thought that I'll make my diagram a much more better one. So talking about the limitation of the symmetric key. So this is the document that we want to send from sender A to sender B. So we encrypt this document with this symmetric key, and this is the encrypted document that we send over the network, and same document is received on the server side. Now if the network is being actively sniffed by a hacker, that means that this document is also passed over to the hacker's computer. Now as this document is encrypted, nor the server nor the hacker will be able to decrypt it unless and until they get the encryption key. Now the problem is, how will you send this encryption key? One of the ways that you can do is you can send it over the same communication channel, right? The problem with this is server will be able to decrypt the document, but even hacker will be able to decrypt the document because hacker is actively sniffing the network. So what could be the ideal solution for this? And this is one of the reasons why asymmetric key encryption was introduced. So let's see what asymmetric key encryption is and how it works. So I'll erase all the tab drawings and let's see how it goes. So in asymmetric key encryption, there are two keys opposed to symmetric key encryption. As we see in symmetric encryption, there is only one key which is used for both encryption as well as decryption. But in asymmetric, there are two keys. One is called public key and one is called private key. And together they form one chain. This is one chain. So if I have this document and if I encrypt this document with a public key, okay? So this document is encrypted with my public key. Now if I want to decrypt this document, it can be only and only be decrypted with the corresponding private key. So if I want to decrypt this document, it can be only be decrypted with a corresponded private key. So say I encrypted this document with a public key. Now if I try to decrypt this document with the same public key, it won't work. It won't be able to decrypt it. Similarly, let's say I encrypt this document with a private key. So this is a private key through which I have encrypted the document. Now in order to decrypt the document, I can only decrypt with the corresponding public key. Simple? I hope so. Because when I was learning asymmetric key encryption during my college times, I was like, asymmetric, symmetric keys, public, private, what is this? I was like full confused. But it was during the initial time. But the concept is very, very simple. Remember two things. One chain is one public key and one private key. Data encrypted from a public key can only be decrypted with a corresponding private key. Similarly, data encrypted with a private key can only be decrypted with a corresponding public key. Now, coming back to the topic, let's see how asymmetric will help us. I select a new document so that I can draw better. Okay, so let's say how asymmetric will help us. So let's say you are into a server which requires authentication. So for authentication, we generally use email ID plus password, right? Simple. For authentication, we use email ID plus password. If email ID and password is right, server will allow you to log in. Now this is a very simple way of authentication. Now there is a new way of authentication which have been used by all the modern companies, that is called key-based authentication. So key-based authentication is basically asymmetric key encryption. So let's see how it goes. So let's say this is a server and this is my computer. Now I have my public key in my server. So this is a public key and I have my private key in my computer. So how will I authenticate to this server without password? So it works as a replacement to a password. So let's see how it goes. So if I want to authenticate to this server, first of all, I'll have to give the username. So let's say username is Z. Username is Z, and instead of password, I need to provide my key. So as this is not a symmetric key, there will be public and private key. So here we have public, this is public key and this is private key. So how will server know that I am the genuine user and not a hacker? So let's see the first step. So first step server will do, it will prepare a simple question saying 2 plus 2 is equal to question mark, right? And it will encrypt this question with the public key. Simple. So server prepared a question saying 2 plus 2. It encrypted this question with a public key. Now we know that this encrypted question can only be decrypted with a corresponding private key, which I have. So once I receive this question, I'll decrypt the question with my private key and I'll get something like 2 plus 2 is equal to question mark. So I know 2 plus 2 is equal to 4, right? So I'll write 4 and I'll encrypt this answer with my private key. With my private key, and I'll send it back to the server. Now server will receive this 4. Server receives it 4, which is there in encrypted format. Now what was the second rule? Any file which is encrypted with a private key can only be decrypted with a corresponding public key. So server will use this public key to decrypt this 4. It will compare this question along with the answer, and if the answer matches, it means authentication is successful and server will give me the access. So in this way, we can actually eliminate the password based authentication.
Now the problem with password based authentication is, if you know my password, you will be also be able to log into the server. But in key based authentication, even if you know the password, without the key you will not be able to log in, right? You need a key to log in, and key are not small, they are very big. So in the next module we'll actually see on how we can log into the server based on public and private keys. So we'll be generating our own public and private keys, and we'll be putting a public key on the server with private key in my laptop, and I'll try to log into the server with my private key. So I hope this concept has been bit understood. So maybe it is bit confusing right now, but once you actually start doing practicals, you will understand it in much more better way. So I hope this lecture has been useful for you, and I'll see you in the next lecture. Hi again, and welcome back to the crypto module. In this topic, we'll look into HTTPS internal workings. So in the previous module, we looked into the difference between HTTP and HTTPS connection. So now we know HTTP does not use encryption, and this was one of the reasons why we were able to snip the username and password through Wireshark. HTTPS on the other hand uses encryption, and this was the reason why we were not able to snip the traffic from the Wireshark. So coming back to the older problem, where we were discussing about how can we actually transfer this symmetric key over the network in such a way that even if hacker is sniffing the traffic, he will not be able to decrypt the data. And this was where asymmetric key encryption comes into play. We saw basics of asymmetric key encryption, where there is one public key and when there is one private key. So let's see how asymmetric key based encryption is used in HTTPS. So for HTTPS, so this is a HTTPS based website. So that means it will have one chain. It will have one chain. So one chain is one public key and one private key, right? So this is my computer which wants to connect to the HTTPS server. So the very first thing that happens is my HTTPS server will send this public key to me. Right? So this public and private key are stored inside the HTTPS server itself. So the first thing is it will send the public key to me. So I have a public key of this HTTPS server. Now I'll generate a random symmetric key. Yeah, so let's say this is my key, and I'll encrypt this key with the public key of server. So let's see what happens. A server has one public key and one private key. When the connection is initiated, server will send me its public key. So now I have the public key. I generate a random symmetric key and I encrypt the symmetric key with the public key of this server, and I send it back to the server side. So considering that even hacker is sniffing into the network, even he'll receive the server's public key as well as the symmetric key which I generated, which is encrypted with the public key of the server. Now, as we know, anything encrypted with a public key can only be decrypted with the corresponding private key. Now, on the server side, as we have this symmetric key generated, server will be able to decrypt the symmetric key. So let's say symmetric key is Motorola. This is one of the simple passphrase, right? Now server will be able to decrypt it with its own, this is private key. So now both the party knows that we have to encrypt the data with this passphrase, which is Motorola, right? Now hacker will not be able to find this because hacker does not have the private key associated with the server, right? So this is one of the functionings of the HTTPS based website. So if I open google.com, let's say I open google.com. If I open on this lock sign, I go to connection and I view the certificate information. I'll go into details. So it is using RSA and it should have its own public key. So here if we see, this is the public key. So this public key is what Google is sending me when I try to connect to google.com. So again, let's revise. When I try to connect to a HTTPS based website, the first thing that happens is the web server will send me its own public key. I randomly generate a symmetric key called Motorola. I encrypt the Motorola with the public key of the server and I send it over the network. Now that encrypted key will only be decrypted by a person which has the corresponding private key, which only server has. So server will decrypt the message with its private key and it will find Motorola. So now both client and server knows that they have to encrypt the data with a passphrase Motorola. So in HTTPS, there is use of both asymmetric key encryption as well as symmetric key encryption. Asymmetric key encryption is only used to transfer the symmetric key from the client to the server and nothing else. Once the key is transferred, then the symmetric key encryption is used. So coming back to the classic problem on the limitation of symmetric key cryptography, this is how asymmetric key cryptography helps over here. So I hope this lecture has been useful for you and I'm seriously waiting for a lot of questions in this topic. So thank you very much for watching.
Welcome back to the Knowledge Portal video series. In today's lecture, we'll look into how we can make use of SSL on our own website along with the NGINX web server. So let's start. Now let's go to the NGINX configuration file. So it is etc nginx conf.d. Now if you have a normal version of Nginx, then essentially when you have downloaded, you will get a ssl.conf inside the conf.d directory. Now if I open ssl.conf, these are the contents which are commented out. So it becomes easier for us to just uncomment and replace the values within the configuration instead of writing this from scratch. If you're using Nginx Plus, then these values are present inside the nginx.conf file itself. Now we already know that we need to generate a certificate that will be used for our website. So let's create a directory called certificates. I'll go inside this directory and let's create our own certificate. In order to do that, we'll make use of OpenSSL library. So I'll use OpenSSL. I'll say X509. I'll just explain you the command that we are writing over here, which is 2048 bit. One will be key out. Let's say it as key dot
and output will be cert.pem. We will also need the expiry date, which can be say 365, and nodes value that will not ask for a key for a private key. So what essentially that we are doing over here is that we are generating a new key with RSA, which is 2048 bit. Now the key will be stored here. So this is basically a private key, and there will also be a certificate that will be generated along with it. Now if I press enter over here, it looks like we have done some problem. Yes, so we have to write a request. Okay, so essentially what it will do is it will ask you for various details, so fill in the details accordingly. It is not mandatory that you, for at least for self-signed certificate, that you provide a correct details. However, if you want to have a certificate issued by a root CA, then you'll need to have a correct details. Organization name, I'll say knowledge portal, I'll say KP. Now common name is basically the host name of your website, which can be example.com, or in my case I'll use zealvora.com. I'll say zealvora.com. Email address you can fill in, and essentially this is done. So if I do a ls over here, there will be two files which will be generated. One is a certificate file and one is the key file. Certificate file essentially contains the details like your organization, where do you reside from, etc., along with the host name. Host name is basically the website name. So we have already entered zealvora.com. It will also contain the public key corresponding to the private key that is generated over here. Now what we'll essentially do is, let's rename this. I'll say cert.pem to final.pem, and let's rename key.pem to final. Say let's make it key.pem itself. Now let's copy both of these files to etc SSL certs. Now if we go to etc SSL certs, then we'll essentially find both of our files over here. Now as we have our certificate and the key, it's time to modify the nginx conf. I go to etc nginx conf.d. Let's open ssl.conf. Now let's comment everything out. If you're using nginx plus, then this section will be inside the nginx.conf itself. Now server name will give zealvora.com. So because we have generated the certificate for this domain name. SSL certificate, this is the certificate that we have generated, which is in etc SSL certs final.pem, and the key is in etc SSL certs key.pem. So essentially we have replaced this value. One more thing that you will have to essentially do is maybe change the root part. So I'll change var www.html. So this is where my website resides, and essentially this is it. Let's do nginx-t and everything is successful. If I do service nginx reload, and everything seems to be working fine. So essentially we have a certificate for our website. So let's go to our browser and let me do https zealvora.com, and here you see it is showing that the connection is untrusted. This is because this is our self-signed certificate. I'll confirm the exception, and I've got a website on. Now the reason why it was showing that error is because we have generated our certificate ourselves. Ideally, if you don't want to see this error, then you have to get your certificate signed by a certificate authority that will basically validate that the information that you have entered, in your certificate, like the organization name, your common name, etc., are perfectly valid. Now, now the question comes is that how can we get our certificate signed? Now what I have done is, if I go over here, let's go to the root certificate. Now the certificate that we have presented over here, .final.pem, ideally you should get it signed from a certificate authority. Now there are many certificate authority that you can go through. One is GeoTrust. So you'll have to actually purchase the SSL certificate. You have to pay some money and you have to send this particular certificate to them, and they will validate the information and they'll sign it for you. Once they sign it for you, they'll send back you the zip file. Ideally, most probably they'll send you the zip file. So it will look something like this. Zealvora. So what I have done, I have generated a certificate and I got it signed from a certificate authority. Once they have signed it, they sent me an email with particular zip file. So if I unzip this, essentially there will be two files over here. One is the certificate. So this is the certificate which is signed by the certificate authority, and second is the ca.bundle which is used for proper compatibility. So essentially in Nginx what you'll have to do is, as there are two files over here, you'll have to combine them into a single certificate file. So what I'll do is, I'll cat the certificate, I'll cat this particular file. I'll also cat the other file that I received from the certificate authority, which is ca.bundle, and I'll post it to say zeal.crt. So essentially what I have is, I have a zeal.crt over here and I have a zeal.key. Now zeal.key is a private key, so this is something that you should not share, and zeal.crt is a signed certificate from a proper certificate authority. So let's do one thing, let's move this, let's copy zeal.crt as well as zeal.key to etc SSL certs. Now let's edit nginx.configuration file and let's modify the values. Say z.crt over here, and here I'll say z.key. Essentially, let me do nginx-t and everything is successful. Let's reload nginx. Great. So essentially now we are using a proper signed certificate. If I'll go to browser once more and let's open https://zealvora.com and let's go to the view certificate. So essentially it seems to be taking the older certificate itself. This might be due to cache. Let's do one thing, let's open some other browser. I'll open Internet Explorer and zealvora.com, and ideally if you see over, it is not showing any exception. That means it is we are using a proper certificate. Now if we go ahead and replace the certificates, and so I'll say, actually I have deleted the older one, so let's bring those older certificates back, which is the final. I'll copy back to the SSL search directory. Oh, it seems to be there. Great. Now let's etc nginx ssl.conf. Let's replace the certificates with a self-signed one, which is final.pem and t.pem. Let's reload Nginx. Essentially, let me close the browser in case there is any session which is running, and let's open the zealvora.com again, and now you see it is showing that there is a problem with this security certificate. That means this certificate is not signed by a trusted CA. So this is it about how can we put the certificate for our own website. Now if you are running a website in intranet, then it's better not to buy a SSL certificate from a CA, because that would be unnecessary spend of money. However, if you have a public based website which is using HTTPS, then you should definitely get it signed from a certificate authority. This is it about this lecture. I hope this has been informative for you, and I'd like to thank you for viewing. Welcome to the Knowledge Portal video series. In the last lecture, we looked into how we can have a self-signed certificate for the NGINX based web server. Today, we are going to talk about SSL termination. Now, if you look at a scenario where you have a reverse proxy and there is an upstream which is application server. Now, generally, if we talk about application server like Tomcat or maybe PHP FPM, they are not very good at handling the SSL based connection. It will actually slow them down. And this is one of the reasons why in the enterprise as well, there is a SSL termination which is done at the reverse proxy itself. Now, in this example, this is a example.com domain where Nginx is acting as a reverse proxy and there is one application server. And we have a SSL based website, which is HTTPS. So generally, web browser calls https.example.com and there is a SSL connection which is established. However, the SSL termination happens at the reverse proxy itself. The SSL does not interfere between the communication of example.com reverse proxy and the application server. So the communication that is taking place between a reverse proxy and application server is still based on plain text. Only the communication between a web browser and the reverse proxy is happening with the SSL. And this is one of the reasons why it is called SSL termination at the reverse proxy. And this is the ideal configuration. Now, many times this is not a very viable solution, specifically if your application server is residing in an environment which is not fully trusted. So in this case, what happens is there are two SSL connection that happens. The first is between a client and a reverse proxy. So here the termination happens at the reverse proxy side. However, the communication between reverse proxy and the application server again happens with a second SSL based connection. So essentially what is happening over here is there are two SSL connections, one between client and reverse proxy, and the second is between reverse proxy and the application server. Now, generally, if we talk about enterprise, they will try to avoid the second SSL based connection because it actually slows down the overall performance. Now, whenever you have your application server on the cloud, which you really don't trust, then having a SSL termination to the upstream is a mandatory requirement, specifically if you are following a PCI based compliance. Now, I have a website called as zealvora.com, which is basically running on a reverse proxy. So I'll show you on how exactly it works. Now I'm connected to my production server. So if I do a vim on zealvora _ssl.conf, so essentially this is my configuration file. Now the server name is zealvora.com. It's listening on 443. these are my certificate. So this is my certificate and this is my key. It is doing a proxy pass to the upstream server over here, and this is essentially what is happening. So this is my NGINX acting as a reverse proxy. So this configuration is essentially stored in the NGINX reverse proxy. So NGINX will itself terminate the SSL on the same server. However, as far as proxy pass is concerned, it is still using the HTTP based connection. Now, if I open HTTPS, say zealvora.com, essentially the website is loading and the SSL is getting terminated at the reverse proxy itself. Now, if we want to know more about this particular connection, let's go to more information. Let's view the certificate. Now, in the common name, it is saying that this certificate is issued by Komodo and issued to it's zealvora.com. If we go into the details, here there are multiple intermediary software. So if we look, first hierarchy starts with the address external CA root, followed by Komodo, RSA, and there is one more over here. And this is one of the reasons why the ca.bundle was given by the Komodo itself. Because traditionally a web browser will not trust these certificates. It will only trust the root certificate. And this is one of the reasons why the CA bundle was essentially introduced. Now, one more important thing to know is if I just go to https://zealvora.com, by default the browser will only show secure content. Now, I have not configured my WordPress to work on full SSL based connection. So essentially I need to unblock it. I'll say disable protection on this page, and essentially now it will show the whole page by itself, because there are many requests which are still going with the HTTP connection, and browser, when we open HTTPS, it will not load the HTTP based requests. So this is it about the SSL termination. The only thing I wanted to show here is that if you are having a reverse proxy environment, then you need to write your SSL termination at the reverse proxy based nginx.conf. So this is it. I hope this has been informative for you, and I'd like to thank you for viewing.